Python is the world's most popular programming language, and that is for a reason. You can use it to make games and apps, run databases, build robots, and create artificial intelligence with ease. The example you see right now is an AI program that tracks my face. It took me about 5 minutes to write. And that is a general theme for Python. It is incredibly easy to learn while also giving you a ton of power for more advanced functionalities. And all of this you're going to learn in this video, starting from scratch. I am assuming that you have never used any kind of programming language before, so we are starting all the way from the bottom. And over the next 10 or so hours, you are going to learn basically everything you need to know about Python. And after that, you can learn pretty much whatever you want in the language, and it should be fairly straightforward. As a matter of fact, this video is part of a larger paid course, and this one is going to use all of the stuff you're learning about Python and uses it to make 4 games. And that way, you are learning in much more detail how to actually use all of this in practice. So check this one out if you're interested. Although this entire video works by itself and you can use it for any other non-gaming purpose as well. It's a general introduction to Python. Before we start to program, we need to cover some fundamentals. First of all, if you are just getting into programming, you are probably overwhelmed by choice. Besides Python, you could learn a few hundred other programming languages. Some have clear names, like HTML5 or Java, while others are much more difficult to separate, like C, C#, and C++. So what makes each language different and where should you start? Also, how does Python compare to these other languages? One good way to separate these languages is by using 2 axes. The first one is about the language being made for a specific purpose, or if it is more open-ended. For example, SQL and R are programming languages for highly specific purposes. Databases and data analysis respectively. On the other side, you have languages like Python that can also analyze data and run databases, but can do a lot more besides that. This flexibility is one of the reasons why Python is so popular. It just can do a ton of different things. Although this line is not static. The best example for that is HTML. Initially, it was purely a language to make websites. It was very much designed for a single purpose. However, over time, people kept on adding more to it, and nowadays you can make apps and games with HTML. It became much more flexible, and that is the main reason why modern websites are as powerful as they are. The other axis is the level of abstraction. Now, when I say a language is more abstract than another, I don't mean to say it's more complex. Instead, abstraction refers to how far removed a language is from physical computer hardware. Let's use HTML again. To see a website written in HTML5, you first need a browser like Chrome or Safari. That browser in turn runs on an operating system, and only that operating system has access to actual physical computer hardware. There is a huge distance between the HTML code and the computer it runs on. That means HTML is a very abstract language. This, however, does not mean that HTML is more difficult than a less abstract language. Quite the opposite, actually. In broad terms, the more abstract a language is, the easier it is to use. That is because a less abstract language needs to work with computer hardware. It needs to be very specific about memory management. You sometimes have to write for different kinds of computer hardware, and generally it is very easy to break things. Now, in this axis, Python, like HTML, is a very abstract language. In fact, Python itself was created using another programming languages. That one is called C. And this language is much less abstract. Generally, in the bottom right of this graph, you have all of the C languages, like C, C#, and C++. You also have Java down there. The differences between them are mostly technical, and you don't really have to worry about them, at least for now. That being said, C# was only created because Microsoft didn't want to pay license fees to the creators of Java. These 2 languages are very similar. So there can be a ton of overlap between these different languages. They are not entirely unique. Now, when you are just getting started, you want to begin in the top right of this graph with more abstract, general-purpose languages. These are easy to learn, work everywhere, there's a huge community for support and resources, and you can use them for a huge variety of projects. What you also want to be aware of is that all programming languages are somewhat similar. If you know Python, for example, you can learn C or SQL much more easily. This is actually a really common pattern. People start programming in Python and then migrate to another language. Python was actually designed to be a tool to learn programming itself, and it just happened to expand over time to become a really popular language by itself. Although that doesn't mean that you couldn't stick with Python. Especially for data science, think of artificial intelligence, databases, and data analysis, Python very often is the default choice. And these are fields where you can earn a lot of money. It is totally fine to stick with Python by itself entirely for your entire career. Lots of people do that. But generally, if you are not sure yet what language you want to go for, don't worry about it. What you're learning in Python can very easily be migrated to another language. What you want to do is just get started somewhere and work on projects you like and see how far you get. And if you feel like changing, you can totally do that and not start from scratch. A lot of things you are going to learn, you can use in other languages as well. You are always going to make some progress even if you are switching. Alright, in this video, we are going to install Python. And the main target of this session is to write Hello World using Python. Now, this task you can approach in two ways. Number one, you can do all of this on your computer. And this is going to be the main way. If you want to use Python normally, you want it to be installed on your computer. Now, that being said, you can also run Python online. And for that, you don't have to install anything. If you just want to have a quick look at Python and check if you like it, I would recommend to just run Python online for now, and then if you decide that you do like it, you can install it properly. So let's start with some websites that let you run Python code. There are quite a few actually. Here, for example, we have one website called programmist.com, and this one lets you run Python code online. Besides that, you could also use other languages like C, C++, JavaScript, and quite a few more. But in our case, I want to get rid of all the code in here and to print anything in Python. Remember, we want to write the word hello world. And to print this, you have to do a couple of things. First of all, you have to put this entire phrase into quotation marks. Could either be single or double quotation marks. And for now, just follow along. I will explain all of this in much more detail later on. But now that you have this word, it should be green. And what you have to do now is write print and then put the quotation mark phrase inside of brackets, which means we first of all have the word print, then we have a bracket, then we have hello world in quotation marks, and then we have a closing bracket. And if you have all of this, you can click on run, and now you get hello world. If you could follow along so far, you have written your first Python code. And if you don't want to install anything on your computer or register for anything, this website here would be really, really good. So this is definitely something I would recommend. You can also make it a bit larger, that's a bit easier to read. Besides that, there is also a website called repl.it or Replit, I'm never sure how to pronounce it. In here, you also have an online editor that you can use for Python. Here, we already have print hello world. If I run this, we get hello world. For this one, to use it properly, you do have to register, although it is a bit more powerful. But both of these are really good to get started using Python. Although keep in mind, you are running all of this in a browser, which is somewhat limiting. What you ultimately want to do is run Python on your own computer. That way, you have significantly more power and you also have more flexibility. So this is what we want to do. Now for that, we have to install Python on your computer. And the important thing to understand here is that Python is just another program that you have to install on your computer. It's working basically like Word or Excel or literally any video game. And the file you have to install, you get from python.org. So let's have a look at this one. Here we have the Python website, and what you have to do is click on Downloads, and in here you want to download Python and then the latest version. Right now this is 3.10.5. By the time you are watching this, there's probably a higher number, but that isn't going to make much of a difference. So click on download, and then you get the file downloaded. And this is going to work with your specific operating system. In my case, I have Windows, but if you have a Mac, this would also work, although you would get a slightly different file. And once you have that, you click on Open File, and now you get either Install Now or Customize Installation. However, before you do anything in here, there's one incredibly important thing, and that you can see down here. It says Add Python 3.10 to Path. This is an incredibly important option that you absolutely have to tick. This one you really want to add. I will explain later why this is important, but do keep in mind this is incredibly important. If you don't add this, you are going to run into a ton of problems. But besides that, you can leave everything as it is and then click on Install Now. Then you get an installation. And this one is going to work like literally any other program. So just wait until it finishes and you should be good to go. There we go. The setup was successful. Now you can close it and nothing changed. However, now what you can do, if you press the Windows key, you can type Python and you have Python 3.10 installed on your computer. If you run this, you get something like this. In here, you can write whatever you want. For example, what you could be writing is what we have already seen. You can write print, then in quotation marks, hello world, close the bracket, and now if you press enter, you get hello world. And this was done using Python. In here, you could also write something like 1 + 2, you would get the result, and you can do quite a bit more. But this is basically valid Python. So with that, we have basic Python code. Although the limitation here is that we can only ever write a single line of code, which, well, isn't great. What we need is some kind of code editor, and that we are going to cover in the next video because this is a slightly larger section. And just to make sure that everybody can follow, here I have macOS. In there, I still have to click on download Python, and now I'm downloading a PKG file. Other than that, I can click on Open File, and now we're getting a Python installer. That messed with my window, sorry about that, but in here, you click on Continue, you click on Continue, Continue More, you click on Agree, and then you click on Install. Now you need your password, as always, install software, and then you're just installing anything. For macOS, you don't have to worry about a path. And now, here you can see all of my programs, and I have Python 3.10. Although, just wait a second, and there we go. Now the entire thing finished. I can click on Close and move this thing to the bin, and now I have Python installed. Now, to actually use it on macOS, I need my launcher, and you have a program called Python Launcher. Although this one does look a bit weird. In here, you can't do very much. Although you have a tick box that says Run in Terminal window, or at least I hope you do. A terminal is another program inside of macOS. If you open the launcher again and type terminal, there you have a terminal. And let me increase the font size here a bit so this is easier to read. Now, what you want to do in here is you want to type Python 3 and then press enter. And now you can write Python code. For example, you could write print, brackets open, then quotation mark, hello world, and then closing quotation mark, closing bracket, and now if you print this, you get hello world. And like we have done on Windows, you could type 1 + 2, and you're getting 3. And this is valid Python code. But once again, you're only writing a single line of code. But for that, again, we're going to work on a code editor. In this part, we are going to install a code editor. And let's first talk about why we are going to need that. Right now, we can run Python code, which is a really good start, but we cannot use Python comfortably. Right now, we can write single lines of code, but later on, we want to write hundreds, if not thousands of lines of code. And right now, we just cannot do that. For that, we are going to need some kind of text editor for our code. Think of this like Word or Pages. It's simply a text editor, except now we are writing code instead of sentences. And there are a ton of popular code editors. Here's the list of the really famous one. We have Visual Studio Code, PyCharm, Atom, and Sublime. Although there are a lot more, there basically is no end to code editors. The one that I am going to use is called Sublime. This is a really straightforward and simple code editor that you can also customize quite a bit, which I really enjoy. But basically all of those would be fine if you have a strong preference. Although I would recommend just to follow along to also use Sublime. And this is going to be just another program that we have to install. Oh, I should mention all of them are completely free. You don't have to pay anything. But let's install it. All right, here we are on the website of Sublime, and the URL is sublimetext.com. The full name of the code editor is Sublime Text, but nobody really calls it that. And then here you can go to download and download the entire thing. Now, you can see it already, probably there is also a buy option. You can purchase Sublime. It costs about $80, I think, but you don't have to do it. The free version has exactly the same features, and this is what we are going to use. Basically, when you're buying it, you are supporting the creators, but you don't have to do it. So on download, you can download the version you need, either macOS, Windows, or Linux. In my case, I need Windows, so I'm clicking on that. And now I have a download for my specific version. Obviously, if you have a different operating system, this would look a bit different. But now you click on Open File, and then you get this kind of menu. In here, you just click on Next, and you install it like anything else, and finish. There we go. Now you have installed Sublime. On macOS, the installer might look slightly different, but that is minor details. But once you have all of that, you can type Sublime Text. And now you should be seeing something like this. This is our code editor. And in here, you can write any kind of text, whatever you want to write. In my case, what I want to write in here is print, then brackets, and now quotation marks, hello world. And this is going to be the Python code we want to execute. Now, to execute all of this, we need two major steps. Number one, this is the easy one. We have to save our file. This we do under File and Save, or Control or Command S. If I do that, I end up somewhere in my file system. In my case, I have the folder here already. You can save it wherever you want. It really doesn't make any difference. Although what does make a difference is the naming of the file. Let me call this one test. But you do have to specify an ending. So you want dot and then add py, short for Python. This is telling your computer that you have a Python file. You could compare all of this to Word, which always needs a docx ending, or a text file, which always has a txt ending. But in our case, we want .py, and now I want to save. And what you should be seeing now is that the colors of our text changed. If they didn't, don't worry too much about it. But now what you want to do, let me show my mouse, and I want to go to Tools, and in here we have Build and Build With. This basically means you want to execute your code. I want to click on Build, and now I can see Hello World down here. Now you might be seeing something else. What you might be seeing is a dialog that looks something like this. In here, you want to select Python. So if I click on this one, you are getting the same result. The reason here is when you're running Python for the first time, Sublime does want to double check that you do indeed want to run Python. But if you have done that once, Sublime does remember. And most of the time, what I am going to do is instead of up here clicking on Build, I am pressing Ctrl or Command B. This one is going to give you the same result. And if you want to close this dialog down here, you press on Escape. Although there's a really important topic I do want to cover. And that is, when we are running any kind of code in Sublime, what essentially happens is that Sublime inserts all of the code into the Python app. However, Sublime doesn't know by default where that Python app is. Because remember, Python is just another program on our computer. It's nothing special. The only reason Sublime right now can find the Python app is because of the path files. These path files are basically a directory inside of Windows that makes it easier for programs to find other programs. And because of that, Sublime can find Python very easily. If we didn't add Python to the path though, Sublime would not be able to find it. And you would have to add quite a bit more yourself to make it all work. Which fortunately we didn't need because we did add Python to the path files. If you forgot that for some reason, just uninstall Python and reinstall it with the path file selected. That's the easiest way to go on about it. But alright, what you can do now? You could, for example, copy this line here and paste it multiple times, run all of this, and you can see hello world multiple times. Once again, how all of this works in detail, I will cover in the next, 10 hours or so. But in here, what you can also do is inside of print, add a math operation like 5 plus 10, and now run all of this again under tools and build, and you get 15 all the way at the end. And with that, we can run Python code over multiple lines. So with this, we can basically start the actual Python tutorial. Although, before we get started on that, there's one more thing I do want to do that you don't necessarily have to follow. Because I think all of this is looking kind of ugly and a bit hard to read. As a consequence, I want to change the styling. But I am literally only going to change the look of Sublime. In terms of functionality, nothing is going to change. So if you want to skip this part, you can totally do so. Let me show my mouse. What I want to do. Most importantly, under View, I can hide a couple of things that we don't need. For example, all the way in the bottom, you can see a couple of bits of information that we don't need. So I want to hide all of this. This is the status bar, and I want to hide the status bar. Already looking better. Besides that, up here, you can see the tabs. If you have multiple Python files, this can be really useful. Each tab would be one Python file. But for a long time, we are only ever going to have a single Python file. Later on, we are going to use these tabs though. But for now, I want to go to View and hide tabs. Already looking much cleaner. Besides that, what you can also do is hide the menu. And this is making everything look even cleaner. If you want the menu back, you are clicking on Alt, and now you can see it. Until you click outside of it, but then you can bring it back. And all of this is already looking significantly cleaner. Now, if you want to get rid of this top bar here, you have to click on F11, and now you have a full screen app, which I think is much nicer to work in. Now, what you can also do is change the text size, which you do with Control or Command, and then either the equal or the minus sign. Equal makes the text larger, minus makes the text smaller. And in here, just choose whatever you can see best. In my case, I usually aim for having 30 lines of code on one screen. So in my case, the font size I usually choose, if I copy this a couple of times, is something like this. I have 30 lines of code on one window, but this is entirely subjective. You probably want to have something smaller. And finally, what we can do is change the color scheme and the theming of this. And for this, you can install external themes. This you do with Control or Command, Shift and P. If you click all of them, you get a couple of options that you can use inside of Sublime. In here, you want to click on Install Package. Now click on Enter. Now Sublime is going to think for a second, and now you can install external modules. Some of these change the functionality of Sublime, but most of them are just different color schemes. And in my case, what I want to install is the Agila theme. So if you type Agila, this should be the first result. And now just press Enter. And there you can see the nodes for the Agila theme, but we don't care about that. Now to get back to our code, you want to press Alt for the menu, and at least for now, I do want to show tabs so we can navigate around here. Although this package control message you can close by clicking on the X here. And now we are back in the code. but nothing has changed. Now, to actually apply the changes, you have to go to Preferences, and in here, you have select a color scheme and select a theme. Let's start with the theme. In here, you have a bunch of different themes. If you click on down, you can see what is changing. So if I click on a couple, you see what the difference is. In my case, I just want to use the Agila theme. So if I click on this, we already have a couple of changes. What you can also do now, if you click on Preferences again, you can select a color scheme. This one changes the actual code in terms of what you see. And in here, once again, you can select a lot of different things. I don't want to go over this too fast because it might be a ton of colors and, well, I don't want to overwhelm you. But in here, you can search for different color schemes, depending on what you have installed. In my case, I'm going to look for Agila and then Oceanic next. If I select this one, all of this is looking significantly nicer. If I now go to View and hide the tabs, this is basically what you're going to see most of the time, and I think this is much easier to read. Although you might be wondering, what is this line here on the left? And well, for now, you really don't have to worry about it. It's something much more advanced. You can entirely ignore it. As a consequence, since it is not going to be relevant for this entire tutorial, I have hidden it, which is bringing us to some more optionality inside of Sublime. So if I go to Preferences, and here I go to Settings, we get another window, and in here you can see the settings. Now, you might be used to other programs, you just have checkboxes. In Sublime, this is working a bit different. You are basically having on the left here all of the different options you could be changing. For example, you could change the margin size to a 4, and to change this, you would have to copy this one here and paste it on the right side. Like this, and now you could change the margin to whatever you want. Although in my case, I don't want to do this. And I don't want to add too many complications in here because all of this is getting a bit more advanced. So what I'm going to do is, I have a text file. Let me increase the size of the right one. I have a text file that you can just copy if you want to have the exact same styling that I do. You just paste it in here. And now, if you click on Ctrl S to save everything, you should see not much of a difference, although the yellow bar, for example, disappeared. And all of these options here you can find in the description. So with that, you can minimize all of this, and now all of this looks as clean as it can be. At least I think so. So with that, we have Python installed, and we can get started. I want to start by talking about how code in Python, or in basically any programming language, is being executed. And there are a couple of things you have to understand. The most important concept is that code will always be executed from the first to the last line. For example, if we have these 3 lines of code, Python is going to start from the top, so line 1, this one here, then we do line 2, line 3, and then we continue until we reach the end of the code. And later on, we are going to learn some tools to make this more flexible. For example, if we want to repeat code or only run code if a certain condition is true. But for now, I just want to execute some basic code so we can get started. And let's have a look at all of this in some actual Python file. And here we have a completely empty one. And something we have seen already is to use the print statement. And in here, you can just write a random word. So a random word. And now if I execute the code, which again, I do with Control B, or if I press Alt, I can go to Tools and Build. Same thing. If I click on it, I get a random word. And just to be a bit more specific here, let me change this word to first line of code. And now if I add another print statement, let me duplicate this line, which I, by the way, do with Control, Shift, and D. That way you can duplicate lines in Sublime very easily. Now, what I want to do for the second line of code, I want to rename this to second line of code. And now if I run this, we get the second line of code. meaning this line here was run first, then we have number 2, and this would then continue forever. We are essentially executing code downwards in this direction. And this would work with any other data type as well. For example, I could print some numbers, and now we will get 1, 2, and 3. And that is then giving us the most basic thing you have to understand, that now we can execute some lines of code. And I suppose there's one more important thing when we are talking about words and print, and that is, let me copy this again, a space in here would also show up. Meaning if I add a ton of white space and run this again, we now get this line of code here. Let me rename it really quick, third line of code. All of this white space here is still showing up. So just keep that in mind. And well, with that, we have covered all of the basics of really basic code execution. And I guess with that, let's do an exercise. I want you guys to use these print statements to print some kind of tree-looking shape. And for that, you want to use basic characters and white space and then combine these two and create that shape. So pause the video now and see how far you get. The way you have to think about it, I want to print again, and I want to write 5 X's. And if I run the code now, we can see these 5 X's. If I now print these 5 X's again, 1, 2, 3, 4, 5, but remove the first 2 and replace them with a space. If I now do this, I get the 3 X's on top of the 5 X's. And before the first X, we have a white space, so we start to have some kind of pyramid shape. I just want to continue. I want to print 2 spaces and an X. And if I run the code now, we can see we have a proper triangle. And this would be the top of my tree. And now I can copy this line. And at the bottom of the tree, I can add it 3 times. If I run this now, we have a tree. This is looking pretty good. Granted, it doesn't look too nice, but it is what it is. I suppose what we can also do, I can just print empty strings with no word inside. If I do that, we have 1 line of space between the words we have covered earlier and our tree. Although one important thing really quick, there is 1 line in here that I left intentionally empty to organize my code. For Python, this line does not exist. If I run the code, the empty line we have here is because of this empty statement. This one comes right below the 1, 2, 3, this 1, 2, 3. This line for Python is just being ignored. Meaning if you don't write a line of code, Python is just going to ignore it, which is really helpful to keep your code organized. So, all right. This is then the most fundamental thing you have to understand, and it's pretty simple. We are just executing code from the top to the bottom. In this part, we are going to learn about math operations. And those are in Python fairly similar because you probably already know them from basic math classes that you learned when you were something like 5 or 6. It's really basic. We have plus, minus, multiply, and divide. And besides that, we also have power, floor divide, and remainder. I guess the latter 3 are a tiny bit more advanced, but not that much. Besides that, you can also use brackets perfectly fine, like in any kind of computer calculator you ever used. There are also comparison operators, like smaller than or smaller equal than, but those we will cover later because they work ever so slightly differently. I guess I can talk about them for a tiny bit, but don't worry about those too much yet. Let's have a look at all of this. Here again, I have a completely empty Python file. And I want to start by printing a math operation. And this I just do by typing the math operation in here. For example, 10 plus 5 is going to give me 15. And that is literally it. It's quite simple. If I duplicate this line, I can change this to a minus, and now we get 5. I could duplicate this again, change this to multiply, and duplicate it once more, and change this to divide. And that way we have all the basic operators. So if I run this, we get 15, 5, 50, and 2. I guess the one thing you do want to notice here is that when we are using division, this operation here, Python is giving us 2.0. It happens to add a 0.0 even though we wouldn't need it. It's really not a big deal, but just keep it in mind. Besides that, we have slightly more advanced math operators. Let me print 10 star star and 5, and this is giving us a fairly large number because we are taking the power here. I guess if I do a 2, we have the equivalent of 10 to the power of 2, which is 10 multiplied by 10, which is 100. And this is what we are getting down here. Besides that, we also have what is called a floor divide. And to understand what that means, let me divide 10 by 3. If I do this, we get 3.333 and it continues basically forever. A floor divide essentially gets rid of all of the stuff after the decimal point. And this floor divide you get with 2 divide symbols. Meaning if I run the code now, we are only getting 3. You are essentially rounding the result of whatever you are getting in here. Although, keep in mind, this value is not rounding the result. What we're doing is truncating the result, which is a fancy word for saying we are cutting off anything after the decimal point. I can demonstrate this by dividing 7 over 2. If you do this in your head, you are going to get 3.5 with a normal division. And if we were to round this number, it should be 4 because 0.5 is closer to 4 than it is to 3. But if I run the code again, I am getting 3. And just be careful here, this can sometimes cause you some errors where you're losing decimal points and then end up thinking you're rounding when you're not actually doing that. There's one more math operation we need, and that is done with the percentage sign. For example, this could look like 7%2. And if I run this, let's see what we get. We are getting 1. And this 1 here is the remainder. The best way to think about it is we have 7 units in total. We have 1, 2, 3, 4, 5, 6, and 7. And when we are dividing 7 by 2, we are basically looking for 2 whole units to get a full number. Meaning here is 1, there is 2, and here is 3. And that is giving us the result we got from this operation. And this percentage symbol is giving us whatever remains at the end, which is this 1 here. And since this is 1, the 1 we are getting down here is, well, a 1. You don't see this symbol too often, but it can be really useful to figure out if a number is even or odd, something you do surprisingly often. We're going to have a look at that later. There's one more thing I do want to cover, and that is brackets. For example, I could print 5 times 2, and the result is going to be 10. This should be fairly simple. But now, if I do 5 plus 5 multiplied by 2, think about it for a second and see what you should be getting. The result is 15. And it is 15 because we always do multiplication first, and then we are doing addition and subtraction. Meaning this operation is basically 5 plus 10, which gets us 15. If I don't want to do that and add 5 plus 5 first of all, I have to put both of those into brackets, and now I'm getting 20. What we're doing now is 5 plus 5 is 10, and this we multiply with 2, which is getting us 20. I guess the one thing we can also cover is very simple comparison operators. And those do work in the same way that you would expect them to work, to be honest. For example, I could type 10 is greater than 5. The difference here is the result we are getting, because the result we're getting is true. Which I guess does make sense because 10 indeed is greater than 5. If I flip this around, that 10 is smaller than 5 and run the code again, we are getting false. And how we can use these values, we will see later on. But for now, don't worry too much about this one. Now, with that, we have covered the basic operations, and let's do an exercise. What I want you guys to do is to get the average of the numbers from 1 to 7. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, all divided by 7. And see how far you get. Once again, I have to type print. And now in here, I want 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And all of this has to be inside of brackets, because what we are going to do afterwards is divide all of this by 7. And the issue is, in terms of math, if we left it like this, we would first divide 7 by 7, which would be 1, and then we are adding all of these numbers. But what we want to do instead is do all of this here first, and then divide it by 7. For this sort of thing, Sublime is quite intelligent. I can just select the entire text, create an open brackets, and then Sublime automatically adds the closing bracket afterwards. And with that, we are done. If I execute the code now, we get 4.0. Although, looking at the result here, I realized for this entire part so far, I have only ever used full numbers, which you don't have to. It is perfectly fine to write something like 1 plus 1 plus 5. You would still get the appropriate result. Any number in here is going to be fine. This is working like any math operation you have ever seen. In this part, we are going to talk about how to connect different lines of code. And let me explain the problem. Let's say we have some kind of math operation and we want to print the result of that math operation on the next line. The issue we have now is how can we connect these two lines? And the answer here is we are going to need variables. And variables are an incredibly important topic in any programming language. So let's talk about it. All that variables essentially are is a simple container for any kind of data. We could, for example, put a word, a number, or really anything we have in Python in there. And once you have created this container, you can reuse it over and over again. And this variable you create like this. We have the variable name, then we have the assign operator, and that is just an equal sign. And then we have the actual data, or the value we want to assign. And that is basically it. This, instead of a word, could also be a number, like 1, and it could be anything else. But how you would solve the earlier problem is you would first store the math operation result in a variable called result. And then this result you would print on the next line. And I suppose, let's actually try all of this. Once more, completely empty Python file, and in here I want to do a math operation again. And so far, we always used print and then did some math in here. Let's say 10 plus 5. But this print we don't need. We could just have lines like this, although if I execute the code now, again by pressing Ctrl B, nothing would happen. Although something did happen, Python did calculate the result here. We just didn't tell to print the result, so it doesn't print the result, and we can't see anything. But something did indeed happen. Instead of printing this result, I want to store it in the variable. And this variable I called result, and this is going to be the name of my variable now. And now to assign this value here to this result, we are going to need the equal sign, which is telling Python that the result of this operation should be assigned to this variable. And now on the next line, we can just print that result. And if I run the code now, we are getting 15, or the result of this operation here. And what is even better, we could use this result for further operations, and we would use it like the actual value. For example, what I could be doing I could have another variable, let's call it result2. And the value here should be the original result divided by 2. And if I now print result2, we can see we get 15 and 7.5, which is this result divided by 2. And this we could do forever. This result is basically a stand-in for the value we have created here. Although there's one thing you do want to be careful about, and that is variable naming. Let's talk about this one really quick. There are two variable naming parts. The first one is the mandatory parts that you have to follow. If you do not follow these naming conventions, Python is going to throw an error. And fortunately, they are fairly simple. The most important one is that variable names can only contain letters, numbers, and the underscore symbol. You couldn't use something like the $, percentage, space, something like this. Space in particular should make sense quite intuitively. If there's a space in a variable name, it's really hard for Python to tell if we have one variable or two variables. It just gets messy. And if you have a longer variable name and you want to add multiple words together, you would use an underscore. And that is quite a common thing to do. I will show you in a second. The second rule is a variable name must start with a letter or an underscore. The important thing here is numbers are not allowed. A variable name cannot start with a number. Finally, variable names must be different from the inbuilt Python tools. For example, we couldn't name a variable print. I hope this one makes sense as well. It would just be confusing. And I guess let's have a look at all of these rules and see if we can play around with them. I want to create a new variable. Let me call it test. And in here, we can just add a word test. It doesn't really matter. If I run this code now, we are not getting an error because this variable name here is perfectly fine. And I could also add an underscore, add some numbers, add another underscore, and add some capital letters. All of this for Python, totally fine, although this name here probably really confusing. What Python doesn't like, let me put this on the next line, is if we, for example, start with a number for the variable. Let's say to test, and the value here could be test again, it doesn't matter. If I run this now, we are getting a syntax error. Or well, we are getting quite a bit. Let's actually go through this error message here. First of all, Python is telling me which file has caused the error. And also it's telling me on what line the error occurred. Line 8 in this case, which you can see here on the left side. Besides that, I also get the actual line that caused the error, so toTest is equal to test. And below that, we have the really important information. And that is this syntax error, invalid decimal literal. It sounds somewhat cryptic, but what Python is complaining about here is that we are starting a variable name with a letter. However, if I change this to test, everything is working just fine again. And on top of that, adding a number anywhere else inside of the variable name is perfectly fine. I could, for example, add the 2 at the end. This would also work just fine. The other thing that you are really not allowed to do is to add spaces in your variable name. And if I run this one now, we are getting invalid syntax again. And here Python is giving me a ton more information, although it really doesn't tell me all that much. This line here is the really important one. And I think it does make sense why there's no space allowed. If we have something like this, it looks like we have two separate variables, which obviously would be kind of confusing. So what programmers I usually do in basically any programming language is they always add underscore signs to show that we want to add a space. But with that, we have all of the basics for variable naming, or at the very least the mandatory parts. There are some more that are more optional. Let's talk about those. The most common rule that you are going to see is that you should use snake case. And snake case just means that when you are starting a new word, you always start with lowercase and every additional word always is lowercase. You basically only use lowercase letters. And then to connect words, you're using the underscore. And this one you have to use anyway, since this is a Python rule. What snakecase basically means is you are always going to use lowercase letters and space is replaced with an underscore. That's all it means. Besides that, the other rule is that variable names should make sense. This sounds very obvious, but I can show you a couple of examples in just a second that might get very confusing. Generally, it's fine to have longer variable names, but make sure that the variable name expresses its content. It's very easy to not do that and end up with code that you do not understand anymore. So always write long names that express what the variable actually does. And finally, variable names should be consistent. I suppose this one is pretty obvious. And I guess the really important one is this one here, because this one is looking terrible. If you were working with other people and try to name a variable like this, you would have some questions about your mental wellness, I suppose. Something better would be more like test variable, and let's call it practice. This one here would be a perfectly fine variable name. It is in the snake case because we have lowercase letters and we are connecting the words with an underscore. And this one here would also be at least a valid Python name, but we are kind of inconsistent. We are first writing a word with letters and then the actual number. So what you might want to do here is write 2 a bit more consistently, or don't use any numbers when variable names begin and always stick with numbers. Whatever you prefer, just be consistent, it really helps. The final thing I really want to mention, what I see a lot of beginners do, is do something like x equals, I don't know, some words. And this is fine for shorter programs, but once you have longer ones, it can be really confusing. Meaning you want to replace this with something that actually means something. It is a really common thing that you write a program, you don't look at the program for half a year, then you come back to the program and you have no idea what you did half a year ago. Happens to literally every programmer. And naming your variables properly makes it a lot easier to read what your code actually does. So name your variables properly. There's one more thing that I really want to do, because now that we have variables, we get a few more math operations. Although those math operations are going to look a bit weird. They are looking like this. We have plus equal, minus equal, divide equal, and multiply equal. I think to explain what they do, let's do an example. Let's say I have num1 is equal to 1. A really basic variable. And I want to increase the value of this num by a certain amount. For example, let's say by 5. To do that, I could write some code like this, that num1 is itself plus 5. And this would be fine, but this also feels kind of clumsy. And for that, we have these operators here. What you would do instead in Python is something like this. We have num itself, then plus equal 5. And those 2 code snippets here do exactly the same thing. They take the original variable and then add a certain value to it. Let's do this in code actually. I think that's going to make more sense. I want to create another variable. Let me call it num1. And by default, this one is 10. And now this 10, I want to increase by 5 again. And this could look like this. I want to get my original num1 and then add 5 to it. If I now print num1, we are getting the value all the way at the end, which is 15 again. I guess let me use different numbers so we get some different results. Now we get 20, which is 10, the value of num1 plus 10. But again, this here is kind of clumsy. And Python gets around this by adding plus equal, and then we are adding 10. Meaning now we are taking the original value of num1 and adding 10 towards it and assigning all of this again to num1. And if I run this, we are getting the same result. So if I spell this out a bit better, these two lines here are doing the exact same thing. And this is working with the other math operators as well. For example, we could have minus equal, and we're getting 0. We could add multiply equal, which is getting us 100. And we have divide equal, which is getting us 1. And if you just want to update a variable, this is how you would do it. And this is now bringing us to the exercise for this part. And what I want you guys to do is to create a variable that has some kind of snake case and try to use a bit of a longer word. Assign a value to it, and on the next line, increase this value by 20. And then on the third line, print the variable. Let's get started by creating a really long variable name that is a bit annoying. Obviously, you would never use something like this in practice, but I hope you get the idea. And the value I want to assign is, let's go with 10. On the next line, I want to get my really long variable name that is a bit annoying, and I realized I do have a typo. Let me fix it really quick. And I want to increase this value, so I want plus equal, and I think I said 20. And now finally, I want to print my really long variable name that is a bit annoying. And if I print this, we are getting 30. And with that, we have variables, which is an incredibly important concept. In this part, we are going to talk about functions. And all that functions are special commands in Python. We have actually seen one already, and that is print, which is printing a certain kind of text. This one you should be really familiar with at this point. But there are quite a few more. For example, len gives you the amount of characters in a word. And another one would be abs, or absolute, which is giving you the absolute number, which in practice just means if we have a -1 and we're using abs, this is turning into a 1. Although to understand functions, we need one really important concept, and that is brackets. Meaning when we're adding brackets after the name of the function, we are calling it. And this we have done multiple times already. Anytime we use print, we have called a function by adding brackets afterwards. And inside of the brackets, we are adding what is called arguments. For example, for print, we can add any kind of argument, and this is then what we are going to print in the case of, well, print. And let's have a look at all of this in code. I want to once again start with print, and this is the name of the function. And to call it, I need brackets. And what we are adding in here is the argument, which right now is the word, which let's call it test. And what this function does is it prints the word so we can see it. Another function that we can use is called len. And in here, we could add another word. If I run the code now, we can't see any result because this is only giving us a value, but we are not doing anything with that value. And to overcome that, we have to print the result. And now if I run this, we are getting 12. And this 12 means that inside of this word, we have 12 characters. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Notice here that Python is counting a space as well. And all of this could also be used with variables. For example, this len, I could assign to the variable word length. And then on the next line, I want to print my word length, and I get 12 again. And this would be a slightly cleaner way of doing this, although the previous one would also be perfectly fine. And another function we can also work with is absolute, or abs. And in here, I can add -50. And for this, once again, I have to print the result, otherwise we wouldn't see it. But now, if I run the code, we are getting 50, meaning abs removes this -50. And there's one more really important thing that you can also do with functions. that right now we always only added a single argument. But for some functions, you could add more than that. Print is actually one example of that. Let's put this on a separate line. So far, for print, I always added one argument. But what I can do, I can add a comma and then add another argument. And now I have two arguments. If I run the code, I get one argument and then print adds the other argument. And print accepts an unlimited number of other arguments, meaning if I run this now, we are getting more and more arguments. The important thing here is you always add one argument, then a comma, and then another argument, another comma, and so on, depending on what the function accepts. And some functions only accept a single argument. For example, absolute only takes one. If I added another, we will get an error, and that is ABS takes exactly one argument, and we have given two. Python here is very clear, abs only gets one argument. But that is essentially the basic concept of calling functions. Now for the exercise, I want you guys to do some research online. And I want you guys to look up the function called max and try to figure out what it does and call it inside of this code. Here I have Google open, although you could use any search engine. And to learn coding, you have to do a ton of research. So it's a really good idea to start early. And what we want to do right now is look at the Python function max. And let's just see what we get. In here, we can see a bunch of websites. And for Python, all of them are basically fine. W Free Schools, Programmists are really big ones. Geeks for Geeks is also really big. But the one you probably want to use the most is docs.python.org. This is the official Python documentation. If I click on this one, we can see all of the built-in functions for Python. And the one I'm looking for is called max. If I click on this, I get a ton of information. The most important one is right in the beginning. It's returning the largest item in an iterable, or the largest of two or more arguments. What an iterable is, we have no idea so far. But what we do know is the largest of two or more arguments. So let's have a look at that one. Once again, we are in the code. And I want to use my max function. And in here, I want to just add a couple of random numbers. And now I once again have to print the result. And if I run this, I get 10. And well, we get 10 because max is selecting the largest argument that we are passing into it, which right now is 10. And well, that is basically all it does. If you understand this one, you also understand min, which is taking the lowest number, which in our case is 2. And with that, we have covered functions. Besides functions, we also have methods. And especially for beginners, methods and functions can be very similar. So let's compare the two. In the most basic sense, a method does the same as a function. The only difference being that the method is always attached to an object, which means we are still calling a method with the name of the method followed by brackets, and this is still called calling a method, just like a function. We can also still pass in arguments, and here this works in exactly the same way. The difference is that methods always are connected to an object, and this happens with a dot, which in practice looks like this. We always start with some kind of object. In this case, it's a word, it could also be a number or any other data type in Python. This is then followed by a dot, and this is really important. Then we have the method name, and then we have brackets with whatever argument you want to put in. And then all of this does a certain thing, just like a function. What this thing could be is, for example, we can use the upper method. And this one takes a word and returns the same word all in uppercase letters. And I think this example also illustrates why we have functions and methods. sometimes functionality only makes sense for a certain kind of data type or for certain objects with a certain data type. And here, the uppercase really only makes sense for a word. There is no uppercase for a number, for example. And this is why we have methods. And I suppose we can implement all of this a bit more practically, so let's have a look at all of this in code. Once again, I have a completely empty Python file, and I want to create a new variable. Let's call it test. And the value for this test is going to be a word. To get started, I want to print my test variable. And if I print it, we are getting a word. So far, all of this should be very familiar. And the method we have seen, we are calling with a dot after the word, and then the name is upper, and don't forget the brackets. If I run this now, we can see a word all in uppercase letters. And with that, we have called a method. What we can also do, let me demonstrate it first and then explain. I can cut out this upper here and run it on this variable. If I run all of this now, we are getting the same outcome. And why this happened, I will explain in the next section. But in the most basic sense, methods always change a value. Where you change that value is really up to you. In the first example, we created the word, and then when we are creating the word, we are calling the upper method, and this is returning the uppercase letters and storing them in the test variable. And once we have that, we are printing the test variable. That's all that's happening here. And then the second example looked like this. And in here, we first created the word and saved the word inside of the test variable. After that, we are still printing the test variable, but now when we are printing it, we are modifying it with the upper method, which is giving us the uppercase word. The result for both of these examples is the same. How this works in detail, you are going to understand very soon. For now, I'm going to call the upper method when I create this value. Now, obviously, this example really isn't all that useful. Let's do something more relevant. Let's say we have some kind of user name. And we are expecting something like John Smith, where we have a first name and a surname. But since you are allowing user input, this might instead look something like this. We have a typo, and maybe we have some X's at the end, and let me add another typo in here. This would still be valid user input, but obviously it would look terrible, which is something we couldn't use for our purposes. And methods are really good to clean all of this up. And the one method we could start with is called title. And let me print the username and see what that one does. Now we get always, let's expand this a tiny bit. We are always getting the first letter is uppercase and then every other letter is lowercase. Meaning now we have John Smith in the proper spelling, at least for names. Meaning with this, we get rid of this O and this I. What you can also do is combine different methods, which you do by adding another dot after whatever value you want to change and then calling the other method. In my case, for this one, I want to get rid of these two X's. And for that, I need this strip method. And what this one does is it looks at the right and the left side of any word and removes a certain kind of value, whatever we specify inside of the arguments. And in my case, I want to get rid of these two X's, which means I want to add the string X in here. And if I run this now, we can see there is no difference. So what went wrong here? And I think you can already tell what the problem might be. In the original word, the two X's were uppercase, and this is what we are trying to remove. But what this strip method here sees is this string changed by this title. Meaning strip doesn't see a capital X, it sees a lowercase x. And for Python, again, remember, capitalization really matters. An uppercase and a lowercase letter are two completely different things for Python. To fix that, all we need is a lowercase letter, and if I run this now, we have removed the two values. You might be asking yourself what methods are available, and there are a couple of ways to achieve that. If you want to stay inside of a code editor, you would use the dir function. And in here, you can pass in any value to figure out what methods it has. For example, I could pass in the username in here, and if I run the code now, nothing happens. The reason is that this function only returns all of the methods, it doesn't print them. For that, we again need the print function. Now if I run this, we get something that looks a fair bit more technical. And you have two main things in here. You start with all of this stuff here. A lot of names with double underscores before and after the word. Like this LT here, we have 2 underscores before and 2 underscores afterwards. What these mean, we are going to cover much later. What you want to focus on for now is all the stuff down here. These are the methods that you could be using. And we have actually used a couple of them already. For example, strip, we have used title, and we have used upper. I guess we can do one more method, and let's use isAlpha. What this method does is it checks if the values inside of a word are in the alphabet, meaning they are not numbers. Let me close this one, and instead of the dir function, I want to print username and then .isAlpha. And don't forget to call it. And now if I run this is saying false. The reason for that is that inside of this word, we have one value that isn't inside of the alphabet, and that is this space here. If I remove it and run all of this again, now it says true, meaning every letter inside of the word is inside of the alphabet. If I added any kind of number in here, this would go back to false. Although I don't really want to do that. But this would be another way to check something in your word that may become useful. Especially when you work with something like user input, you might want to check if there are numbers inside of the name. However, if I go back to the dir function, run this again, this list here still isn't that useful because you have a name, but you don't really have an explanation of what the specific method does. And well, to really understand what a method does, you do want to use Google. And if you want to Google for specific things, you need to know their names. For example, in Python or in really any programming language, a word is always called a string. We're going to cover that in much more detail in the next major section. Just remember for now, a word in programming is always called a string. And with that, let's do some Googling. In here, I want to look for Python string methods. And then I'm getting a ton of different results. And again, all of these websites here work quite well. The one that is the official documentation by Python is called docs.python.org. And this one says built-in types Python something something documentation. And in here, on the left side, you can see all of the data types. Again, we're going to cover those in a lot more detail very soon. For example, here you have numeric types, we have sequence types, and then we have text sequence type, str, which stands for string methods. This is the one I want to look at. And in here, you have a very long list. Let me minimize this part. You have a very long list of methods that you could be using, along with a fair bit of text explaining what they do. For example, here is isAlpha, the one we have just looked at. And if you have any kind of problem yourself, you will probably read through this list and try to figure out what method works for your purpose. And I suppose let's have a look at another website. For example, W3 Schools is also really good. And in here, we also have a long list of all of the methods. The list contains the same number of methods. And in here, let's say if I click on isAlpha, we get to another website. We have an explanation along with an example. You honestly can use any of these websites. They all cover basically the same thing. All right, with that, we can do an exercise. And in my case, I want you guys to do some research because I have an exercise string that is saying, I like puppies. And what I want you guys to do is to find a method that replaces the word puppies with, let's say, kitties or any other animal that you really like. So pause the video now and try to figure this one out yourself. In my case, I want to look for Python, a string. Remember, this is just a word. And I want to replace let's say, a value. If I do this, I already get one answer predicted by Google that is called replace. Although if I go down, I see replace a bunch more times and, well, I just have to look at one of them. Doesn't really matter which one it is. Let's choose programmist this time. This one is really good. And then here we have an explanation of what this one does. We have an example, and then we have the syntax, so how we would use it. And in here, we have a string, so any kind of word, then the replace method, then we have an old value, a new value, and a count. And down here, then, we can see how we would use these values. The old value here means the value we want to replace. The new value is what we want to replace it with. And then the count basically means if we have the old value multiple times, how many times we want to replace it. And this one is optional, so you could leave it out entirely. And with that, we can implement all of this. Back in my code, I want to add a dot and then the replace method. And in here, we first of all need the old word, which in my case is puppies. After that, we need the new word. And this, in my case, is going to be kittens, although any kind of word would be fine in here. And these two values would be mandatory, so we have to have them. But once we have them, we can print the result and run this now. And all the way at the bottom, we get I like kittens. We have successfully replaced puppies with kittens. We could also add a third value. And this one determines how many times we would want to replace this value. Let me actually paste it in a few times here. Now we have puppies 4 times. By default, I am replacing all of them with kittens. Meaning what I get is I like kittens, 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 and kittens. But if I add another value in here, and this has to be a number. Let's say I want to add a 2. Now if I run this, I am only replacing the first 2 instances of puppies with kittens. But after that, I keep my puppies around. And again, there are a lot more methods, far too many to cover them in one video. What you basically do as a programmer is you keep on working and you learn more and more methods as you go along. But that being said, even after a few years, you are not going to know all of them. For that, you have Google and you just look up different methods. I have been programming for years and I still forget them all the time. It's really not a major issue. And with that, we have methods. In this part, we are going to cover return. And return is one of the most important concepts in all of programming. So let's talk about it. In the most basic sense, return is the glue that connects everything in Python. What that means is that any operation returns a value. For example, if we calculate 2 plus 2, a 4 is being returned. We also have functions and methods, and those can also return values. For example, upper returns the uppercase letters of a string. And by combining different return values, you are creating more complex logic. And what you are basically going to do in programming is combining different return values to create something more complex. And an example here could look something like this. Just read through this and try to think of what the outcome here is going to be. And let's go through this line step by step. We are always starting with the innermost part. In this case, it is a word. And then we are applying right now the first function, which is len. This is going to return a value, and the value it is going to return is 6, or the amount of letters inside of this word. And next up, this value we are going to multiply with -10. This again is going to return another value, -60. This is then going to return 60 because the absolute function always turns a negative number into a positive number. And this would be one example of the return statement, where we are taking specific functionalities like the len function here, and then use the value they return in another operation, like this 6 multiplied by -10. What you absolutely have to understand is that every operation in Python returns a value. And then this value you can combine with other operation, like using it in another function or with another method or in a math operation. It's really up to you. But this is a really powerful system that allows you to add lots of logic on a single line of code. Let's play around with this. I think that is going to be really important. Once more, completely empty Python file, and let me create a test variable. Let's use the example from the previous part, where we had a word, and then we used upper. Let me print it as well, and we are getting a word, all in uppercase letters. And I think I want to have a bit of white space around it. That makes my life a bit easier. What happened in here is we have a word, and then we are using the upper method to change the word. What this combined statement here returns is a word, all in uppercase letters. And once we have that, we can add another method to it. And the method we could be using here, the one we have already seen, let's use replace. And what we want to do in here is replace the letter A with the letter, let's say, X. And now if I run this, we have X word. What happened here is that this first statement returned a word. This one should be obvious by itself. After that, we have used the upper method to turn this a word into a word, all in uppercase letters. After that, we have used the replace method to change this A to an X. And we could continue this forever. For example, what we could be doing is wrap all of this inside of the len function. And now if I run this, we are getting 6. We start with a word, then we are turning all of this into uppercase letters, then we are changing the first letter from an A to an X. So what we have inside of these brackets is X word, all in uppercase letter. And what we do then is use the len method to count how many characters we have inside of this word, which right now is 6, and this is what we are storing inside of the variable. I hope this makes sense. It is a really important concept to understand. All it means is every time you perform some kind of operation, a different kind of value is being returned. And then this value is what you are working with next. You really have to be aware that every operation returns some kind of value, although this can be kind of weird sometimes. One really good example. Let me remove the white space here. And then let's play around with the print function, because this one by itself just prints whatever we pass inside. So what's going to happen when we print a print function? And let's see. We are getting 6 and none. The 6 we are getting from this inner part. And the none is what gets returned by a print statement. And none is an actual data type in Python. You can work with it, but it basically denotes the absence of a value. But again, print is returning something. Although in this case, what it is returning is the data type none. I hope you get the idea here. Now for this part, I am not going to do an exercise, but I would recommend you to play around with this yourself in your own time and see what you can do yourself. Throughout this series, we are going to do a lot of examples, so there's plenty of time for practice. A really important thing you have to understand is comments. And comments do not influence your code whatsoever. They are just explaining it, or well, they are commenting what your code does. And you really want to use comments quite extensively, because they are really useful to help how you organize your code and to understand what it does. Especially if you work in a team, you want to add lots of comments because other people would really appreciate it. It also works as a really good reminder for your own code. It's a really common thing for programmers that you write some code, you don't look at it for half a year, and then you have no idea what it does anymore. And writing comments is a very good way to remind yourself. There are two ways to write comments in Python. The first one is the hashtag symbol. Anything on that line after the symbol is going to be ignored by Python. The other way is a triple quotation mark. This one will comment out anything inside of these quotation marks. This would also work over multiple lines. Although technically it's not a comment, we are going to learn later what this is, but you can use it as a comment. And let's say I have again a test variable, and this one is a really important value. I want to add a comment to explain that this is a really important value. We are just using the hashtag symbol, and anything after that symbol is going to be a comment. You can also add multiple if you want to add some specific kind of styling, which is fairly common actually. What you see fairly often is programmers doing something like this, then a comment, and then something like this at the end. I guess we can close this box as well to make it look a bit prettier. With something like this, you have a very clear section inside of your code. But the important thing here to understand is that anything after hashtag symbol on the line of code is going to be ignored. I guess let me actually run the code by printing the test variable. Run this now, and we can only see a really important value. Anything here and here was ignored by Python. You could also put this anywhere else in your code. For example here, and then this line of code is going to be ignored entirely. And something that would make more sense is you could comment out the entire line. And that is basically it for the easiest kind of commenting. Although for this type of comment, Sublime has a very neat trick. Let me duplicate it a couple of times. And imagine all of these are different examples of code. And you want to comment out all of them. It would be really annoying to write a hashtag in front of every single line of code. It just wouldn't be efficient. So what you can do is select all of them and then press Ctrl and the /, the one below the question mark. If you do that, all of them are being commented out. And if you press it again, the comment disappears, which is what I am using all the time. And well, with that, we have the first type of comment. What you can also do, I guess, let me add something below here. Let me call it another variable. Let me just use some numbers. And now duplicate this a few more times. And again, I want to comment out multiple lines of code. For that, I can use 3 quotation marks at the start and at the end. You can already tell the color was changed to gray, and this tells us this is going to be a comment. Meaning if I run the code now, we wouldn't be able to see it. Okay, granted, we wouldn't be able to see this at all, so let me add a print statement in here with another variable. If I run this now, we still cannot see the print statement because all of this is a comment. Now, this example here isn't exactly great because it's just lots of individual variables that I copy pasted. How you would use this kind of comment most of the time is by adding a couple of lines of code that explain something more complex. Let's say this is a really important section. It does a couple of things that we need for the code to work. Whatever you want to put in here. After that, you would have the rest of your code. This is what you see fairly often, and Python actually incorporated this into its functionality. We're going to see this later on as well. I guess for now, the really important thing you want to be aware of is this one here. The simple kind of comment that you can just put anywhere, and that way you can either add explanations or sections to your code which really help with the organization. Before we are finishing off this section, I want to talk a bit more about the lines of execution logic, because there are a few things that I haven't covered yet. Let's go through them. The most important part is that how you see lines differs from how Python sees them. A really good example here is that Python does not see empty lines in the code, only you do. And let me illustrate what I mean. If I start typing print, and let's call it first line, and then duplicate the line and type in second line. If I execute this code, I get first line and second line. This is the stuff we have already seen quite a lot. It should be fairly obvious by this point. However, what happens if I add a space in here? Now we have a line of code, nothing, and another line of code. If I run all of this now, we are still seeing the same result. The reason being that Python ignores a line without any code. If there's nothing on a line, Python is just going to ignore it. Meaning what you could be doing is add a huge amount of white space and it would not make any difference to your code. Which is very often something you do want to work with quite extensively, because this is making it much easier to organize your code. Especially if you add more comments with something like, let's say, second line, and then this could be the first line. You could have a setup like this, which in your case might make it much easier to read. But all that Python sees is this line and this line here, which is giving you a ton of work to customize whatever explains your code the best. But there are quite a few more things that you should be aware of. What I have also covered is that Python ignores white space within a line, meaning you can add as many spaces as you want. Let's have a look at this one as well. For example, what I could be doing inside of a string, I could add as much white space as I want, and this one is going to be reflected in the code I am running. What I can also do is add white space between the different parts of the code. Something like this would still work just fine. Although granted, in this case, there isn't much reason to do something like this. I suppose something slightly more relevant might be we could add 1 plus 2 plus 4 and so on. And for this line, Python would just ignore the white space. Meaning if I run this, we are just getting the result. Python doesn't care what you do between these lines, which I suppose you could be using for something like 5 multiplied by 5 and then plus 10. So you indicate which operation comes first, the 5 multiplied by 5. Although still kind of a stretch. What you can also do is use tab. You can add this as much as you want. Python doesn't care. It treats tabs like white space. That being said, there's something really important. And that is Python really cares about the indentation of an entire line. Let me demonstrate this. This is going to become incredibly important later on. What we have seen so far is that these indentations do not matter to Python. However, what Python does care about is if this entire line is indented. If I indent this entire line and run this again, Python is going to give me an error. The error we are getting is called indentation error, unexpected indent. Why that is, you are going to learn later. What you have to keep in mind for now is that inside of a line, you can add as much white space as you want, but you couldn't add white space when you start the line. Like here, Python is not going to like that. But alright, there's one more topic I do want to cover. And that is how to break the line space, or at least how to make it a bit more flexible. Because you can create multiple lines of code in one line. The reason here, again, is what you see as a line and what Python sees as a line are two separate things. If you want to be a bit more specific about it, what you see is a physical line. All that really means is whatever is in a single line of code. It's as simple as that. But what Python sees is a logical line. And this is what gets executed one step at a time. Let me demonstrate this one as well, actually. Let me clean all of this up actually, so things are a bit easier to read. We have two physical lines and two logical lines, meaning what we see and what Python sees is identical. We have this line and we have this line. However, what I can do now is put both of these print statements on the same line. And Python isn't going to like this at all. And the reason here is that for us, this is one physical line and we can, I guess, read it. But to Python, this is one logical line now that doesn't make sense. Python can only execute one of these functions at a time. It has to execute this line first and then this line second. It cannot do them at the same time, which is why we are getting an error here. Although this logic you can break to some extent. And there are two ways of doing that. The first one is you can use a semicolon. And this way you can separate a physical line into logical lines. All of this here would be a physical line, but because of the semicolon, Python is going to break this one out into two logical lines and is going to keep happy. The opposite operation, I suppose you could call it, would be a forward slash. This one is breaking two physical lines into one logical line. This is something you are going to use fairly often if you have a really long operation. The example here is we're just adding some numbers and at some point we ran out of monitor space. As a consequence, we wanted to have all of this on the same line. Meaning this is two physical lines, but because of the forward slash, Python turned all of this into one logical line and keeps being happy. So all is good. And let's have a look at those two, and then we are done with this entire section. And I guess we can start with the semicolon. If I put print and print on the same line, run this again, Python is going to be unhappy. But if I put a semicolon between the two, then Python is going to remain happy, because this semicolon is breaking a logical line. Now that being said, this semicolon you are probably never going to use, or at the very least you are very rarely going to use it. It really is very, very uncommon. What is, however, much more common is, let me create another variable. Let's call it a. What you do see fairly often is some kind of very long math operation. Let's say 1 plus 2 plus 3 plus 4 plus 5, and this could go on forever, and you want to break this up. And for that, you would use a forward slash, and then on the next line, you can continue writing the line as you would normally do. Meaning I could add a plus 6, plus 7, plus 8, and so on. If I now print a and run this, we are getting a proper result. Keeping your code readable is a priority that you want to keep in mind, and the forward slash is really useful for that. But alright, with that, we have all of the basics covered. In this section, we are going to cover data types. And this is going to be an incredibly important part, because understanding data types is one of the most fundamental things you have to understand about programming. Python does have quite a few different data types. We have actually seen some already. The one that we have used the most is words, which is just a string. It really is just a fancy word that programmers use. We are just talking about words. Besides that, we have also used different kind of numbers. We have seen integers and we have seen floating point numbers. The only difference between the two is that floating point numbers has decimal points, whereas integers are always full numbers. The reason why that is quite technical and you don't have to worry about it. You can work with them very, very easily and they are basically interchangeable from your point of view. There are only very rare exceptions where that is not the case. And those exceptions you probably are not going to come across unless you get into some very specific topics. Besides that, there's one more data type that we have seen as well, and that is a Boolean. And Boolean data types can only ever have two values. They are either true or false. And in the context where we have seen them is some kind of math operation. For example, 10 is greater than 5 was true. These Boolean values you are going to work quite a lot later with to organize the flow of your code. For example, you might only want to run some code if a certain condition is true. Besides those 4 data types, Python has quite a few more. Some are more important, some are less important. But there are 4 that you absolutely have to know. And let's start with the easiest one, a list. This is basically just a container to store other data types. For example, in this list right now, we have 3 values. We have 1 and 2, and both of those are integers. And besides that, we have a string, which is just a word. You could also store Boolean or floating point numbers, and you could even store a list inside of another list. Python really is flexible here. Besides that, we have tuples, we have sets, and we have dictionaries. And all 4 of those data types are just there to store other values. The difference between them is that they're storing data slightly differently. A list and a tuple differ because a list can be changed, whereas a tuple cannot be changed. A set would be different because every value inside of it has to be unique, and there are a lot of ways to compare different sets to filter out data. And finally, a dictionary is a much more organized way to store your data. In here, we always have a name and then a data type. I am going to go through all of those in detail throughout this section. And then we are going to go in quite some detail into all of them. Besides those, there are also some data types that are much less common. I will cover those at the end of this section. They really aren't that important, but you do want to be aware of where they appear and why they matter. But generally, Python is incredibly relaxed about different data types. Most of the time, you are actually not even going to notice. For example, if you have an integer and a floating point number, for example, this could be 1 plus 1.2, and Python here would automatically convert these 2 numbers into a floating point number with 2.2. You have essentially combined different data types, but because Python is so flexible about it, you didn't even notice. Which is one of the main reasons why integers and floating point numbers, especially for beginners, are basically identical and you never have to worry about them. On top of that, Python also has a ton of functionality to change different data types. I'm going to cover that very soon as well. Let's get started by talking about integers and floats, or, well, just numbers. And I just covered them, but just as a recap, we are creating numbers either with integers or with floating point numbers. And again, the only difference between the two is decimal points for floating point numbers and integers are always full numbers. Again, the difference is because of how computers work, but you really don't have to worry about it. The most important thing for you is that all math operators work just as normal. Meaning if you add an integer and a floating point number, you are getting a floating point number. Let's have a look at some examples. And a really useful function to understand what data type you're working with is called type. If I write type and then add an integer, so a 1 in here, Python is going to tell me what data type I am working with. And again, we have to print the result so we can see something. If I run the code now, we are getting class and integer. What a class is, you're going to learn much later in this series. But the important thing for now is the integer. This is the kind of data type we are working with. If I change this 1 to a 1.1, then we are getting a float or a floating point value, which means you are working with different data types. You could also add a string in here, so a word, let's say a word, that is horrible spelling, but you get the idea, and we have str for string. Let's stick to a 1. Actually, we don't need to type at all anymore. Instead, what we can look at is the conversion between different data types. And for numbers, this is all automatic. In here, I could just type 1 plus 1 plus 1, and we get 2.1. Since this does have a decimal point, we have a floating point value. Although, if you didn't know this specifically, you would never notice. Although, I guess sometimes this can be slightly weird. We have actually seen this very early on in this entire series. If you divide any number by another number, let's say 10 divided by 5, I am going to get a floating point number, even though I wouldn't necessarily need it. And this always happens in Python. You can't really get around it. But that is basically all you have to know about numbers in Python in terms of data types. Python here is really flexible and makes all of this very easy, which does make it much easier than most other programming languages. I guess one thing we can cover as well is, let me add this on the next line, you can use functions to convert different data types. For example, let me print something again, and I have an integer, let's say 2, and I really want to convert this integer into a floating point number. One way of doing this is to add 0.0 to it. If I run this now, we get 2.0. Although this isn't exactly elegant, so we're not going to use it. A better way would be to use a function that is called float. And float converts any kind of integer into a floating point value. If I run this now, we are getting the same result. You can see it's a float because we have a decimal. This would also work the other way around. Let me put this on the next line. If I print a number like, let's use something else, 5.1, if I want to convert this 5.1 into an integer, I could use the int function, or int for integer. If I run this, I am only getting 5. Because remember, integers are always full numbers. We do not have values after the decimal, so we are losing some data. Also keep in mind, when you are using int, you are not rounding. The operation you are doing is truncating. And truncating means we are getting rid of anything after the decimal point. Which means if I had 5.9 and run all of this again, we are still getting 5. If you wanted to round, you would use round, and then you are getting 6. It would also return an integer because, again, we don't have any decimal point. Now, there's one thing that you do want to be really careful about, and that is that floating point numbers sometimes can get really weird, especially if you combine integers and floating point numbers. For example, if I print 1.1 times 3, what we would be expecting here is 3.3. However, if I run the code, we are getting something really weird. 3.3 and then 0 a lot and then a 3 at the end. Technically, this result is wrong. It resulted because floating point numbers are kind of weird in computers. Now, that being said, in most cases, this error here makes absolutely no difference because it's such a small deviation, you are never going to notice it. But do keep it in mind, you generally want to avoid floating point numbers because they can add some arithmetic errors once in a while. Generally, integers are much easier and much cleaner to work with. But obviously, sometimes you just have to use floating point numbers and then you can just use them. They work just fine in basically all circumstances. The next data type I want to talk about are strings. And this is the one we have seen a lot by now. All we're talking here are words. And this is something we do have to talk quite a lot about because we are going to use them extensively. Strings are created either with single or with double quotation marks. You could either write word with single quotation marks, this one and this one, or you could use double quotation marks, this one and this one. Python really doesn't care. The only limitation is that you have to stick to the same kind of quotation mark. You couldn't add a single quotation mark and then end with a double quotation mark. And strings have a ton of methods to manipulate them. I guess some examples we have seen are upper, is numeric, and strip. What we haven't seen yet is you can also use strings with math operations. For example, if you add hello plus world, you are combining these two strings. We are going to explore that functionality a bit more in this section. Besides that, you can also add values into strings in quite a few different ways. The most important concept here that you have to understand are f strings. You will see in a second what that means. It's basically another kind of method. And finally, we can also cover how to write over multiple lines and how to add quotation marks inside of a string. And that's a ton of stuff to cover, so let's have a look at all of this. Let's start by creating some test variable. And in here, to create a string, we can either use single quotation marks or double quotation marks. I guess let's start with single quotation marks. Let's call it test1. And then for test variable 2, we can have double quotation marks with test2. If I run the code now, all of this is going to work just fine. As a matter of fact, if I print test var1 and test var2, both of them are going to give the same result. Python does not care if we use double or single quotation marks. The one thing Python does care about is that we do not mix quotation marks, meaning something like this wouldn't work if I run it. We are getting a syntax error, undetermined string literal. I think the reason here should be quite obvious. It would be very strange. What I also want to do starting from, well, now is to comment my code. So it's going to be a bit easier to read when you read through it. And this section here is about quotes for strings. Along with that, there's one important thing that we do have to cover, and that is quotes inside of strings. What that means, let me create another test variable. Let's call it test var3. And let's do an example. Let's say I have the case that he said, and then I want other quotation marks, this was great. And let me add a bit of white space here so this is easier to understand. We are using quotation marks here, and that way we are creating a string. Inside of this string though, we have another quote. And you can already see by the colors here, Python is not exactly happy about it. If I run all of this, we are getting an error, invalid syntax. Python just doesn't know what to make of it. As far as Python is concerned, we are starting a string here and we are ending the string here. Then we are adding some random words and then we are creating another string. The reason now why Python is confused is because these three words are neither variables nor inbuilt functions, so Python just doesn't know what to do with them and it gives us an error. So how can we get around it? And there are two ways of doing this. The first one that you are probably going to use the most is to mix the quotation marks. Now we have single quotation marks to create a string, and inside of the string we have double quotation marks to explain that we have a quote. This Python is completely fine with. Let me print it actually, test var3. If I run this now, we are getting, he said, this was great. Python has no problem with that. And let me remove the white space. That should make all of this a bit easier to read. While we're at it, I also want to comment out this stuff here at the top, so things are a bit easier to see. Now if I run this, we can see we have quotes inside of a string. This would also work the other way around. If I start with double quotation marks and end with double quotation marks, then inside of here, I can add single quotation marks like this, run it again, and we would also see the result. Now we have single quotation marks. This would be one way to approach this. Although this system has its limitation. For example, if I add a test var4, and in here, we want to have, for whatever reason, a single quotation mark, a double quotation mark, and then a single quotation mark as well. And this would just not work. Python would just get very confused. Not exactly something you would do all the time, but it might come up once every year, and then you have a problem. To overcome this, you need what is called an escape character. Let me add a comment, an escape character. An escape character is, again, a /. And this you need in front of every character you want Python to just interpret as a string. And this you need in front of every character you want Python to interpret as a normal character. So in my case, I want this escape character in front of my double quotation mark and my single quotation mark. And now you can see the comment appears as a proper comment. If I print it, I can see the 2 quotation marks. This way, you can literally add any kind of character without it disturbing your code. As a matter of fact, let me rename this to simple escape character, because escape characters can do quite a bit, which means I want to add another comment for escape characters. What we can do in here, let me comment out the earlier part, and now I want to have a test var 5. And for this one, I want to print some text over multiple lines. Let's say I want to have line 1, some text, and then I want to have line 2, some more text. And I want to tell Python that this should be over multiple lines of code. For example, if you want to build some kind of text editor, you want to store all of the text inside of one string. But when you present a string, you want to have line breaks between them. How could you do that? I guess let me print the test var first. If I run this, we get all of this on one line. And to create a line break in here, we need, once again, the / and then the letter n. If I run this now, we are getting those 2 lines on, well, different lines. /n tells Python that we want to add a line break between these 2 different parts of the string. There are actually quite a few more. For example, /t is adding a tab inside of your string. There's also /r. This one adds another kind of line break. You don't really have to know the difference here. For your purposes, work essentially the same. /n, though, is the most common one. So that way, you can write text over multiple lines. Besides that, let me add multiple lines as a comment here. There's another way to write multiple lines. And this is one way we have actually already seen. What you need here are triple quotation marks, something that Python by default considers a comment. However, if you assign this comment here to a variable, let's call this one test var 6, all of a sudden it changes the color and it becomes a string. And this string is kind of special because for this one, Python does respect the white space, which means now I can press space, end up on another physical line, write some more text, do the same thing again, and then write on another line. If I print this test var 6, Python is going to preserve all of the line breaks. For example, what we could be doing in here, let me actually copy it. That should save some time. I could copy something like this in here. If I run this now, we have the tree we created in one of the very first section of this entire series. And this is a much easier way to see what's going on. Although, granted, because of the first line here, this is a bit difficult to understand. But with all of this covered, we have quite a bit more understanding about strings. Now, there are 2 more things that I do want to cover. The first one is math and strings. And before we start that, let me comment out the earlier stuff so it doesn't get confusing. What you can do, let's call this test var 7. You can add something like one string, hello, and then plus a world. And Python, when it sees this plus, it is just going to combine these 2 strings. If I print test var 7 now, we are getting hello world. Keep in mind here, there's no space between the 2, because neither hello nor world have any white space. One way to add them would be to just add them here and then combine all of these with another plus. You can add as many pluses here as you want. There's no limit on it. This would also work with different types of quotation marks. Python literally does not care. Another math operation that we can use, let me create a test var 8. Let me write a word like copy. I can multiply it. For example, times 10. If I now print the result, I get the word copy copied 10 times. But again, I think this concept here should be fairly straightforward. Let me comment it out. And now we come to the most important section of this entire video. And that is how to get values into strings. And let's do this by example. I have a name, and in here I have Bob. And I have an age, and let's go, I don't know, 40. Now I want to create another, let's call it a greeting string. And this greeting string, I want to say, hello, Bob, you are 40 years old. Let me add the print statement as well so we can see what's going on. I want to have the greeting string, and let's run this. I can see, hello, Bob, you are 40 years old. Right now, the two values are matching. We have Bob here and Bob here, and we have 40 here and 40 here. But this is only the case because I have written Bob. If I change this Bob to Tom and run all of this again, we wouldn't see a difference. So what I want to do is to somehow get this name variable into here and this age variable into here. And Python has quite a few ways of achieving that. The one people tend to learn first is called format. This is just another method. This one works by adding curly brackets inside of your string where you want to add a variable. In my case, I want to replace the name with a curly bracket and the age with another curly bracket. And now I can add values into this format. This could, for example, be a 1 and a 2. If I run all of this now, I can see, hello 1, you are 2 years old. What Python has done here is it looked at the first curly brackets, and then it looked inside of format and found the first value. After that, it saw another curly bracket and looked for the second value inside of format and then inserted it into the string. Granted, just adding 1 and 2 in this example isn't particularly helpful. But what we can do is add variables in here as well, like name and age. If I run this now, we get, hello Tom, you are 40 years old. And this now means we can change these variables, let's say 100 and something. It really doesn't matter what it is. Although you do have to be careful about the order. If I switch them around with age coming first and then name, now we have hello 100, you are something years old. The order here being wrong messed all of this up, which can be kind of annoying, especially if you have longer strings where you want to add more variables. This can become very confusing. And as a consequence, Python has a way to make all of this more organized. You can, inside of the curly brackets, add something like variable names. Let me call them 1 and 2. And now you can assign 1 to name and 2 to the age. If I run this now, we are getting the same outcome. Although now we know very specifically which value is being assigned to which curly bracket. 1 gets this one here, and 2 is getting this value here. Meaning now we could assign age to 1, and I guess we could keep age for 2 as well. If I run this now, we get hello 100, you are 100 years old. The reason is we are assigning age to both 1 and 2, which is putting this age into here and into here. And that way you can be much more deliberate about where you put the variables. That being said, very few people use this kind of method because when you look at it, it's kind of inefficient. Why do we have to add a whole method with arguments? Why couldn't we just add variables straight inside of these curly brackets? That would be much better. And Python developers agree, and to achieve that, they have created what is called an F string. Let me create another variable. Let's call it greeting string better. For this one, I want to copy this entire string and paste it in here. And now I am going to add the variables I want straight into the curly brackets. We have name for hello and age for years old. Although now, if I print greeting strings better, I am getting hello name, you are age years old. Python interprets this and this as a simple part of the string, which isn't ideal. To tell Python that these are supposed to be variables, we have to add an f at the beginning of the string. And that is all we need. If I run this now, we're getting hello something, you are 100 years old. And you can see it by the colors. The name and the age are not green anymore, which in our case means they are not a string anymore. Although your colors may vary depending on what color scheme you have. We can, let me return to Bob, who is 40 years old. This is still going to work. And this version here is much more readable than this one up here. I guess, let me fix it. This is better. But still, this one here is very annoying to read, whereas this one is really clear. And f-strings can actually do quite a bit more. Inside of these curly brackets, you could even do basic math operations. For example, we could add age plus 10. All of this would also still work. With that, we have covered a lot of stuff for strings, and I think this part is getting quite long. So let's do an exercise and then finish it off. And what I want you guys to do is this one here. I want you guys to create an f string that says, hello, my name is X and my hobby is Y. X and Y should both be separate variables. And the second half of the sentence should be on a separate line. And by second half, I mean, and my hobby is Y. This should be on a separate line when it is being printed. Pause the video now and try this one yourself. Let me comment out all of this here so we're not getting confused. And now let's go through this step by step. First of all, I want to start by creating an f string here. Let me copy it and let's call this the exercise string. In here, I want, hello, my name is X, my hobby is Y. Since we want X and Y to be in separate variables, X should be in curly brackets and Y should also be in curly brackets. And since we want Python to interpret these as variables, we need an f at the beginning of the string. So now we have to tell Python the values for X and Y. Let me put X here and Y here. Let's say for X, a value we haven't used yet is Lisa, and I like, I don't know, programming. With that, I can print the exercise string, and we have, hello, my name is Lisa, my hobby is programming. This is already covering the first two parts of the exercise. Next up is the second half of the sentence should be on a separate line. And this we could approach in two different ways. The first one is we could use an escape character, meaning /n. And now if I run this, we get, hello, my name is Lisa and my hobby is programming on two different lines. Another way of approaching this, let me copy it. You could use triple quotation marks. So I add 2 at the beginning and 2 more at the end. Now I get rid of the line break and put all of this on separate lines. I guess let me call this exercise string 2 and now print 2, and we're getting the same result. These two lines here and this line here both do practically the same thing. Although I guess this one is a bit more readable. Well, I guess it's debatable. You could choose here whichever you like, although be aware the first one is much more common. Also keep in mind here, the variable naming I used, capital X and capital Y, is quite bad. This should rather be called name and hobby. In this part, we are going to learn 2 more data types, lists and tuples. Both are very similar and both are simply data containers for other data types, which means they are storing other kinds of data. That's what a container does. And they can contain any kind of data. This could be a string, a number, it could also be a Boolean, other lists and tuple, and a lot more. There's no limitation on what they can store. A tuple would look something like this. We are starting with normal brackets, and we're also ending with normal brackets. And inside of that, we have values that are being separated by a comma. For example, in this case, we are starting with an integer, then we are adding a comma, then we have a string, another comma, then we have a Boolean value, another comma, and then we have a tuple inside of this original tuple, which Python is totally fine with. And inside of this tuple, we have another string. And that is the only value for this tuple, so it really doesn't make too much sense. I just wanted to illustrate that you can do it. Besides a tuple, we have a list. And a list is looking very similar. The only difference now is that to create a list, we need square brackets. But other than that, we are still adding values inside, like integers, strings, booleans, and other lists, and we are separating each value with a comma, like here, here, and here. On the surface, those two would look identical. And you would be kind of correct, the two are very similar. But there's one incredibly important difference. Tuples are what is called immutable, which just means that they cannot be changed. For example, you could use something like list append, and this would work because a list can be changed. But a tuple and appending a value would not work because we cannot change a tuple under any circumstance. If you really wanted to add a new value to a tuple, you would have to create a whole new tuple and combine the old values with a new value, which you can do fairly easily. But if you are going to do that, you could just use a list. It would be much easier. That being said, because of this immutability, tuples process a tiny bit faster in Python. Although the difference is so small, you are hardly ever going to notice. I guess let's have a look at all of this and see how far we get. Let's get started by creating some lists. And a list, let me store it in a variable again. You are always creating with square brackets. And in here, you are adding values that are separated by a comma. For example, you could be adding numbers like 1, 2, and 3. You could add floating point values like 4.5. And you could be adding words like, let's say, word. Those are the data types we have already seen, but any data type would be valid in here. Now, if I print my list, we can see the output we have entered into this list. It does work pretty seamlessly. What you can also do is to use the functions we have already seen. For example, len is now going to give us the amount of items we have inside of this list, which right now is 5. Finally, you could also use the list with methods, and lists do have quite a lot of methods. I suppose a simple one would be clear. This one removes every value from the list, meaning if I print my list after running this method, I am getting 5 items from this line here, and this line now is going to print an empty list. I suppose if you want to look this up, in Google, all you would have to do is look for something like Python list methods. Once again, you are going to find a lot of different websites that talk about it. The official Python documentation, this one here, is probably the one you want to use. And in here, let me hide this one, we have append, extend, insert, remove, and a lot more. The one we have just seen was called clear. This one is removing all items from a list, and it is equivalent to something else. What this part here means, we are actually going to learn in a couple of minutes. It's super useful. For now, just keep in mind, there are a lot of different methods in here that you could be using. Another easy one would be reverse. This one reverses the list. Let's have a look at this one. I suppose we could change clear to reverse. And now, if I run the code, we are getting the entire list in the reverse order compared to this list here. Just like with words, or well, with strings, the main way you are going to learn the different methods is by just using Python and encountering different problems and finding the solutions to them. And most of the time, the solution is going to involve some kind of method. At some point, you are going to get used to different methods for a list. That being said, also, you don't need to know all of them by heart. I myself completely forgot about reverse until I saw it when I prepared for this video. But, well, with that we have lists, and I guess we have functions, and we have methods, at least in a very basic outline. Although there's one really important method that I do want to talk about, and that one is called append. And this one appends a value. I think the name makes sense here. Basically, anything you add in here as an argument will be added at the end of the list. For example, if I added, let's say, a 10 at the end, run all of this, now we can see all the way at the end, we have this 10. This would be one of the ways you add an item to a list. There are quite a few more, but this is a really basic one that I just want to cover for now. With that, we can look at the other kind of container, and that is called a tuple. And the tuple, let me save it in a variable that I called my tuple, you would be creating with brackets. And in here again, you can add any kind of value you want. Could be a number, could be a floating point number, it could be a word, or it could be a list as well, that itself contains other values. Let's say 7, 8, and 9. Let me comment out the earlier stuff and print my tuple. And there we go. Now we can see all the values we have added in here. A tuple and a list work in very similar ways, at least up to a point, because there is a major difference. That difference being that tuples cannot be changed under any circumstances. This means I couldn't run something like my tuple, append, and then let's use a 10 again. The method we have used up here. If I run this line of code, we are getting an error. That tuple object has no attribute append. We also couldn't delete a value, and we couldn't reverse the order of this tuple. Let me demonstrate the reverse one, this one here. This one also would not work on a tuple. Most of the time when you are using tuples, you generally only want to use tuples when you know you are not going to change the values. But most of the time, let's say 70–80%, you are going to use a list. This one is the much more common data type because it is more flexible. With that covered, we have to cover a really important topic, and that is how to pick elements from a tuple or a list. What that means is, for example, I might want to get this floating point value here from the list and then work with it. So how could I get this value? And for that, we need a specific process that in Python is called either indexing or slicing. The two are very much related. Let's talk about it actually. Let me actually go through this a bit more properly. To restate the problem, we want to pick one element from a list. This could also be a tuple. They both work in exactly the same way. For us to do that, we need to cover two important concepts. The first one is that Python assigns each value in a list or in a tuple an index number. If this is our list, Python would give each of these numbers an index. The first number is always going to be a 0, and then every successive number is going to be +1 of that number. Meaning the second value is 1, the third value is 2, and then so on. And a really important point to notice here is that we always start counting from 0, not 1. And this can be a very annoying concept to deal with. I think for beginners, forgetting about this covers about half of all of your errors. Just be ready for that. But anyway, the concept we have for now is that every item inside of a list has an index. And this index we can use to pick an element. And this works by adding square brackets after the list or tuple. In practice, this would look something like this. Right now, we have our list, and then after the list, we have another set of square brackets with an integer. And this integer is going to pick one specific index. Right now, the index 1, which is going to be the second element, this one here. Meaning this operation would return the value 2. And since we are using an index, this entire operation is called indexing. It works on quite a few data types. Lists and tuples should be fairly obvious. We could also be using it with strings because they are basically another kind of container. We can have a look at this one as well. However, indexing does not work on dictionaries and sets. Dictionaries work in a slightly different way and sets work in a very different way. We are going to see that later on. And I guess let's play around with all of this. Here I am back in my code and I want to comment out the two methods for the tuple and I want to uncomment my list. Meaning now I have a list and a tuple to work with. And I want to just pick some random elements from them. I guess we can start with my list. And in here I am using square brackets and now I need an integer. I'm going to pick 0 just to pick the first element. This 0 now is going to refer to the first element inside of my list, or the one with the index 0. If we added a 1, we will get the next element, 2, 3, 4, and so on. To show all of this, we have to print it again. Now, if I run this, we are getting 1 indeed, the value up here. If I added a 2 in here and run this again, we are getting the integer 3, which is this item here. We have 0, 1, and 2. All of this would also work with a tuple, meaning if I use my tuple, this tuple here, and now pick, let's say, the item number 5. Run this again, we are now getting the list, this one here, at the end of the tuple, because this one is the element with the index 5. We have 0, 1, 2, 3, 4, and 5. What we can do now as well is to add another square brackets afterwards, because remember, what we are getting from this one here is going to return one item from this tuple. In this case, this list here, which means that this operation here stands in for this tuple. So when we add the square brackets afterwards, these ones here, we are basically adding the square brackets after here, and then we can take other elements from that. If I add a 0 in here, we should be getting 7. My tuple 5 gets us this list here, and then the 0 gets us the first element inside of it. These operations are fairly common. Right now, I assume they do seem quite confusing, but if you play around with them for a while, they should become fairly familiar. Just remember what is getting returned and how you can work with that. There's one more thing that you could be doing in here. Let me duplicate the line. I only want to use one indexing operation. What you can also do is go in the negative direction. For example, if I use -1, we are getting the list again. What this -1 means is we are always starting at 0, and if we go in the positive direction, we are basically going to the right. However, if we are choosing a negative number, we are going all the way to the back of the list and then going in the opposite direction, meaning this list here would be -1, word would be -2, and the 1.45 would be -3. Which means that -3 and 4 should have the same result, unless I made an error. Let's try. If I enter -3, we get 1.45. If I add 4, we are getting word. And I just realized I can't count. Sorry about that. This should be a 3 and this is a 4. Talking and writing can be kind of challenging. I guess you noticed this one already. But now, what you should be able to see is if I add a 3 in here, we are getting 1.45. And if I add a -3, we are also getting 1.45. All right. With that, we have basically all we need to get started with indexing. This is a very simple operation when it comes down to it. Although this video is getting kind of long. So let's do an exercise and then we finish this section. And what I want you guys to do, let me paste it in. Here's the exercise. We have a long string. And of the string, I want you guys to pick one word or string, and that is hello. that is going to be this element here. Although do notice here that this is a list inside of a list inside of another list. So you have to pick elements that are quite a bit nested. But if you paid attention so far, this should be doable. So pause the video now and try this one yourself. Righty, let's get started. And just to illustrate what is happening here, let me save all of this in a separate variable that I want to call solution var. And this is going to be, we always have to start with the exercise list. Now we need square brackets, and we want to pick one item from here with the index. We have item number 0, we have item number 1, and we have item number 2. And item number 1 covers this entire list here. This is what we want. Meaning in here, I want item number 1. Which means if I print the solution variable and comment out all of the stuff above and run all of this now, we can see we have the list with 1, 2, 3, 4, 5, and then the other list inside. And from this, we want to get another index. Now we have, let me clean this one up a tiny bit. Purely inside of this list here, we have a few more elements. We have 0, we have 1, and then we have 2. 2 being this entire thing. This is all we want right now. Which means we now want the index number 2. Now, if I print my solution, I get another list with 0 and hello. We are getting very close. Now, inside of this final list, this list alone here, we have 2 entries. We have 0 and we have 1. And 1 is our solution. Which means at the end of this, I want to add a 1, and then we should be done. So let's try, and there we go. We get hello. Obviously, you would very rarely see something like this. This is very poor data management because it's a very messy list that is really hard to work with. But I guess it's a very good exercise. This video is going to be part 2 on lists and tuples. And this is primarily going to be about picking multiple elements. So the main problem we have to cover is how to pick multiple elements from a list. Let's say we have a list with the numbers 1 to 4, and we want to get the second and the third element. How could we do that? Right now, we can only pick a single element. Fortunately, Python can do this with something that is very similar compared to indexing, and that is slicing. How this works is you are still going to need square brackets, like with indexing. But now, instead of adding one number, you are adding 2 numbers separated by a colon. The first number is the start, and the second number is the end value. For example, it could look something like this. For example, in here, we have the indexes from 0 to 3. 1 right now is going to refer to this 2 here, and 2 is going to refer to the index number 2, which right now is going to be a 3. This is how we are picking the start and the end value. However, there's going to be a really important concept you have to understand. And that is, Python only goes up to the end, but it does not include it. Which means in this case, we would only get one number. We would be starting on this 2 here. That is our start value. However, we are only going up to index number 2. We are not including it. So in practice, our list indexing ends here, right before our end index. As a consequence, this operation here is only going to return this 2 and nothing else. That is going to be a fairly common issue, but you will get used to it. Let's practice this one. Once again, here I have a completely empty Python file, and I want to create a test list, and that is the list we have just seen. This one has the values 1, 2, 3, and 4. And just to demonstrate what I've just talked about, I want to print my test list, and in here, I want the values from 1, 2. If I now run this, I am getting another list with 2. That means that list slicing always returns a list, even if there's only a single value inside. For example, what we could even do is go from index 1 to index 1, which would get us, if I run this, an empty list. And this is something you always have to keep in mind. If you want, in this case, for example, the second and the third element, you have to go to the index after that. In this case, this is going to be 1, 2, 3. If I run this now, we are getting the numbers 2 and 3. And that for start is all you have to know about slicing. Although you can do quite a bit more, but let's talk about this inside of my slides. Besides the start and the end value, you can also add a third number for the direction. By default, this one is going to be 0, meaning we are always moving +1 in the positive direction. It might look something like this. We again have the same list, and we have our indexes 0, 1, 2, and 3. And this one here at the end means that we are moving in the positive direction in a step size of 1. Which right now would get us the next element, but we could have a larger or smaller value. You could also have negative values to go into the other direction. Here we are back in the code, and I want to add a few more values to this list so it's a bit easier to visualize what's happening. Now we have the values from 1 to 10. Although if I run this one here, it is going to give us the same result. But now let's say I want to have the values from 0 to 8. If I run this, we are getting the first 8 values. Although now what I can do, I can add another set of colons and then, for example, add a 2 in here. And now if I run this, I am only getting every second value. So we are starting at the index number 0, and we are only ever picking every second value, which is the 3, the 5, and then the 7. And since our last index is going to be here, we are not including this 9 anymore. And then we are getting the values 1, 3, 5, and 7, the values down here. And this step size can also be negative. For example, you could in here add a -1. Although right now this wouldn't do very much. So the issue here is we are starting at this value as our starting point, and our end value is 8, which I believe is this value here. And since we are now moving in this direction, there simply isn't any value. So this entire operation doesn't give us anything. However, what we can do is flip those two around. So our start value is 8 and our end value is 0. If I now run all of this, we get all of these values reversed. And negative values you can add actually everywhere in here. So for example, you could have the start value of -1 and the end value, let's say, at 4. This is going to work just like normal indexing. This would mean you are starting here all the way at the end. That is the -1. And then we're going to the fourth element, which is going to be 0, 1, 2, 3, and 4. This one here is index number 4. So we are expecting to get the numbers from 10 to 6. Let's see if that's the case. And it is. We get numbers from 10 to 6. And that is basically all you have to understand about the basics here. Although there's one more thing that you can do. And that is you can also leave values entirely empty when using slicing. This might look something like this. This does look a bit strange, but it does work. What it means is, let me talk through it. Every number in the slicing operation has a default value. So we have a start, an end, and a step value. For start, the default value is always the very first item inside of the list. In the example here, it would be a 1. The end value, by default, is always going to be the last item inside of the list. In this case here, that would be a 4. And for the step size, the default value is a 1, which means we are always moving +1 in the positive direction by default. This one should make sense. It's quite straightforward. And let's play around with all of that. Let's see how far we get. So here we are back in the code, and let me actually add all of this inside of a variable. Let's call it negative slicing. I should probably add more variables so it's easier to follow in the notes. But let's start working on leaving values empty. This I want to save in a variable. Let me call it default slicing. In here, as always, I need my test list. And in here, I want to go from my start to the end of the list. And I only want to get every second value. Now, the start is going to be easy because this one is always going to be 1. But you could also leave it completely empty. It would have the same result. And here, we could also leave empty. That would get us the very last item inside of a list, 10 right now. And this is actually really useful because by default, we don't know what the last index is going to be. Finally, I want to have every second element. This would be a 2 in here. And now, let me print the default slicing variable. Let's run this. And we're only getting every second value. We could also add every third value in here. And there we go. If you left all 3 of them empty and run this again, you would get all of the numbers. So this is looking a bit strange, but it certainly is working. And this system can be incredibly useful. As a consequence, let's do an exercise. And what I want you guys to do is this exercise here. I want you guys to start from 8 and go to 2 and only pick every second element. And when I say 8 and 2, I mean actual number, not indexes. So you want to start at this 8 here and then go to this 2 here at the end. These are the values you are going to cover, except only every second element, meaning this 7 shouldn't be in here, this 5 shouldn't be in here, and so on. So pause the video now and try to figure this one out. Let me save all of this inside of a variable, and as always, we need the test list. In here, we need square brackets for slicing, and now we need a start, an end, and a step size. Since we do have to go negative, remember we are starting from 8 and we are going to 2, this has to be a negative number. Let's say -1 now, just to have a start value. While I do this, let me show the solution. Right now, what we are going to get is the entire list in reverse. Although in my case, I don't want to start at 10, I want to start at 8. Meaning we have to figure out how we can get this 8 here. That would be our start value. And one mistake you could be making in here is simply add an 8, because this would not work. Right now, we are starting at 9. The problem here is, remember, when we're using indexing, we are starting at 0, meaning this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Meaning if we are adding the index 8, we are adding on the 9 here, which isn't helpful. Instead, what we could do is add a 7 in here, and now if I run this again, we are starting at 8. Alternatively, what you could also do is add a -3 in here. If I run this one, we are also starting at 8. And I guess, remember, we could also go negatively, so this 9 would be -1, then we have -2 and -3, that would be our 7. Both would be fine, it's really up to you what you prefer. I guess the 7 here is a bit more expressive, but, well, it's basically subjective. But now we have to find the end value. And in here, you might be very tempted to pick 1 for the index. Let me actually do that. If I add a 1 in here, run this again, we are ending on 3 as our final element. The reason is that Python always only goes up to the final element, but it doesn't include it. As a consequence, 3 is going to be our final element. The way around that one is this should be a 0. Now our final element is this 0, so we're going up to that element, but we're not including it. So 2 is our final number. The final thing we need is we only want to pick every second element. This is quite easy. All we need is a -2. If I now run all of this again, we get 8, 6, 4, and 2. And with that, we are done. This is basically all you need for slicing. And this would also work for a tuple. I guess, let me demonstrate this one really quick. Let's call it tuple slicing. And in here we have a test tuple. And this one would just have the values 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And in here, I could, for example, print test tuple with the values 0, 5, and let's say 3. It should be a colon. And let me comment out the exercise here. And there we go. We get 1 and 4. Once again, A list and a tuple are incredibly similar. The only difference is that a list can be modified, whereas a tuple cannot. There is one more topic that I want to cover with lists and tuples, and that is unpacking. Basically what that means is both lists and tuples can be unpacked in a way like this. We have A and B, and we are assigning a tuple to them. What this is doing, we are taking the first value and assigning it to the first variable, A and 10 in this case. And the second value gets assigned to the second value. And that way you are unpacking a tuple on two variables. This would also work with a list. You would have the exact same result. And let's have a look at all of this in code. So for example, what we can do, I have a variable called A and a variable called B. And I want to assign them to the values 10 and 5 inside of a list. And this is, well, all we need. If I now print A and print B, we are getting 10 and 5. We have unpacked this tuple onto these two variables. Although keep in mind, this only works if you have the same number of items as you have variables. If, for example, I added a third item to this tuple, let's say a 1. If I run this now, we are getting an error that we have too many values to unpack, and Python expected 2, which we don't have. But if you have the same number of variables as you have in the tuple, you are good to go. And this would also work inside of a list. So let me add 2 more variables. Let's say C and D. And now we have a list with, 20. And this also works with strings. Let's say hello. If I now print C and I print D, we are getting 20 and hello. And this you can also make more powerful. Because when you are creating a tuple, you don't actually need brackets. For example, you can have a list like this, or you could create a list like this without the brackets. Just having values separated by a comma automatically creates a tuple. Although most of the time when you want to create a tuple, it makes more sense to write the brackets because it's clearer what you are doing. But you don't actually have to do it. Now, where all of this becomes really interesting is when you combine these two approaches. Because by doing that, you can assign multiple values to multiple variables on a single line of code, which is super powerful. For example, we have the variables A, B, and C, and we are assigning the values 1, hello, and 4.5. We have assigned values to 3 variables inside of a single line of code. So let's have a look at this one in practice, and then we can do an exercise. For example, for a video game, you could have health, you could have energy, and you could have a weapon. And this you could all assign inside of a single line. For the health, we could have 100, for the energy, we could have 50, and for the weapon, we could have a sword. And now, I could print weapon, for example, and all the way at the end, we are getting sword. And I hope you see the value of this. If you have to assign multiple variables, this is really, really useful to keep your code a bit more organized. And all right, this video is going to be a bit shorter. We can do the exercise right away. And what I want you guys to do is this. We have a variable 1 with the value 10 and a variable 2 with the value test. And I want you guys to switch the values of these two variables, meaning value 1 should have the value test and value 2 should have the value 10. So pause the video now and try to figure this one out. All right, the solution here is actually incredibly simple. All you have to do is you want to assign value 1 and value 2. And what you want to assign them to is value 2 and value 1. Basically, what we're doing now is for value 2, we are assigning it to value 1, and value 1 gets assigned to value 2. This is basically how you would switch around different values across different variables. Meaning now, if I print value 1, let me run this, we are getting test. The value that used to be in the second variable. Before we're getting to the next section, I want to do a short intermission. And this one is strings, lists, and tuples, because those are surprisingly similar. All 3 of them are basically just containers. They just happen to have different formats. And as a consequence, you can move between them very easily and also use indexing on strings. Let me demonstrate all of this actually. I already have two variables, a test string and a test list. I suppose we can start by turning a string into a list or a tuple. The two are very similar. We don't really have to worry about the difference here. And to convert a string to a list or tuple, you have a couple of different ways. The first one, we can use the test string and then use the method split. And this one splits the string at a certain point. If you don't specify anything in here and print the result, we are using a space to separate the values. If you enter a value in here, let's say a t, and run this again, we now separate this wherever we have a t. We start at the beginning here, and the t in there disappears, meaning now in the string, this t disappears, and we have an empty string at the beginning of the list. Then we have all of this stuff here up to the next t, which is his is a and then a space. Then we have the next t here, and this one then gets us to the next point, the es bit, this one here. And then finally we have another t, and this one disappears, and we are just left with an empty string. Most of the time, you are just going to use this space here. This one does make a whole lot more sense. Another thing you could do is to use the list function. And this one turns any kind of data type into some kind of list, or at least it tries to. It doesn't work with every data type, but a string definitely does work. If I run this, we are now turning every single character into one element inside of a list. This would also work with a tuple. This is another function. Here we can add a test string once again. And now we have the same thing, except now it's a tuple instead of a list. The other way also works just fine. We can turn a list or a tuple into a string. Although the process here can be a bit weird. Basically, what you would be doing is you first get a string. And right now, I'm going to leave it empty intentionally. Then I need a dot, and then I need a specific method. And this method is called join. And into this method as an argument, I have to pass in some kind of list. And as an argument here, we are going to need a list or a tuple. Although it has to be a special kind of tuple, because this one has to contain some kind of string. Let's say 1 and 2, just to keep it simple. And now if I run this, these two elements here have been merged together. What we are specifying inside of the string is going to be what determines the gap between the two. Right now it's empty, so there's no gap between 1 and 2. I guess I could just add the gap in here. If I run this now, we get 1 gap 2. If we added more values in here, let's say 3 and 4, we would always have a gap between each of these values. Most of the time, you are just going to leave it empty, and now you have one space between the values. What you really have to be careful here, though, is that all of these values have to be a string. I guess let me copy it and replace this with the test list we have up here. If I run this now, we are getting an error. That Python has a type error, sequence item 0, expected a string instance int found, which is Python's way of saying it wanted a word or a string, but it found a number, and it's really not happy about it. Finally, what you can do is to, let me print it again, you can use the str function and pass in a list in here to turn this list into a string. If I run this now, we are getting what looks like a list, but this is actually a word or a string. To demonstrate this, let me put all of this inside of the type function. If I run this now, we get class string. This one here is going to be a string. It just looks like a list. But I hope you get the idea. One more thing really quick, and that is indexing on strings. This one works like it would work for a list. For example, I could have my test string, and then here I want the first element, which right now should be a t. If I print all of this, I am indeed getting a t. Just like with a list, in the string, the first element is going to be a 0, then we have 1, 2, 3, and so on. You could even use slicing here and, for example, add a 5, and now we're getting this, the first word. And I think it is quite valuable here to compare these two data types, because when you think about words, they really are just containers for individual characters. And for Python, it made a lot of sense to make these interchangeable with a list or a tuple because, well, it does make kind of sense. One of the major operations you are going to do as a programmer is to work between different data types. So understanding how you can change one data type to another data type is a really valuable experience. But okay, there's one exercise I do want you guys to do, and that is going to be connected to this operation here. Let me copy it and add an exercise here at the end. What I want you guys to do on this string test list, I want you guys to use string methods to remove all of the stuff so you only get 1, 2, 3, and 4. Let me comment out all of the other parts to see what we get. Right now, we're getting square brackets, then 1, 2, 3, 4, and square brackets again. And I only want to have 1, 2, 3, and 4. Try to use some methods to get rid of all of the other values besides the numbers and see how far you get. To make this a bit easier, let me save the result in a separate variable. Let's call it exercise. This is also what I want to print. Right now, we have to get rid of a couple of different things. Let's start with the square brackets. For those, we need the method we have already seen much earlier called strip. And this one, we want to start with one of the square brackets. Doesn't really matter which one you start with. If I run this now, we get rid of one square bracket. And remember, we can combine different methods, meaning I can call strip again, and now add the other square brackets, the closing one. We now have all the numbers and the commas in between them. And to get rid of the commas, we want to replace them, meaning I want to target my comma and then replace it with an empty string, so nothing. Now if I run this, we are only getting the numbers 1, 2, 3, and 4, and we are done. If you wanted to, you could even get rid of the spaces here as well. And this you would achieve with another replace method. And now I want to target the empty space and replace this with nothing. Now if I run this, we have all of the numbers right next to each other, whichever you prefer. At this point, this is hopefully at least manageable. The next important data type is a dictionary. And this one is a more complex container, but still just a container for other variables. This one always has a key and a value pair. The example for that I have is this one. In here, we have a key and we have a value. The key right now is an integer, the 1. But it could also be any other data type. Python is fairly flexible here. And then we have a value, this one here, a list, but again, it could also be any other data type. What you ultimately have to understand about dictionaries is that they are a container, but a more organized one, where every value has a key associated, and you would use the key to access the value. That way, you wouldn't go by indexing, you would instead have specific values. We're going to cover that in more detail later on, but let's start playing around with that. Let me start by creating a test dictionary. And a dictionary you always create with curly brackets. And inside of the curly brackets, you need a key, then a colon, and then a value. Both of those have to be valid Python data types. For example, for the key, let me call it capital A. And the value could just be an integer, let's say 1, 2, 3. This would now be one key value pair. If you want to add a second one, you would add a comma and then the second key value pair. Let's say I want to call this one B, and now I need a colon again. And for the value now, I want a list with the values, I guess 1, 2, and 3 again. I guess let me print this one so we can see the result. If I run this, we can see we have a dictionary with two key value pairs. Right now, the key is always a string, but this doesn't have to be the case. You could also use a number like 1 and then give it the value of, I guess we haven't used a Boolean yet, so I can just add true in here. If I now run this, we get another key value pair. The one limitation you do want to be aware of here is you cannot duplicate keys. For example, if I added another A with, I don't know, let's say another value, and if I now run this, this first value has disappeared. The reason being that once we add the same key, we are overwriting the original key value pair. Although most of the time that really isn't an issue you are too concerned about. And once again, you also have a ton of methods you could be using for dictionaries. To go through all of them, here is W3Schools with a list of all of the methods you have available. Some that you are going to use fairly often are values, keys, and items, this one here, because those return specific parts of the dictionary. Let's play around with a couple actually. Right now, if I run this, we are getting the entire dictionary. But if I add another method here and add values, don't forget the brackets, run this again, now I am getting some kind of list looking thing with just the values from this dictionary. Keep in mind, this is a different kind of data type. If I put this into the type function, run this again, we are getting class dictionary values. This is a completely separate data type in and of itself. Although you don't have to worry about it too much. There are specific use cases for it, and they all work basically automatically, and you never think about the data type here. The other method would be keys, and this one gives you all of the keys, again, in a dicKeys data type. Finally, what we could also be looking at is items. And this one is going to return the list, but now it has tuples inside. And those we could also access. We are going to learn how this works later on. And if you go through the list of the different methods, this one should be fairly straightforward. Besides that, you can also use, once again, the len method is incredibly versatile. In here, you can add the test dictionary, and we would get 3, meaning we have 3 key value pairs inside of this dictionary. We have 1, 2, and 3. And that's kind of it for the basics of a dictionary. It really isn't that complicated. I guess let me add a comment here at the top for basics of a dictionary. One topic I do want to cover really quick is converting a dictionary. For example, what we could be doing, I guess let me print the results straight away. I could get my test dictionary and convert it to a list, for example. If I run this, we are now getting an actual list with all of the keys, meaning the list contains A, B, and 1. Something you really want to keep in mind when you are converting the data type here. Tuple would result in the very same outcome. I guess finally, you could also convert all of this to a string, and then you would get the entire dictionary as a string. Probably not the most useful thing you could do, but well, you can do it. I do want to cover one more important thing, and that is indexing with dictionaries. And here we have a problem, because indexing, the way we have learned it so far, does not work. And I think this makes sense. If you have a dictionary like that, and you want to add some kind of indexing operation at the end, let's say with the number 0, this to Python would be kind of confusing. This could for Python mean you want to have the first item inside of the index, or it could mean you are supposed to look for a key with the value 0. In this dictionary, this doesn't exist, but Python doesn't know it when it sees this number here. As a consequence, the normal indexing does not work. But there is another way. Actually, there are two other ways. You would do something like this. Instead of an integer, you would add the name of the key. In this case, we have square brackets with an A. And the A refers to this key here. What is then being returned is the value associated with the key, which is the 1. Another way of doing this is the method get. This one works in the same way. You are passing in a key. This key looks for a specific key value pair in the dictionary, and we are getting the value associated returned. Back in my code, I want to print test dictionary, and now I want to get the value for capital A. If I run this now, we get 1, 2, 3, which is the value we have gotten all the way up here. Along the same lines, instead of using square brackets, you could use the method get, and in here pass in the key you are looking for. And you will get the value associated with it, 1, 2, 3 again. You may be wondering now, what is the difference between these two approaches? And generally, get is slightly better, because if you're looking for a key that doesn't exist, let's say X in this case, if you use square brackets, you are going to get an error, meaning your entire code is going to crash, which usually is not a good sign. But if you use the get method, you don't get an error, instead you get none returned. Which means, let me add comments, doesn't crash when it cannot find a key. And I guess the comment here would be does crash when it doesn't find the key, or a key. Besides that, the two approaches are pretty much identical. And with that, we have covered all of the basic things for this part. So let's do an exercise. What I want you guys to do is to do some research and look up the update method for a dictionary. And via this method, add another key value pair to this dictionary. Once again, I am on a website that looks at all of the different methods that we could be using with a dictionary. And the one we want to look for right now is called update. If I click on it, we have an example, a definition, syntax, and quite a few different things that we could be doing. Usually what I'm looking at is the example. In here, we have one dictionary, and then we are using the update method, and we are passing in as an argument another dictionary. And this dictionary has a key and a value pair, and this is going to insert all of this into the other dictionary. So let's have a look at this. I want to get my test dictionary, and I want to use the update method. And what we have seen so far is to insert another dictionary. And in here, we can just add some values. Let's say I want another key, that's not how you spell that, then a colon, and then some other values. I guess what we haven't used yet is a tuple with, some other values in here. If I run this, we are not going to see any difference because we are not printing our new dictionary. Meaning now, if I print my test dictionary, I can now see another key and 1, 2, 3 at the end. Although you could be using this method in another way as well. Let me get rid of the argument we had so far. And what you could be doing as well is specify some kind of name for a key, in my case C, and then specify a value. Let's say, let me call it test. If I run this now, we get a string C and then test as another value. And you could even add multiple values in here. Let's say D is going to be, 1, 2, 3. It doesn't really matter. And with that, we have, another value. I suppose while we are here, there's one more way to add a value inside of a dictionary, or a key value pair to be more specific. And that is by using test dictionary and then using brackets and specifying a new key here. This is very similar to using the key here, except now we are creating a whole new key value pair. A value we haven't used yet would be E, And now you can just assign a new value to it. Let's say 100. If I now run this, we have all the way at the end the key E with the value 100, the thing we have specified here. And that is basically all you have to know about dictionaries. It really is a fairly simple data type, but one that gives a lot of order to your code. The final major data type is a set. And these are also simple containers, just like the other containers we have seen. But this one is kind of different and special in some way. It would look like this. We still have curly brackets, like in the dictionary, at the start and at the end. And inside we have values separated by a comma. So far, all of this is really straightforward. The only difference compared to a dictionary is we don't have keys, we just have values. Where a set becomes unique is that every single value inside of a set has to be unique, and any kind of duplicate will be deleted. Once more, I have a completely empty Python file, and I want to create a variable, let's call it my set. And here, I need curly brackets, and inside of those, I want to have some values I want to have separated by commas. Once I have that, I can print this variable, run the code, and we can see we have some kind of set. You know it's a set because we have values surrounded by curly brackets without any kind of keys. If they had keys, it would be a dictionary. The one crucial thing you have to understand is that if I have a duplicate value in here, let's say I have 2 4s. If I run this again, the second 4 is going to disappear because every value in here has to be unique, and Python is going to get rid of any value that is duplicated. Let's say duplicate values will be exterminated. All right, but other than that, we can do quite a few normal things with a set. For example, we could print the len of my set that is not a bracket. Let's run this now, and we know this set has a length of 4 because we have 4 elements inside of it because we get rid of the duplicate values. What you can also do is to use methods, and sets do have quite a few. One that is fairly popular is you can add another value. And in here, you just add as an argument the value you want to add. And if you run all of this now, we have a 5 added at the end of the set. Along the same lines, you can also remove a value. And let's say I want to remove the 2 in here. If I run this now, we don't have a 2 in the set anymore. For the full list of all the methods you have available, let's use a different website. This time I'm using a website called Geeks for Geeks. This one is also quite good for Python, and I do want you guys to get used to looking at different websites. They all do very similar things, but slightly different. So it is a really good idea to understand different ones. All I really did was I typed Python set methods into Google, and there we have W3 Schools, we have Programmis, we have Geeks for Geeks, and we have the Python documentation. These are the 4 that usually come up in Google that tell you all you need to know about specific parts of Python. In here, if you scroll down, you have a whole list of all the methods you could be using. The one you have just seen was add, and this one adds another value. And in here, well, you have a lot of different stuff you can work with. And the list really isn't that long. It should be fairly easy to work with. Now, there's one thing that is quite limiting for sets, and that is that indexing and slicing does not work. I guess let me put these 2 print statements at the top, and now I want to print my set and then the one with the index 0. If I run this, we are getting an error. And the type error we are getting is set object is not subscriptable, which is a Pythonic way of saying that you cannot use indexing for a set. As a matter of fact, there actually isn't a really easy way to pick one element from a set. The one that gets closest to it is to use the pop method. Let me comment this one out, and instead, I want to have my set and then use the pop method. If I run the code now, we are getting a 1, or the first item inside of the set. However, what this one is doing, if I print the set after this operation, the 1 has now disappeared. The reason being that this pop takes the first item from the set, returns it, and then removes it from the set. If you call this multiple times, at some point your set is going to run out of items. Which, again, very often is not what you want to do. Sets are not designed for indexing or generally to pick items from them. The actual use case is something entirely different. I'll cover that in a second. But first of all, we could actually do a really interesting exercise just in the middle of this. And the exercise I want you guys to try is to use type conversion to get one item from the set by index. Basically what that means is you should try to convert this set into another data type, and then on this data type get the index. The main thing I want you guys to take away from this is that you can very easily change the data type of something in Python and then use different methods or different operations. So see if you can figure this one out. We know that we cannot take the index of a set. This one just doesn't work. However, what we can do is get the index of a list. So what I can do is convert my set to a list, and then from this list, I want to take the index. Meaning if I run this now, this one is going to work. I get the first index, I could get the index at 1, or any other index. This is now going to be a list that we can work with. If I remove the indexing and show the entire thing that we are getting is, well, it's just a list that came from the set. And this is also non-destructible. We are just doing this for this one print statement. Outside of it, the set is going to remain a set. We are not changing the entire variable. Just for this one line, we are changing the data type for a very specific purpose, which is what you are going to do very often as a programmer. Meaning this is something you definitely want to get used to. And that way you would select different values from a set, although that really isn't the idea of a set. But I guess let's talk about what the actual purpose of a set is in Python. And what they are supposed to do is being used for comparison operators. Sets are incredibly good at that. There are a lot of ways to check if two sets have values in common or if they have different values. For example, what we could be doing is set 1 and check if there's a union with a set 2. And that way we are getting all of the shared elements. Another way would be looking at the intersection between two elements, and now we only get the values that are present in both data sets. There are actually quite a few more. Let's go through a couple of them. Let me add another comment for another section, and let's call this comparison operators. And in here, to keep things a bit cleaner, I want to have two more sets. Set 1 and set 2 that do share some values. And everything else I want to comment out so we are not going to get confused. What you can do, for example, the one we have seen already, I can print set 1 and then union and set 2. If I run this now, we essentially merge these two sets. I suppose an operation that is a bit easier to see in terms of what's going on is the intersection method. If I run this one, we are now only getting 4, because 4 is the only value that is shared with set 1 and set 2. Any other value disappears because they are not shared by the two sets. A really good way to think about it is to use Venn diagrams. This one is set 1, this one is set 2, and let me draw two circles. And set 2 would be the other circle. What intersection is doing, this one here, is it only finds the shared values between the two. Union got all of the values. And the third operation we could go, we can have set 1, and the one here is difference. Again, I want to check with set 2. And this looks like a typo, difference. This fits better. Let's run this now, and there we go. Now we only get the values 1, 2, and 3. These 3 here. we are getting this area here now, where we only get the values that are not present in set 2, which specifically here means that 4 is disappearing. And those are the main comparison operators. That being said, there are a few more. There's a different way to use these methods. And those are going to look slightly weird. For the union, instead of writing union, we could do set1, then I think this is called a pipe operator, and then set2. Let me comment out the other 2 lines so we're not getting confused. If I run this now, we get the exact same outcome. Along the same lines, intersection, we could replace with the AND character. So set1 and set2. If I run these 2, I am getting 4. We are only getting the values shared by both sets. And finally, difference, we could access with set1 minus set2. And if I run this, we are again getting the same values. This one may look weird, but it actually makes a lot of sense. We are basically taking set1 and we are subtracting all of the values from set2. If they exist, they are going to remove the value, 4 in this case. If they don't, we're just going to ignore them. Now that being said, these operators or sets in general, you are not going to see all that often. They are very rarely used. Lists, tuples, and dictionaries are the really common one, and sets you only really use when you do some more data-oriented stuff. Alright, now with that, we are nearly done. I just want you guys to do an exercise. And for the exercise, I have a long list. I'm not even sure how many numbers are in here, but there are a lot. And what I want you guys to do is to use a set to figure out if this list has duplicate values. Try to figure this one out yourself. It's a really common operation that is incredibly useful. I have added a comment to explain what the exercise is going to be, but it actually isn't all that difficult. The function you want to use here is len. And right now, if I pass the list in here, I know we have 34 items in there in total. Let me comment out the earlier stuff so we're not getting confused. We have 34 items inside of this list. How we can use this is we know if we are creating a set. So I want to create a set from this test list. Since a set cannot have any duplicate values, if the length of this set is shorter than the length of this original list, then we know there are going to be duplicates inside of this list. Which means if I run the len method on this, run both, we are getting 26, which means we have quite a few duplicate values in the original list. If you want to do this a bit more fancy, you could also do, I guess let me put this on a separate line, you could print len of the test list, then the comparison operator. I don't think we have seen this one yet, but this checks if 2 values are equal to each other. And then we have len of the set of the test list. And if I run this now, we are getting false. And if this is false, we know they are duplicate values. With that, we have all the important stuff for a set. Although, keep in mind, sets are fairly rare in Python. You would only really use them when you run something that requires a lot of data work, like running a database or doing data analysis. For anything else, like making a GUI or making games, they really aren't used that often. So don't worry too much about them for now. When you actually need them, you can learn about them in more detail. The next incredibly important data type is a Boolean. All a Boolean is either true or false. And usually we are creating Booleans with comparison operators. For example, if we are running something like 5 is smaller than 10, we are getting the Boolean value true. And this is incredibly useful to control the flow of our code, something we are going to talk about a lot in the next section. For example, if a condition is true, then you want to do something. And Booleans can be created in a lot of different ways. The one way we have seen already is we're using either integers or floats, and then we use comparison operators. We can also use some string methods like isNum to check if there's a number inside of a string. I think we have seen isAlpha to check if there are only letters inside of a string. Another way is we can check if there are values inside of a list, inside of tuples or a set or a dictionary. This would also work. We could also compare different sets to create Booleans. And finally, we can also create Booleans by themselves, although that's something you really aren't going to do too often. I guess let's go through this entire list. And we're going to start with comparison operators. And there are quite a few. The one we have just used in the last part is the equal sign. So we are checking if two values are equal with two equal signs. And we're using two because a single equal sign is reserved to assign a data type to a variable, meaning we couldn't use it. And to check if two numbers are not equal, we have the exclamation mark equal. And that checks if two numbers are different. And finally, we have smaller or smaller equal to check if something is smaller than or smaller or equal than. And greater equal would work in the same way. Those are the main comparison operators. In my code, let me start by printing, and I want to print if 1 is equal to 1. If I run this, we are getting true. If I use a different number, let's say 10, run all of this again, I am getting false, because 1 is different from 10. This should be quite obvious. The next operator would be exclamation mark equal, and let me add comments, is not equal, whereas the double equal sign looks for is equal. If I run those two, we get false and true. False here because those two are not equal, and we get true from this operation because they are indeed different. I suppose a better way of writing the comment here would be true if is equal or is not equal, or besides not equal is different. We can also print if 1 is smaller than 10, and this one gives us the obvious result because 1 is indeed smaller than 10, and we could also use smaller or equal than. And this one, in this case, would also be true. I guess where this one matters, if we have a 10, smaller equal here is going to be true, but 10 is not going to be smaller than 10, meaning this operation would return false. This also works with greater than. Again, this would be false because 10 is not greater than 10. And those are all the major comparison operators for integers. For the next part, we could look at lists and Booleans. And in here, we can check if a value is in a list or if a value is not in a list. And this, by the way, also works with strings. An important point here is that not reverses a Boolean. If we have not false, it is going to be true. If we have not true, it is going to be false. Python here works very similar compared to what you would use in a sentence. And I am trying to be better with comments. Let's do this Booleans and numbers. I think is a good name here. Next up, we have Booleans and lists and strings. What you could do, for example, here is you could check if 1 is in the list 1, 2, and 3. If I run this, we're getting true because 1 is indeed in the list of 1, 2, and 3. Let me comment out this part here so we're not getting confused. And run this again, now we are only getting true. And this is also going to work with different data types. If I, for example, had a tuple and run this again, we would have the very same outcome. If I duplicate all of this, I can also check if E is in the word hello. And run this again, and we would be getting true again because E is indeed in the word hello. Finally, what you can also do is to use the not operator. For example, you could be checking if 4 is not in the list of 1, 2, and 3. If I run this one now, we're getting true again because 4 is indeed not in this list. Generally, not reverses all of these operations. I could, for example, uncomment this print 10 is greater than 10, and this one, let me keep it the only one without a comment. If I just had this one line, by default, this one is going to be false. But if I put a not in front of it and run this again, we are now getting true. Not reverses any kind of Boolean. So if you have not true, you are going to get false. You can actually do this by itself. Let me add another comment, and let's call it Booleans by themselves, and comment out everything else. What you could do, you could just create a Boolean by just writing true or false if you wanted to. And this one would get you true, which is its own data type. And if you write not true, you would get false. This, I think, is going to make sense. And I guess while we are here, we can do another data conversion exercise. So data conversion exercise. And what I want you guys to do, here are the nodes. I have an edict, and this one contains 3 key value pairs. It's always the integer of a number and then the word of the number as well. Although honestly, it really doesn't matter what the specific value here is. And I want you guys to do 2 things. Number 1, check if one of these keys exists, specifically if this key 1 exists. Just assume you don't know what's inside of the dictionary and you want to check if this key exists in the first place. And number 2, I want you guys to check if the value, not the key, the value 4 exists inside of the dictionary. And again, assume you don't know the actual content of the dictionary. So try to figure out these 2 problems. The first problem, I guess, let me put it right below, is the easier one. We want to check for a specific key. And here we can use the same thing we have used up here. It works in the same way. I can just check if 1 exists inside of the dictionary. And let me comment out this print statement down here so we're not getting confused. If I run this now, we're getting true because we can see it right here. This one does exist inside of the dictionary as a key. If you want to be more specific about it, you could also use the method .keys and you would get the same result. This edict.keys would now return something that looks like a list with only the keys inside of it. Although this is what you get by default anyway, so you don't really have to use it. The second part is we want to check if the value 4 is in the dictionary. Although this right now is not going to work because this edict is checking for keys, not for values, which wouldn't help us all that much. To access the values, we would need the values method, the one we learned about earlier. And now we're getting something that is basically a list and it only contains all of the values of the dictionary. If I run this now, we're getting false because we know this 4 does not exist as a value inside of this dictionary. Although if we had a 3, this one would be true. So we know it is working. All right, with that, there's one more really important topic I want to cover, and that is the bool function. Let's talk about this one. Bool is a function that creates a Boolean data type. And this one can accept basically any kind of other data type. It's really flexible here. We could pass a number, a string, any type of container, and we would still get a value. As a matter of fact, bool accepts so many different values that there are actually different rules that determine how the values are going to be converted. And just think about the problem here. You have some really complex data set, let's say a really long word, and you pass this into the Boolean function to either get true or false. How is Python going to determine what values count as true and what values count as false? And the logic here is actually so common that Python has dedicated words for it. We have the words truthy and falsy. Truthy means all the values that will be converted to true, and falsy is all the values that will be converted to false. The way you have to think about it is that some values will always be converted to false, and those are fairly specific, and anything else will always be true. And falsy values are 0 or 0.0, so integers or floats that have the value 0. Any positive or negative number will become true. Any kind of empty string, so a string without any content, not even a space. Any kind of empty list, tuple, set, or dictionary is also going to become false. And finally, none, so the absence of a value. and literally any other value is going to become true. Meaning you don't actually have to learn that much. Now this is something we definitely want to play around with. So let's have a look at all of this in code. Let me comment out all of the stuff we have written earlier so things are not getting confusing. Right. The bool function is another function that creates a Boolean data type, and I do want to print the result. We could, for example, add in a number, any kind of number, and we will get true. What Python basically does is it looks at a number and then determines if the value is truthy or falsy. If it is truthy, we get true. If it is falsy, we're getting false. And what I talked about just now is that any number besides 0 will be true. This one here indeed has become true. This would also work with negative numbers. Let's say -1 is also true. The only time a number becomes false is when you have 0, this one is false, or 0.0. This one is also false. As soon as you have any other value besides 0, let's say 0 point, a lot of zeros and 1, you are getting true again. But if you have any floating point with just zeros, it is going to be false. And this was the first rule. Besides that, for strings, if you have any kind of word, even if it's just a space, it is going to be true. However, if you have an empty string, this one is going to be false. Finally, if you have an empty list, this one is also going to be false, but if you have any kind of value inside, it is going to be true. The way you want to think about it is that if any kind of data type has an actual value, then it is going to be converted to true. If it doesn't have any content, it is going to be false. There's one more data type we haven't really covered yet in detail, and that is the absence of a value, so none. And this by itself is also a data type in Python. And this one obviously is also going to become false. I think this one makes sense. We are actually going to talk about this in just a second in a bit more detail, but it's not something you have to worry about too much. But, well, with that, we have Boolean data types. That's kind of all you need to know, and in the next section, we are going to use this a lot more. Before we are finishing off this entire section, I want to cover some other data types, because Python does have a lot. What we have seen so far is that Python is really flexible with data types. Sometimes data is even converted automatically, like with integers and floating point numbers. But other than that, we also have functions to change data types. And this is the entire list for the major data types you would most of the time actually need. And these are very forgiving. Python here, again, is super flexible. Now, besides those, we do have a couple of data types you see once in a while, but not very often. Or in other words, data types you don't specifically use. The most common one here is none, or the absence of a value. This could, for example, happen if a certain kind of value got deleted, or if you didn't get value from some kind of input field. But besides that, we also have a sequence, like a range of numbers, bytes, complex numbers, memory view, frozen sets, lots of really specific data types that you sometimes see in very specific circumstances. You usually have to look them up and they are very rare, so I'm not going to cover them. I will, however, cover later on none and sequence. Those you do see reasonably often. But values like bytes, complex numbers, memory view, frozen sets, you would only ever use in highly specific circumstances, and I'm not going to cover them because we don't really need them. Almost the entire time, you are going to be perfectly happy with these data types here, and they are what I am going to focus on. So right, with that, we can come to the next major section. And welcome back. In this section, we are going to work with the flow of our code. Now, what does that mean? Basically, so far, we always executed code from the start to the finish. Meaning, if these are different lines of code, we are starting all the way at the top, and we are going down line by line. Which works fine by itself, but it is fairly limiting. Because sometimes we want to do something else. For example, we might only want to run code if a certain condition is true. or we might want to run code multiple times, or we might want to run code for every item inside of a list or a tuple or something like that. And all of these things can be done quite easily. Python has a lot of ways to control the flow of your code. Although to understand how it is going to work, we need to understand one really important concept, and that is how Python groups chunks of code together. You're going to see in a second why that is important. But the way Python groups code together is by using indentation. Let's say we only want to run some code if a condition is true. And this white line here is the left side of our code editor, just to better illustrate how we are using indentation. The basic problem we have now is if we have code below this condition. How do we tell Python that it belongs to the condition and isn't something that's independent of the condition? For that, we need indentation. Anything that is indented by one indentation after this line belongs to this if condition, meaning these three lines here all belong to this if condition. I think I actually added a bit more text here. Yeah, there we go. Indentation determines where the code belongs to. If we added some other code in here, like line 3 and line 4, those would be independent of each other. They would run no matter what happens, whereas line 1, line 2, and line 3 would only run if this condition is true. If it was false, then none of this would be run, but line 4 and line 5 would still run. Meaning lines that are not indented do not belong to that if statement. I hope this makes sense. Once you understand the system, it makes a lot of sense. And indentations in general in Python are incredibly important. You are going to see them all the time. But first of all, once we understand indentation, there are 4 major ways to determine the flow of the code. The first one is if, elif, and else. These are different kind of if conditions to run code if certain conditions are true. We are going to talk about this one in the next part. Besides that, we have match. This one is kind of like if, but it's more designed for specific value to find one very specific condition. Then we have while, and this one just repeats code as long as a certain condition is true. And finally, we have for. And this one is about running some code for every item inside of a container. Let's say you have a list with 1, 2, and 3, and you want to run some code for every item inside of the list. A for loop for that would be perfect. And those are the 4 major concepts that we are going to learn. There are also a few more extra tools you can use, like breaking a certain kind of statement or skipping to the next part in a while loop. I will talk about those at the appropriate point. So I guess with that, let's start with the first major part. Possibly the most important concept to determine the flow of your code is the if statement. All this one does is it tells Python to only run some code if a certain condition is true. Note here, we are always looking for a Boolean value. They are crucial to make all of this work. And an if statement can also be extended with elif and else. And you can also add different conditions together. We're going to cover all of this in quite a bit more detail over the next 2 videos. Let's have a look at all of this in code. Let's do a super quick recap of Boolean values. All they really do is if I have something like 10 is greater than 5, I print it, I'm getting true, because this condition is indeed true. And if I do it the other way around, that 10 is smaller than 5, this would get me false, because this condition is not correct. And these Boolean values we can now use to control the flow of our code. For example, we could run some code if a value in a variable is greater than, let's say 10. For that, let me first of all create a variable. Let me call it x, and let's start with 5. And now I want to run some code only if this value is greater than 10. And for that, I would need the word if, and then the condition I want to check, which in my case is x is greater than 10. After that, I need a colon. And now if I press enter, Sublime is very intelligent here and already creates one level of indentation. So we are here if I write some code. And this is really important. Let me write some code here. Actually, let's say print the if statement was true. Because of this indentation, we know that this print statement belongs to this if statement here. If I execute all of this, we can see nothing. The reason why we can't see anything is that this condition here was not true. 5 is not greater than 10. But if I change this 5 to a 15, run all of this again, now we can see this print statement here. The main thing that you have to understand here is this condition. If it becomes true, then we are running all the indented parts below the if statement. And if it is false, we're not running any of the indented parts. This would also work over multiple lines of code. I could, for example, print another line. If I run this again, we get another line as well. I could also create another variable in here. Let me call it y is equal to 10, and I could print y. All of this works just fine. We can write any kind of code in here. As long as it's indented, it always belongs to this if statement. However, if I write now some other line of code after the if statement that is not indented, let me call it some other code, this one is always going to run regardless of what the if statement does, because it's not indented. If I run the entire code right now, we can see some other code, the line we get here. And if I return x back to 5, run this again, we now can still see some other code, because this line is not affected by the if statement, because again of the indentation. Indentation is really important to Python. You absolutely have to understand it. Although that being said, this is the core part of an if statement. It really isn't that complex. Although you can extend the logic here in two different ways. A very easy one would be an else statement. This one, again, is going to need a colon. And now if I press enter again, we have another indentation. And in here, I can write the code that was run if the statement was false. How does this work? Basically, this else statement always has to be connected to an if statement. And what it does is, if this condition here is false, then we are not running any of this, but we are running anything inside of the else statement. Since x is 5, this condition is going to be false, meaning none of this will run, but this one here should be run. And this line is going to run no matter what happens. So if I run the code, I should be seeing the output of this line and of this line. Let's try it. And there, indeed, we can see these two lines. And there's one more thing that you can do, and that is called an elif statement. And again, this elif statement has to be connected to an if statement. Basically, what it means is shorthand for else if. It's kind of similar to the else statement, except now we are adding a condition, which means if this condition here is false, then we want to run this statement here. But we only want to run this one if another condition is true. And this condition is just going to be another Boolean value. Let's say I want to check x again, and I want to check if x is different from 0. If that is the case, I once more need some indented code. And for this one, let me print the elif statement was correct. And now we have a much more complex if statement. We first check if this condition here is true, which in our case right now is going to be false because 5 is smaller than 10, meaning this would be a false statement. Then we are coming to the elif statement, and now we are checking if, let me use a different color, if x is different from 0. And since 5 is different from 0, this one is going to be true. As a consequence, we are going to run or expect this code here to be run. Let me add it properly here so we can see what's inside of the line. And once any of these elif statement has run, we are stopping this if statement, meaning this else statement here would not be run at all. And once again, this print statement here is going to be happy either way because it does not care what happens in this entire thing. Let's try all of this now. And we can see the elif statement was correct, which is this line here. And then we have some other code, this bit here. I suppose we could be doing another example. And now let me add a 0 in here. And I would really recommend you to go over this one yourself and see which line you would expect to run here. Once again, we are starting at the first line, and we know 0 greater than 10 is going to be false. That can never be true. Next up, we are looking at x being different from 0, which in this case is also going to be false. Which means at the end, we are left with this else statement, which means the code we are expecting is the code that was run in the if statement was false. And we're also expecting this one at the end, although that's getting repetitive. Let me run the code now, and we get the code that was run if the if statement was false and some other code. With that, we have all the basics for an if statement. If you understand if, elif, and else, you already understand what you need. I guess one more thing that I haven't covered yet is if and else can only occur once inside of this if statement. But elif, you can multiply as many times as you want. For example, I could add x is greater than -20, for example, and then add something else. I know, print something else. And you could add as many elif statements as you want or as you need. But else and if can only occur once. Although what you could be doing is add another if statement afterwards. I guess we could add if 1 in the list 1, 2, and 3, and then we want to print another if statement. When I said an if statement or an else statement can only occur once, I was always referring to this block here, where we are starting with an if, and inside of that we can only have one else. We couldn't have a second else. However, Python is totally happy to have a completely separate if statement. But with that, we can do an exercise. And what I want you guys to do is this one here. We have one variable that determines how much money we have. And from this amount of money, I want you guys to figure out what we are going to eat. If we have greater or equal than 80 units of money, I want you guys to print eat something fancy. If the money is greater than 45, eat something nice. If it is greater than 15, eat something okay. And else, eat something cheap. And obviously, there should only ever be one print statement running at any point in time. So pause the video now and try this one yourself. Before we start, I want to comment out all of this because it would otherwise get kind of confusing. First of all, we need an if statement, and now I want to check the money available. And I want to work on the first line here. And what we are being asked to do is greater or equal than 80, which we get with greater or equal, and we want to check for 80. If you want a reminder on Boolean values, check out the last section on Boolean data types. This is going to be really important for this entire section. But in here, I now need a colon, and now I want to print eat something fancy. I guess let's add an exclamation mark because why not? The really important part here, this print statement has to be indented. But with that, we have covered the first line of the exercise. Next up, we want to check if the money is greater than 45, which means we want to first check if the money is greater than 80, but if that is not the case and the money is still greater than 45, we want to do something else, which means we need an else if statement. Else, because we want something else than the if statement, and if because we have another condition. What I want to check in here, if the money available is greater than 45. After that, again, I need a colon, I need an indented line, and now I want to print eat something nice. And with that, we have covered this line here. Next up, we have a very similar line, meaning now we again need elif. And what I want to check now, if the money available is greater than 15. If that is the case, this is getting a bit repetitive, I want to print eat something okay. That covers this line, and finally we have an else statement, that if all of these conditions are false, we want to do something else. And the else we want to do is to print eat something cheap. And there we go. This is going to cover all of the 4 if statements. If I run this now, we get eat something fancy, because the first if statement, this one here, is true. However, if I change this 100 to, let's say, 50, we get eat something nice. If I change it to 20, we get eat something okay. And if I change it to 5, we get eat something cheap. And with that, we have basic if statements. Now that we have learned about basic if statements, we can work on the more complex ones, because if statements can be extended. Number 1 is you can combine different conditions inside of one if statement on the same line. And number 2 is you can nest one if statement inside of another if statement, which lets you create really complex systems that check different values. Let's start with combining conditions. And in here, the 2 keywords we need are and or. Kind of confusing to say, but you get the idea. How this would look like is we have if 5 is smaller than 1 and e in hello, or 10 is different from 4. This may look confusing, but let's go through it one by one. To understand how this works, we have to understand and or. And means that all the parts have to be true. Meaning when we are talking about this and here, this bit in particular, both of these conditions, 5 is smaller than 1 and e in hello, have to be true individually for this entire statement here to return true as a whole. Whereas or works in the opposite way, where only one or statement has to be true. Which means if this or statement here is true, then it wouldn't matter if all of this is false, because as long as one or statement is true, then the entire if statement is going to return true as a whole. And this is probably going to sound very confusing, so let's do this a bit more practically. Let's do this actually in the simplest possible way. Let's say I have if true, and I want to print true. This if statement here really doesn't make too much sense, but to illustrate the point, it's really useful. But since we're adding the Boolean value true in this if statement, this is always going to run. Meaning if I execute the code, we are getting true. And now what we can do is use and in here. And if I add false now and run this again, nothing is going to happen. This line will not be executed. Because of and, both the first one, this one here, and the second one have to be true for this entire condition to be true as a whole, which they aren't right now. But if it was true, then this would run again. The way you have to think about and is I'm only going to run this if statement if this is true and this is true and anything else is true, and if any single statement is false, then the entire thing is not going to be run. I hope that makes sense. It does take some time to get used to it. Let me go back to false. And the other word we can use is or. Now we want to run this line of code if this is true or this is true. Meaning if either of these is true, then the entire if statement is going to run. If I run this now, this is going to be true, because for or, only one of them has to be true. And once you get so far, you can combine and or. For example, what I can do is true and true and true, or true. Now, this would obviously return true as a whole because we only have true values in here. But now, if I set this to false, this would still run. And the reason is, let me add a bit of white space around it so I have more space to draw on. I am assuming that this is kind of confusing right now still. Python essentially combines all of the AND statements into one block inside of the if statement. And this entire block can either be true or false. For AND, every single value has to be true, and if a single value is false, then the entire thing is going to be false. In our case, since there is one false statement, the entire block here is going to be false. Once we have that, Python is looking at the OR statement, this bit here. And as a consequence of this, we now have false from all of the AND statements, and then we are checking false or true. And if either of these are true, then the entire if statement is going to be true, which in this case it is. Just to make sure, let's do one exercise for this one already. And what I want you guys to do is here we have 3 variables, and the exercise is going to be fairly similar compared to what we have done in the last video. What you should be working on is another if statement that checks if the money available is greater than 80 and if you are hungry. If those 2 conditions are true, print, eat something fancy, or whatever you want. However, this should also run if bored is true. And for that to work, you have to combine and or statements. So pause the video now and try to figure this one out. To get started, I need an if statement once again, and now I want to check if money available is greater than 80. This covers this first bit. On top of that, I also want to check the AND if hungry is equal to true. With that, I have covered this entire bit. Now that I have that, I can print eat something fancy. If I run this now, this is going to return eat something fancy. Let me comment out this stuff at the top so we're not getting confused. Eat something fancy. If I change hungry to false, run this again, we are not getting anything. The simple reason being that both of these statements have to be true because of the AND statement here. If either of these is false, then the entire thing is going to return false, which it does right now, so none of this is going to be run. However, now what we can do is use an OR statement as well to cover the last bit, or if bored. And now I want to check OR bored equals to true as well. If I run all of this now, we get eat something fancy. And what happened here is Python first checks the 2 statements connected by AND. And it sees that money available is 100, which indeed is greater than 80, meaning this part here is going to be true. But then for hungry equals true, it looks at the hungry variable, and this one is false, meaning this one is going to return false. As a consequence, the entire bit here is going to give us a big false. The difference now is we are also checking this OR statement, which means we ever want to check if anything in here is true or if this condition is true, which it actually is right now. And as a consequence, the entire thing combined is going to return true. The consequence being, we are going to run this line of code. And I hope this makes sense. Using these and or keywords can be a bit confusing. Definitely play around with this in your own time if you're struggling. That being said, most of the time you are going to keep this fairly simple. You usually only have a single AND statement in here and then you're good to go. Don't overthink this. The other way to make if statements more complex is by nesting them. And let me do an example. We could have an if statement if A is inside of the list A and B. Right now, this one would be true. But inside of this, we can add another if statement that is indented by one line. And inside of that, we could even add another if statement. And this system we could continue forever, as long as we keep on adding more indentation levels. Let's have a look at this one in a bit more detail. I'm going to comment out the stuff we have done earlier. I guess I could organize it a tiny bit better. There we go. And now I want to look at nested if statements. And to keep comments a bit more consistent, let me add one for the first part. Let's call it combining conditions. The example we have just seen is we want to check if the letter A is in the list A and B. If that is the case, let's say, want to print A is in the list. Executing the code is going to print this line. This one should be fairly straightforward. And again, remember, we are on one level of indentation. On this line of indentation though, we could add another if statement. We could, for example, check if A and then use the method is alpha. Then I need a colon again, and now I need another indentation line or another level of indentation. And then here, let me print it is a letter. If I run this now, I get A is in the list and it is a letter. Now, this example really doesn't make too much sense, but we can make it quite a bit more interesting. For example, what you could be doing is create a variable, and in this right now, I want to have, let's say, the string A. And now I want to check if X is inside of this list, and I want to check X is alpha. If I run this again, we are going to get the same result. We essentially just replaced the string A with a variable that contains the same string. But once we have that, I could add another string in here that contains a 1, which is not in the alphabet. So if I check this one here, what I expect now to happen is that this is still going to be inside of the list, so this entire condition should be true. As a consequence, this print statement should run. However, the number 1, even if it's inside of a string, is not in the alphabet. So this condition should not be true. And if I run this, we can indeed only see this line here was run, but this was false, and as a consequence, this line here was not executed. If you wanted to, you could even add another level of indentation. I don't know, let me just add true, so we always execute it, and inside of that, you could keep on adding more if statements. There's absolutely no limitation on how many if statements you can add. The only thing you really have to consider here is that each if statement has to be on a separate level of indentation. At the very least, if you want them to be part of the other if statement. If you added an if statement here, let me get rid of this one, you would check those two individually. The way you want to think about it is that each if statement is one block of code. This if statement here is one block. Inside of this if statement, we have one block for this if statement and another block for this if statement. And these two here are independent of each other, but they both depend on this if statement to run. If this if statement does not run, neither of those will run. Just to have something in here, let me print something. And let me add some proper white space so this looks a bit cleaner. All right, with that, we can do another exercise and then finish this part. What I want you guys to do, let me copy it from up here. I want you guys to check these 3 conditions, but now instead of using this system here, I want you guys to create a nested if statement. And if all 3 conditions are true, so you have enough money, you are hungry, and you are bored, then I want you guys to print, eat something fancy, or really whatever you want, it doesn't matter that much. Let me actually uncomment them and add a comment for the exercise, and now pause the video and do this one yourself. Let's start with money available is greater than 80. That's the one we have already used. And I guess while we are here, I can also print something to check on what if statement we are. For this one, I want to print I have enough money. After that, I want to check the next if statement, and I just want to check if hungry is equal to true. And if that's the case, I can print and I am hungry. Inside of that, I want to check if bored is equal to true. And if that's the case, I want to print the final thing, eat something fancy. Before I run it, I do want to comment out this part here, so we keep things a bit cleaner. If I run this now, we only get up to I have enough money, this line here. We are not getting to if hungry because hungry is false. If I set this hungry to true, we get, let me expand this a tiny bit, I have enough money, I am hungry, and eat something fancy. All three conditions here are true. And with that, we have if statements. Obviously, you could also add else statements in here if you really wanted to and make this even more complex. Now there's one more thing that I want to cover really quick. Writing something like this is a bit redundant. All you really need is hungry by itself. If I run this, it would still work. What happens here is that Python looks at the hungry variable and the value for hungry is true, meaning this if statement here is essentially if true. And keeping like this is much more readable. If a value is truthy, you could just add it in here and then Python would take care of the rest for you. But being more explicit about it would also still work perfectly fine. But alright, with that, we have if statements covered. In this part, we're going to cover the match case statement. And this one is kind of similar to an if statement. The major difference is you still run some code if a certain condition is true. But match case is more designed to check for one specific value out of a long list of possible values. That probably doesn't mean too much. Let's do an example. Let's say you want to check the mood of something. If used an if statement, it might look something like this. We have if hungry, you want to run some code, and else if you're tired or bored, you want to run some other code. All of this would be just fine, but it also feels kind of inefficient. Having one else statement for each mood seems kind of annoying to write every single time. And as a consequence, Python has a slightly different way to approach this kind of case. And this is a match case. You would use the match keyword, and then you would look at the variable. In this case, I am looking at the mood. And then you can specify different kinds of cases. For example, case for hungry. And if that is the case, we have colons again, and we are running some code inside of it. And then we can check for different cases and run some code for all the different possibilities. It is very, very similar to an if statement. If you compare the two, match case is actually a tiny bit longer, if that makes a difference to you. Although the main thing you want to look at here is readability. All of these else statements here eventually get kind of annoying to read, whereas case this, case that gets much better and is a much easier way to check the value of this mood. Both approaches here would be perfectly fine though. As a matter of fact, match case is a reasonably recent addition to Python, which is the reason why very few people actually use it. Most of the time, you are going to see some kind of if statement, which is still perfectly fine, but in some cases, match is the more appropriate way to go on. But, well, let's have a look at all of this in code. Once again, I have a completely empty Python file, and I want to create a new variable. Let's call it mood. And right now, my mood is going to be hungry. If that is the case, I want to run some code. What we have seen so far, you could use an if statement. If mood is equal to hungry, then let me print get some food, or something like that. Running this will get me indeed get some food. This one is working just as intended. The difference now is if we have lots of options here for our mood. We could be hungry, bored, thirsty, tired, and whatever else you want. For each of these conditions, we would have to add another else-if statement to check for all of the possibilities, which does eventually get kind of cumbersome to write. And because of that, we have match, and then we want to look at the variable, mood in my case. Now you need a colon, and if I press enter, we are again indented by one line. And now I have to specify a case that could be one scenario for this mood. For example, the case could be hungry. If I add a colon now and press enter, we are once again on a separate line. And now I can print get some food. If I run all of this, we are again back to get some food. This result here is basically a simple if statement. The difference now is that we can specify other cases. For example, a case thirsty, and then let me copy this one, get some water. I could specify a case for tired and continue like this forever. There really isn't any limitation on how many cases you can have. Let me just write it out, get some sleep. With that established, I can now change the variable and get different outcomes. I suppose there's one more thing that you could include here, and that would be case underscore. Still needs a colon, and now you can print in here any other mood. Because an underscore is run when none of the other cases are correct. For example, right now, if I write in here something like bored, a case we haven't accounted for yet. If I run this, we get any other mood. If Python doesn't find any of these, it is going to run the underscore one. And with that, we have match case covered. And I am fully aware this is about as efficient as an if-else statement. It really isn't that much of a difference. Match case really is not something you absolutely have to use. If you want to stick to if-else statements, this would also be perfectly fine. But alright, let's do an exercise. What I want you guys to do is this one here. Create a variable with an integer between 1 and 5. And this should be a grade you could be getting at school. And then create a match case statement for all of the values that this grade could have. 1 would be very good, and 5 would be very bad. And print something like this for each of these cases. And I mean all of them from 1 to 5. Also, don't forget to include some default behavior if you get a value you didn't expect, like a 10 for example. Pause the video now and try this one yourself. Let's get started. And I want to comment out all of this, and then we can start by creating the grade variable. And let's start with number 1. I want to start by writing my match, and what I want to look for is the grade variable. Then I need a double colon, and now on an indented line, I want to check for one case. And the case right now could be a 1. Now I need a colon again, and once again on an indented line, I want to print very good. I can now run this, and we get very good indeed. With that, we have one case. Now we can do case 2, print, let's say, still good. Case 3 would be print okay. Case 4 would then be print needs improvement. And finally, case 5, I want to print very bad, I think I said. Yeah, very bad up here. And this would already be a working match case statement. I can run this again, we get very good, the same we had earlier. Let's say if I use a 3, we get okay, and if I use 5, we get very bad. The one thing we haven't done yet is if I have a 7, a value we don't have accounted for, nothing is running in here. I guess I haven't specifically mentioned that, but if the match case doesn't find a value, it just doesn't run. We do not get an error message. Just keep that in mind. It's a specific behavior of it. All right, but I want to add case underscore for all the other values I haven't accounted for. And for this one, I can print, let's say, grade not recognized. If I run this now, we get grade not recognized. This would also work with, I don't know, something else. Python doesn't really care what the value here is. All right, with that, we have match case. Something fairly similar to an if-else statement, but it could be useful in very specific scenarios. A really important concept in Python is the while loop. And this one is actually quite simple. All it does is it repeats some code as long as a condition is true. For example, this could look like, while true, I want to print an infinite loop. This infinite loop here would run forever unless we manually break the code. Not exactly the most realistic scenario, but something we could be doing. I suppose something slightly more realistic would be something like this. We are starting with x being 0. Then we are checking if x keeps on being smaller than 10, and inside of this while loop, we want to print a certain thing, and we are also going to increase the value of x on this line here. This condition now is only going to run 10 times. And this is how often we are going to print this loop here. And with that, we have some basic theory out of the way. Let's actually have a look at all of this in code. I guess we can start with the examples I just talked about. We always start with the while keyword. Once we have that, we need some kind of Boolean statement. This could either be true or false. Although, if you have false, this while loop is not going to run. It will only run if the value is true. If that is the case, in here you can print, I think I called it infinite loop. If I run this now, we get an infinite loop that keeps on running forever. It's not particularly exciting, but it definitely does work. The way you would exit this one is by just pressing escape and it would stop. Although you really want to be careful with while loops, it can not crash your code, but it can make your code not work anymore. Let's say if you have some kind of game and you end up in a while loop that you can't escape from anymore, your game might just stop because your computer is stuck in this while loop and it doesn't continue from it. Let me get rid of this one and let's do something a bit more reasonable instead. I want to create a variable x, and by default, this one is going to be 0. And now I want to check while x is smaller than 10. I want to print x. Look at this code. If I run it, what do you think is going to happen? What we get is, if I run this, we have a whole bunch of zeros that keep on running forever. And the reason here should be fairly clear. This Boolean condition, x is smaller than 10, is always going to be true, because x is always 0 and we are never changing it. The consequence being that this print statement is going to run forever. It is never going to stop. To overcome that, we would have to do something like x plus equals 1. And now if I run this, we get the values from 0 to 9. I suppose what you could also be doing is combine this with an if statement. For example, if x is equal to 5, and this has to be indented, really important to tell Python that this if belongs to this while loop here. But once we have that, I want a colon again, and on another level of indentation, I want to print x is 5. If I run this now, we get the values from 1 to 9, and at the value 5, we have x is 5. And this way, you can repeat code quite easily. That being said, there are two ways to make all of this a bit more complex. Let's talk about it. You can break an entire while loop, and you can also skip one iteration of the while loop. And let's do this by example. This is a bit difficult to explain. Here's the example I've shown you earlier. And this one would just print the word loop 10 times on the screen. But what you can do, let's say with one if statement, you could, for example, add the break keyword. And just the keyword, no brackets, just break. And if you write this, the entire while loop is going to end whenever x is equal to 5. You would never get to this 10 here at the end. Besides that, you also have continue. Continue doesn't break the while loop. Instead, it just skips to the next iteration of the while loop. Meaning, in this case, if x is 5, this print down here would be skipped over, because after continue, this line here, we would go back to the while loop and then continue with the next iteration. I think I added a bit more text here. There we go. So break ends an entire while loop, while continue skips to the next iteration of the while loop. And that's basically all you have to understand about it. Let's play around with it. I already have an if statement inside of the while loop, and this one I want to use. Let's start with the break keyword. And you can already tell Sublime is coloring it differently, so we know that it has some kind of special functionality. If I run the code now, we get only the numbers from 0 to 4. And this happens because of this break here. It ends the entire while loop as soon as x is 5. The other keyword we have seen is continue. And this one right now is not going to work. And maybe you can figure out why. Let me run it actually. In this case, we are getting all of the numbers. And try to think of why we didn't skip over one of them. After we are running continue, we are skipping the rest of the current while loop. In our case though, we don't have anything after continue. Continue is on the last line of this while loop, which means it doesn't actually do anything. We could change this though by putting the print statement after continue. And let me add a bit more white space here. This looks a bit cleaner. If I run this now, we would expect this print statement to be skipped if x is equal 5, meaning we shouldn't see 5 in the output. Let's try it. And indeed, after 4, we skip straight to 6. We do not have 5 because of this continue here. And with that, we have a while loop. Let's do an exercise and then we are done. That is horrible spelling. There we go. What I want you guys to do is to use the while loop to create a list with only even values from 0 to 100. I guess as a tip here, create an empty list first, and then from the while loop, append more values. I haven't covered yet how to only get even or odd values. Maybe try to do some research. It should be fairly doable, but let's see if you can figure this one out. I guess this one was a slightly more challenging exercise, but let's try it together. I first need some kind of list. Let me call it my list, and this is just empty brackets for an empty list. And there's one more thing that I am going to need, and that is some kind of counter. By default, I want to set this one to 0. This is what we are going to use to control the while loop, like the x we have used up here. Actually, let me comment out this earlier stuff so we are not getting confused. What I want to do with that is run my while loop again with counter is smaller or equal than 100. Because this is the maximum number we want to go to, and we are starting from 0, which is the value here. And let's start by adding every single value to the list. For that, we need my list, append, and then the counter. Once we have that, I can just print my list, and let's see what we get. And we are getting nothing. The reason here, look at this again. I have actually made the mistake I warned you about earlier. Right now, the code is stuck inside of the while loop. Let me end it with the escape button. This, if this was an actual code example, would have been really bad. The reason here is this counter doesn't increase. It always stays at 0, and as a consequence, this condition will always be true. And as a consequence, we keep on adding the value 0 to this list. And besides that, we would do pretty much nothing else. I would spend my entire processing time just adding zeros to a list, which not only would break my code, it would also be a waste of resources. The way around it is I want to increase the value of the counter by 1. And now if I run this, we are very quickly getting the values from 0 to 100. Already a pretty good start. But now I don't want every single value, I only want the even ones. Meaning I want 0, 2, 4, 6, and so on. For that, we are going to need an if statement inside of the while loop. All you really need is the percentage sign. And this we want to use with the number 2. If this is 0, we know we are getting an even number. If I run this now, I am getting only the even numbers. This operation here, if you forgot about it, is the remainder. For example, if the counter was at 3. I think early on I used dots, and that's a really good system to explain it. Let's say we have 3 dots here representing this 3. And if we are dividing this number by 2, we have 1 full block, and this would be 1 unit after the division. And what this percentage sign here gives us is the remainder, so this 1 here. And if this is any value besides 0, we know we have an odd value. On the same line, if there is any value, so if I use different from 0, we are only getting the odd values. And this is the most common use case for this remainder operation. It's a really easy way to get even or odd values. I guess while we are here, we should also practice skipping one while loop. So let me extend the exercise. I also want you guys to do not add the value 58. For some reason, I really do not like this one. Try to add this one as well. All right, this is turning kind of into extra practice for the if operator, but I suppose that can't hurt. We can approach this in 2 different ways. We could either add another if statement in here, or add an AND keyword after the original if condition. I guess let's start with this one. I want to check if my counter has a remainder of 0 and my counter is different from 58. This is the number I want to avoid. If I run the code now, I get, let me find the value, we have 54, 56, and then we skip to 60. We do not have 58. This would be one way to add it here. A different approach could be another if statement inside of this counter. I could check in here if counter is different from 58. And then this append here has to be on one more level of indentation to tell Python it belongs to this if statement here. And if I run this now, we are getting the same outcome here with the 58 being skipped. All things considered, while and if work really well together. And all right, with that, we have while loops. Something fairly similar to a while loop is a for loop. And this one works in a somewhat similar way. We are still running code a certain amount of time, so we are basically repeating code. The difference now is that we are running code for every item inside of a container. This could, for example, look something like this. We want to run a for loop for every item inside of the list that contains 1, 2, and 3. The way this works is that Python goes through this entire list and picks every single value, 1, 2, and 3 here. And then for each cycle, it assigns the value to the x in this case, but you could name it whatever you want. Meaning, if you added something like a print inside of this for loop, you would print 1, 2, and 3. 4 cycles over every single item in the list, and then it stores the value inside of x, and you can treat it like a variable. And just like with while, you can also use break and continue. And that is basically it. Let's have a look at it. I want to create, let me call it a basic list. And here, let's use the example. I have a list with the numbers 1, 2, and 3. And I want to run a for loop to access every single item of this list. The example we have used is for x in basic list. And then inside of it, we have printed x. If I run this now, we are getting 1, 2, and 3. So what happened here? I think it actually makes kind of sense. Python is going to run this block of code here for every item inside of this list. And on every cycle, it picks one of the values, starting from 1, then 2, and then 3. And it always assigns this item to the variable we have specified here. But you could use any Python variable name. And then inside of the for loop, we are doing something with that value. Right now, we're just printing it. We could also add it to a list or doing some math operations or really do whatever we want. And that way, we can run code for every item inside of a list. And this would also work with the other types of containers, like a tuple, a dictionary, or a set. As a matter of fact, there are lots of different things you could be cycling over. For example, a string would also work inside of a for loop. And there's one particular case I do want to cover if you want to cycle over a number. This would also work, but it does need some adjustment. Let's actually play around with all of this. And I have pre-written some values, these ones here. We have a basic tuple, a basic dictionary, a basic set, a basic string, and a basic number. Tuples and sets work exactly like the list. If I replace the basic list with a basic tuple, we get the very same outcome, and we would also get the same thing with a set. There we go. We always get 1, 2, and 3. Python just really doesn't care what kind of container you have. It's fine cycling over any of them. A basic dictionary also works, but it looks a bit different in terms of what you get. Let me paste it in here, basic dict. And now we are still getting 1, 2, and 3. We are getting all of the keys, which if you cycle over a dictionary is probably not what you want to do. The way around it is you would use either values to get the values, now we get 1, 2, and 3, the strings attached to each key, or we would use items. And that way you're getting a tuple returned with the key and the value. We are going to learn later on how to work with dictionaries in a bit more detail. But for now, I think this is all we are going to need. For a basic string, we can just paste it in here. And now Python takes the string apart and gives us every individual letter, including the space. Finally, we have a basic number. And this right now is not going to work. If I run it, we get a type error, int object is not iterable. Let's talk about why this one didn't work. To loop over a number, so the operation we have seen was for x and 3, and this one didn't work. The reason it didn't work is because Python needs some kind of iterable, and integers cannot be iterated over. That being said, iterating from 0 to a certain number is such a common operation that there's a specific Python function for it. It is called range. How you would use that is you would add a number in it, and then it creates a range object. If you use something like range 3, we would get a range object from 0 and then all the way to 3. And this we can iterate over. It's fairly similar to a list, although it is its own data type. Meaning, if you want to iterate over a number, you would use for x in range and then the number. And I guess let's implement this one as well. Here we are back in the example, and instead of using the number, I have to put the number inside of the range function. If I print this now, we are getting the numbers 0, 1, and 2. Which, if you pay close attention, is kind of different from these numbers here. We are not even getting 3. We are again starting at 0 and then going all the way to 3, but we are not including 3. And this is why we are getting 2. A better way of illustrating this, let me copy this and comment out this entire for loop and just print the range object. Running this gets me a range object from 0 to 3. It very much is its own data type. And this one simply gives us something we can loop over, and it starts from 0 and goes all the way to a number we specified, but it doesn't include it. which granted is a bit confusing to read. The range function actually works very similar compared to slicing, because inside of range, right now, we only specified one value, which was the endpoint. But you could specify up to 3 values in here. You could have the start, the end, and the step size for the values. Start by default is going to be 0, and the step size is always going to be 1, meaning if we don't specify them, we are getting those values. Most of the time, you are only specifying the end value, which is what we have done ourselves. But in here, you could specify something like 10, let's say 20, and 2. If I run this now, we are getting a range object from 10, 20, and a step size of 2, which by itself isn't particularly useful. But if I cut all of this out, get rid of this print statement, and uncomment this for loop, and now I want my range object to look like this. If I run it now, we get only the even values from 10 to 20, and again, we are not including 20. But that is essentially the for loop. It is very often used alongside the range function. They are very much connected to each other. And I guess with that, let's do an exercise once more. And what I want you guys to do is this one here. And this list contains other lists. These are nested lists. You are supposed to cycle through this entire list using a for loop and then only print the numbers below 50, although skip the values below 10. As a tip here, you will need one for loop to go through this list and then another nested for loop to go through each individual list inside of this list. Finally, I want you guys to break this for loop if any value is above 100, which is the case here. For this one, you are going to need a for loop inside of a for loop and also throw an if statement in there somewhere. See if you can figure this one out yourself. All right, let's do it together now. First of all, I need for, and now I need a good name. And since I know that each of these lists here are nested inside of this practice list, I want something like for nested list inside of my practice list. Meaning I'm looking at this practice list here and I'm cycling over this entire list. What I'm getting from that is going to be, let me print the nested list. I am getting these 3 lists here. We still get the earlier results. Let me comment out all of this to make all of this a bit cleaner. There we go. Now we have a couple of lists with numbers inside of them. Problem is, this still doesn't help us figure out individual values. For example, I want to print this 10 here, but right now I can't access it because it's inside of a list. To overcome that, we are going to need another for loop with for, let me call it value, inside of the nested list. And now if I print this value, and let me comment out printing the nested list, that's going to get confusing. If I run this now, I am getting all of the numbers. Basically what happens here, let me use different colors for this. The first for loop, this one here, is going to go through this entire list, and it is looking at every item. And an item is counted at anything separated by a comma, meaning this is one item, this is another item, and this is the final item. Python doesn't care if the item is a list or a number, it treats all of them the same. And to access every value inside of this nested list, we have this second for loop here. And this one is going to go for every individual list. It starts with this one, then it does this one, and then this one. And via this for loop, we are going through every individual value inside of the list, or the nested list to be more specific. The result being that this value here is going to be every individual value from all of the lists. And this is what we are printing. That is a really good start. So now we have to cover that we only want to print the numbers below 50 and we want to skip values that are below 10. I guess we can start with if the value is below 50, only then do we want to print the entire value. Let me run this now, and we are only getting values below 50. This is going to cover the entire first line. Now we have to cover the part to skip if a value is below 10. And this again, we could either do by adding an and here, or we could add another if statement inside of here. I guess I'm going to stick with the if statement inside of here, although it really doesn't matter. I want to skip the values if we are below 10, meaning if the value is below 10, then I want to use continue. If this is the case, we are stopping this entire cycle and we are not getting to the print value. So let's try this. And indeed, we are only getting values that are at least 10, and the values 2 and 4 we have skipped. Now, finally, we have to cover the last part, that I want to end this entire for loop if we get a value above 100, which is going to be this one here. And now you might be very tempted to add something like if value is greater than 100, then I want to break this entire code, or at the very least the for loop. However, now this is not going to work. I guess to demonstrate it, the last value after 101 is going to be this 10 here. And since this is not below 10, we do expect this to run. Although I just realized that since we have a 10 here and a 10 here, it might be a bit hard to see. Let me change the name here to a 12, so we have a specific number. If I run the code now, we still can't see the 12. And I would recommend you to look over this and see why we can still see a 12. The error here is because of one of the if statements. Try to have a look for it. The error happened on this line here. This if statement checks if the value is below 50, meaning we are never getting a value above that 50. As a consequence, when we are getting to this line here, if value is above 100, this line doesn't even run because we never get to it. After this line here, we are only getting values below 50. So this line here is essentially pointless. We can, however, cut it out and paste it at the top of the inner for loop. Let me fix this one. Now, when we are looking inside of this for loop, if we find any value above 100, we are breaking the entire thing and none of this would run. I guess let me run it. And now the last value is 10, this 10 here. This does look confusing, especially if you're just starting to program, but if you get used to indentation here, this should eventually make more and more sense. This is definitely something you want to practice in your own time even more. When it comes to Python and the flow of the code, understanding indentation is really important to understand what's going on. There's one more topic I do want to cover before finishing this section, and that is flow and line breaks. So far, we always wrote code with a colon and then with an indentation on the next line. You don't have to do that. You could just write straight after the colon. For example, for a for loop, instead of the line break after the colon and the indentation here, you could simply continue writing the print statement here. This would also work with an if statement. It would also work with a while loop. As a matter of fact, you could even use a semicolon to add multiple lines of code. All of these here would be counted as indented. Python is totally fine with that. That being said, most of the time you do want to indent your code because having multiple lines is easier to read. But that's not always the case. Sometimes, if you have a very simple statement, it might make more sense to have it on the same line. For example, match case very often has each case on an individual line, without a line break between the case and the actual code. because the idea here is each case should be fairly simple. We're going to have a look at that in a second. But much more important, for the if statement, Python does have a special operation here to have a one-line if statement. And this is called a ternary operator. This one works like this. Let's say we have x equals 5 and we want to check something like if the value is below 5, we want color equals blue, and else the color should be red. A really simple if statement. The problem is that we have 4 lines of code for something that really is very simple. We could make this more space efficient by skipping the line break here. This way we only have 2 lines. And this, I think, is more readable, but this may be debatable here. However, there's an even more efficient way of doing all of this. And this would look like this. This, by the way, is called a ternary operator. This entire line would be this bit here. Then we have the if statement as always, but now the if statement, this bit here, with the condition, is this part here from the original if statement. We also have an else, and then we have the else condition. So this red here would be assigned to the color if the condition, this one here, was false. And the way you would understand this ternary statement here is if you read it like a sentence. I want the color blue if the value of x is below 5. If that is not the case, so else, I want the color red. And that way, if you have a simple if statement, you can cover all of this on a single line of code. Once again, we have a completely empty Python file. And I want to start with the match case statement. And here is the exercise we have done earlier. If you see this now with the understanding that we don't have to do these line breaks, I think all of this starts to make a whole lot more sense. This one we could write like this. Let me get rid of all of the line breaks. This here is something incredibly readable, especially if you have some kind of statement where you would expect a lot of specific values you want to check for. This would be a very readable way to organize all of it. Although, granted, using if-else statement wouldn't look all that different. The much more important operator is the ternary operator. And let me comment out the match case stuff because we don't need it. The example I've used earlier was x equal 5. From this value, I want to assign some kind of color. And in here, you first of all need the value, in my case red, if the condition you want to check for is true. I want to have red if the value of x is, I think, smaller than 5, I said. Doesn't really matter what it is. If that is not the case, so else, I want to assign a different value, which in my case is blue. And that is all we need. If I now print my color, run this, we are getting blue because 5 is, well, this condition here is false. But if I change x to 1, run this again, we are getting red. And this way, if you have a very simple if statement, you can cover it on a single line. I guess let me go over this a bit more theoretically. A ternary operator always looks like this. We have a true value if an expression results in true. If the expression is false, let me add a cross here, then we are getting the else value, so the false value. And then either the true or the false value will be assigned to whatever kind of variable we are assigning all of this to. That way, you can cover an if statement on a single line of code. And this is really readable and very efficient if you have a simple if statement. If the if statement gets more complex, obviously you want to use a normal if statement, the ones we have already seen. I guess one thing I haven't covered yet is that this sort of operation here, this ternary operator, works in a lot of different tools as well. For example, you can use it inside of an f string or when you are creating a list. Let's have a look at those two examples. Let me get rid of this print statement, and instead I want to print an f string. And in here I want to write something like the color is, and then I want to have an operation. And in here, I could copy this entire thing instead of the variable, and it would still work. So I can copy it, although there's one thing that we do have to take care of. And that is that right now, the quotation signs are going to confuse Python. So it doesn't know where the string ends and where it begins. The way around it is to use double quotation marks at the end and at the start. And this should be working now. Let's try it. And there we go. The color is red. And in here, we have a fairly complex statement inside of a string. This way, we don't have to assign variables before or after. We can keep everything nice and neat inside of one line. Finally, we could also do something like a is equal to some kind of value in a list. And in here, I could once again copy all of this, paste it inside of the list, and then have some other values like, I don't know, yellow and green. If I now print the entire list, we are getting red, yellow, and green. All I really want you guys to take away from this is that this sort of operation works basically anywhere in Python. You could also put it inside of a function or a method. Python really doesn't mind, and this can give you a ton of power and avoid you having to write extra code that you wouldn't need. In this section, we are going to cover functions. And let's talk about what functions are and what purpose they serve. So far, we covered some basic data types, like integers and strings, and we also learned how to change them using functions and methods. On top of that, we also learned how to change the flow of the code using if-else, match, while, for statements, and stuff like that. So we are basically able to create simple programs that work just fine. But all of this only gets us so far. And to understand why, let's do a metaphor. And let's say we want to build a car. And the tools we have learned about so far are the basic parts that you would need for a car, like screws, pipes, wires, plastics, and all the most basic parts you can have for a car. The problem is, these parts don't really make a car. We don't build a car out of plastics and wires. Instead, we build a car out of an engine, out of steering systems, out of control systems, batteries, and stuff like that. Meaning, what we want to do in our code is to take these simple parts here and use them to create more complex systems, like a control system or like an engine. And once we have these more complex systems, we actually create the entire car. And in this analogy, a function is one of these more complex systems, like the engine, the control, the battery. They are just more complex parts, but they're still made out of these simple bits here. And the main purpose of this is to make our code more reusable and more organized. So what we are going to focus on for this section is to combine these simple tools to create more complex parts. And that is the main purpose of functions. Later on, we are going to learn even more powerful ways to organize your code using classes, but that comes later. For now, we are just going to look at functions, and the one really important thing I already want you guys to understand is that a function is simply a block of code that can be reused. We're not really learning anything fundamentally new. Instead, we are just putting our pre-existing code into a simple block or container, and then we're using this container to execute that code. That's basically it. Although to use functions, we need a two-step process. Let's talk about that one, and then we actually create some functions. For a function, we first of all have to create the function. And this is where we are adding all of the code to the function, or well, we are creating the code inside of the function. Once we have that, we have to do what is called calling the code. This is a very common word. Calling a function means you are executing the function, or you're telling the function to run and execute the code inside of it. And you can also add information into the function when you call it. We will see that in just a second. But with all of that covered, let's actually create some basic functions. And this we should do in our code, so let's have a look at that. And to create a function, we need a special keyword, and this is called def, short for define. And now we need a name for a function. And in here, we have the same naming convention that we have for variable naming. So for example, a name for a function could be test_function, and this would be perfectly fine. And once we have the name, we need a pair of brackets. And those you always need. I will explain in a second what they actually do. I am going to leave them empty for now though. And now we need a colon. And if I now press enter, I am going to be in one level of indentation. This space here tells Python, or well, this indentation, that any code we have inside of here belongs to this function. Really important to understand. It works like a for loop or an if statement, same principle. And now in here, we can write any code we have already seen. For example, I could print hello. I could create a new variable. Let me call it test. And test could just be 1 plus 2. And then I could print test. We can write the very same code in here that we can write in normal code. And once I have this, I have created a function. So this is the first step. And now to call it, I need my test function, so the name of it, and then add brackets afterwards. And this entire process here is called calling a function. Essentially, every time you are adding brackets after the name of a function, you are calling that function. And what that essentially means is you're telling Python you want to execute all of this code here. If I run the code, we can see hello and free. So this hello here and the result of 1 plus 2 printed in this line. And what I can also do now, I can duplicate this call of the function and run this again. And we can see this code run or executed multiple times. And I hope you can already see why this is useful. You can basically create some specific functionality in here and then execute it wherever you need. So if you had some really complex code and you wanted to organize it better, this is one of the main ways you would be doing it. And let's actually do another example. And for this one, let's do something more specific. I want to create a calculator. And again, I need brackets. And all I really want to do in here, I want to create a variable result. And this result should be the result of number 1 plus number 2. And once I have that, I want to print my result. Meaning this would be an incredibly simple calculator that just adds two numbers together. But for this to work, we kind of have a problem. And that is, how can we get this and this number here? And for that, we're going to need these brackets here. And those brackets are called parameters. And what they mean is, let me add them actually. I can add a parameter for number 1 and a parameter for number 2. And let's actually do the entire function. Now, when I call this calculator and execute it with brackets, I have to add arguments in here. Let's say 2 and 3. If I run this now, I can see 5, which is the result of 2 plus 3. Now, why did this happen? Essentially, this number 1 here and this number 2 are both parameters. And a parameter is essentially a variable that you can only use inside of the function. Meaning this number 1 here, we can use as a variable inside of this function. Same for this number 2 here. And then the value for these two parameters or these two variables inside of the function come from the information that we pass into the function when we call it. Meaning this number 2 here is going to be the value for number 1 and number 3 is going to become the value for number 2. Let's actually do this the other way around. When we are calling the calculator by calling the name of the function and adding brackets afterwards, Python is looking what happens inside of the bracket. And right now we are adding two numbers, 2 and 3. And next up, Python looks at the actual function and the parameters. And right now it has number 1 and number 2. And now what happens is that Python is going to add the first argument, which right now is this 2. It is going to assign the value of this 2 to the first parameter. And then the second argument, so this 3 here, is going to be passed into the second parameter. And that way, num1 becomes 2 and num2 becomes 3. And once we have that, we can use those two numbers like variables inside of the function. Although one thing you do have to be aware of is that both of these parameters only exist inside of the function. Meaning if I try to print num1 outside of the function, I would get an error. And that error is name1 is not defined, because this name1 here only exists inside of this function. So in the code, besides calling the calculator once, I could also call it twice and add different numbers, let's say 10 and 20, and I would get the result again. So again, this function here we can call multiple times. And well, with that, we already have the basics of functions. So let's do an exercise. And what I want you guys to do is to work on this calculator and give it some more functionality. It should still accept num1 and num2 for two numbers you can add. But besides that, the user should also be able to add an operation, so a third parameter. And I want you guys to add a plus and a minus operation here. So for example, if the user adds, let's call it the better calculator, in here we can add 1, 2, and then we can add minus, or we can add plus. And obviously, if the user does that, we get either plus or minus operations. Now, first of all, I have to create a new function by writing better calculator, the name of our function. And now in here, I need three parameters. I want num1 and num2 again. And besides that, I need an operation or operator, doesn't really matter what you call it. And one important thing really quick, since these parameters are always relevant only to the function, we can reuse names here quite easily. Meaning to Python, these num1 and num2 parameters and these up here have no relation whatsoever. So don't worry about naming here. Now, what I want to do inside of this function is to add an if statement. And in here, I want to check if the operation is plus, and if that is the case, my result should be num1 plus num2. And once I have that, I want to print, let's do this a bit more fancy. I want to add an f string, and in here, I want num1 plus num2 is equal to the result. And we can actually try this. So I already called the function with 1, 2, and plus. And the plus we have in this if statement here. Meaning if I run this, I get 1 plus 2 is 3. And let me comment out these two lines here, so it's a bit cleaner. And one important thing here, the indentations continue on each additional level. I guess we haven't talked about this too much yet, but inside of this function, all of the code has to be on one level of indentation. And now, if we use more code inside of this, like an if statement, for example, we have to add the code for this if statement inside of another level of indentation. And that way Python knows that this code here belongs to the if statement and all of this code here belongs to the function. It's really important to understand indentation early on. Python uses it extensively to organize the code. If I add a minus to this calculator, we get nothing because we have no if statement for any of this. But we can add it quite easily because I want to add an elif statement. And in here, operation, I want to check for minus. And now for this one, I can just copy all of this. And now the result should be num1 minus num2. And then for printing all of this, there should be num1 minus num2. And now if I run all of this again, I get 1 minus 2 is negative 1. That seems right. And now I can copy this line, change the numbers, let's say, I don't know, some larger numbers. Let's add a plus here. This is not how you spell that. Let's run this now. And we are getting something that looks pretty good. And I hope now that we have some better examples, you can see the value of functions. This is a really good way to organize your code, because when we actually execute the code, we just have one line. But this one line executes a whole bunch of code. And in actual programming examples, you might have hundreds of lines inside of one function. And what you see most of the time is that programmers create all of the functions at the top of the file. And then a bit further down, the actual code logic is written. And that way you create some pretty good logic that is quite easy to follow, and you could just change some functions here if you wanted to. Now with that, we have basic functions. Although you can do quite a bit more with functions. And the next part we have to talk about is arguments and parameters. So let's talk about that in the next section. So let's talk about parameters and arguments. And let's do a quick recap because it's really important to understand these names. When we are creating a function, we are setting some parameters. This would look like this. For this function, we are creating parameter 1 and we are creating parameter 2. And these parameters we can use like variables inside of the function. So for example, inside of the function, we could print parameter 1 and parameter 2. And again, remember, these parameters only exist inside of the function. And now the next important step is when we are calling the function, we are adding an argument to give the parameter a value. Which means when I call the function and I pass in hello and 42, then the first argument is going to be assigned as the value to the first parameter, and the second argument will become the value for the second parameter. And after that, we are using those two parameters like variables inside of the function. And the output we would get in this example would be hello and 42. And the basic thing you have to take away from this is that a parameter is basically a slot for an argument. We are only using arguments when we are calling the function here, and the parameters are the slots that we add the arguments to. Now, there's one thing that we also have to talk about, and that is how this ordering happens. So how do we assign this hello to parameter 1? And by default, arguments are being assigned to parameters via their position, meaning the first argument is going to be assigned to the first parameter, and the second argument to the second parameter, and so on. But there is another option, and that is called keyword arguments. And for this one, you specify the specific parameter you want to add an argument to. And let's have a look at this in practice. That should explain this the best. Here again, we have a completely empty sheet of code, and I want to create another function that I called test function. And right now, I want to have argument 1, argument 2, argument 3, and argument 4. And then inside of the function, I just want to print all of these arguments. So let me copy it a few times, 3 and 4. And now, when we are calling this test function, I can add, for example, 1, I can add hello, I could add true, and let's say for a list, I could add 1, 2, and test. You can essentially pass anything you want as an argument inside of a function. If I execute this function, we get 1 hello, true, and a list. Now, the problem we have here, when we are using position to assign this argument to this parameter, for example, is that this can get messy really fast. And I think you can already see this one here, where it's kind of hard to tell where things belong to. It's really starting to look messy. And 4 arguments still is a fairly low amount. Imagine we had 20 arguments in here, which isn't impossible. So we want to have something to organize this a bit better. And for that, we have keyword arguments. And what those are is, well, we're adding the name of the parameter, in this case arg1, and then we are assigning it a value like we are assigning values to a variable. This, in this case, I want to do for all of these different arguments. This would be argument 3, and this would be argument 4. And if I run this now, we can see the very same result. Although here, when we're using keyword arguments, Python does not care about the order. For example, I could assign argument 4 here, and at the end, I assign argument 1. If I run this now, the first item, so argument 1, that we are printing here, is going to be this list. And this would then be a clear way to call your function. What you can also do is to add this over multiple lines. So I can do something like this and call all of this again, and it would still work. Python here is quite smart, and it understands that all of this is one function. And this one here is actually fairly readable. So even if we had more arguments, this would be workable quite easily. Now, what you can also do is combine positional and keyword arguments, although you do have to be careful here. And let me do one example. Let's say I want to assign argument 1, argument 2, and argument 3 via keyword arguments, and then the final argument should just be a positional argument. If I run the code now, Python is going to complain. And the complaint here is positional argument follows keyword argument. And this is a general rule you have to follow, that positional arguments always have to come before keyword arguments. Meaning this positional argument here would have to be before all of the keyword arguments. Let's say now I only want to have argument 1 as a positional argument, and all of the other arguments, this one is arg4, I want to have as keyword arguments. If I run the code now, this is working just fine. And the basic reason why we have this is, let's say I want to assign this argument here via position. And right now, this would be the 4th argument because this is the 4th item when we are calling the function. Problem is, if I change this argument 2 to argument 4, then this keyword argument would also be referencing this argument 4 here. And as a consequence, Python would get confused. And if we have positional arguments before the keyword arguments, this is somewhat mitigated. Although you could still mess this up. For example, if this first argument here is argument 1, and then the first keyword argument also references this arg1, and I run the code, we are getting an error that test function got multiple values for arg1. So you do have to be careful here, but it's generally quite doable. Now with that, we have positional and keyword arguments. There's one more concept that I do want to cover, and that is default arguments. And the concept here is really simple. Let's say for this argument 4, if we don't get a value, I want to assign a default value. And this I do by simply adding an equal sign and now adding a value. Let's say for argument 4, I want argument 4. If I have this setup here, I can get rid, theoretically, of this argument 4, call my function, and now argument 4 is going to be argument 4 here, or the parameter value is going to be this string. And what you could even do if you really wanted to, you could assign a default argument to all of your parameters. That would look like this. I hope I didn't forget anything. And now you could call the function without a single argument, and it would still work just fine. Although this again becomes kind of hard to read, but sometimes this can be quite useful. Now let's do an exercise. And let me copy in what I want you guys to do. It's getting a bit long. So I want you guys to create a greeter function with 3 arguments, or well, 3 parameters. We have person, greet, and weekday. Person and greet should have default arguments. Person for the person parameter and hello for greet. And inside of the function, use an f string to print the greet and the person and also print the weekday. And when you're calling the function, use at least 1 positional argument and 1 keyword argument. And pause the video now and implement all of this yourself. I want to create my function all the way at the top below my test function. And the function name is greeter. And in here, I want 3 parameters. Let me actually fix this one, 3 parameters. I want to have person, I want to have greet, and I want to have the weekday. And with that, we have covered the entire first line. Now, next up, for person and greet, we want to have default arguments. For person, this should be person. And for greet, this should be hello. And now inside of the function, I want to print an f string. And that is the third line of the exercise. And in here, I want to print the person, and I want to print the greet. And I guess on top of that, we could print another f string. And in here, let's say it is the weekday. And now with that, we only have to call the function. And let me comment out the test function. And instead, I want to call my greeter. And now we need one positional and one keyword argument. Let's say the first argument has to be positional, because remember, positional arguments come before keyword arguments. And let's say the person then is going to be Bob for me. Now, next up, we need a keyword argument. And for this one, I want to go with weekday. And let's say it's Tuesday. And now, since greet has a default value, this should be all we need. So if I run this, we are getting an error. And the error here is that non-default argument follows a default argument. Meaning Python is unhappy that we have a default argument, and then no default argument. And this again can cause confusion in terms of what argument we are assigning to what parameter. And I guess in our case, to fix it, for the weekday, we can also assign a default argument. Let's say Monday is our default weekday. So now if I run this, this function is working just fine. And I can assign arguments via keyword arguments. So I have person, weekday, and for greet, let's say I can say welcome. This would also work. And I can also use positional arguments to assign the values like so. And if I run this, we would get something slightly weird, because now we are assigning this Tuesday here to this greet. So you do have to be careful. But at the very least, this is working. And I guess let me put this exercise on top of the greeter so it's a bit easier to read. And all right, with that, we have some default arguments and keyword and positional arguments. The main thing you should be taking away from this video is how you assign arguments to parameters. Understanding that is really important to use functions. We can actually do some more things with arguments. So let's put this in the next section. Okay, so let's talk a bit more about parameters and arguments. And the main question we have to answer for this part is, what if you don't know the number of arguments? Can you still make a function? And the answer for that is absolutely yes, although we do have to learn some new things. And let's do this straight in code. Here I have a completely empty file, and I want to create a new function that I want to call print all. And this function should take an unlimited number of arguments. And then inside of the function, I want to print all arguments. But the problem is I don't know how many arguments I am going to get. Now, one thing that you might have already figured out, you could add some parameter called arguments. And this arguments would be a list, meaning if I run print all and add a list in here with, let's say, 1, 2, 3, 4, 5, and hello. Now, inside of the function, I could run for argument, that is not how you spell that, in arguments, and I want to print the argument. And this is indeed working. Via the list, we can basically add as many arguments as we want, and this would still be working just fine. There's no limit on this. Although this is kind of annoying to work with. And because of that, Python has a special way to work with unlimited arguments. And this is called, let me add a comment here, it is called list unpacking. And how this works is we are adding a star before the parameter that we want to unpack. And now what I can do, when I'm calling the function, I can remove this list here and just have unlimited values. And if I run this now, we are getting the same result. So what is happening here? And I think the best way to understand this is just to print what we get. So let me print the arguments and run the code again. And now you can see we have a tuple with all of these values here. And then later on inside of the function, we are just looping over this tuple and printing each item inside of it. That's all that's happening in here. And that is essentially all the unpacking operator does. It looks at all of the arguments we potentially have and then return all of them as a tuple. And we can use it along with other parameters. For example, if I added another parameter here, let's call it first. I want to print my arguments and I want to print first. And let's see what we get. We get 1 and then we get all of the other items. Meaning what happened? In this function call here, Python sees that this one here is the first positional argument and we have one parameter. So Python is putting this one in there and then it sees we have a list unpacking arguments and we have a ton of arguments here. So all of these are being stored in this arguments as a tuple. And once we have that, we can work with them inside of the function. And this would also work with a parameter after the list unpacking. Although for this one here, we would need keyword arguments. So let me print the extra parameter here, the one that comes after the list unpacking. If I run this now, we have print all is missing one required keyword only argument extra. And Python here is quite specific. We want a keyword argument for extra. And this extra here, since it comes after the unpacking, has to be a keyword argument. The reason for that is that Python by default doesn't know when this list unpacking ends and when this parameter starts. But, well, we can fix that quite easily. Let me remove the error message. I can assign extra another value, let's say 12, and remove this 12 here. If I run this now, this would be working again. And here are the values we are getting. And with that, we have simple list unpacking. And now we can essentially add unlimited numbers of arguments inside of our functions. Now this you can actually make even more powerful. And how this would be working is with keyword unpacking. And for that, let's create another function. And this, let's call it print more. And here, I again want to have my arguments. And those I want to unpack, but now I want to unpack them again. And those I want to unpack, but now I want to use 2 stars. And you see in a second why. And I guess inside of this function, let's just print the arguments of what we are going to get. And let me comment out print all, and let's call print more. What this double star arguments does is it looks for keyword arguments and then unpacks all of them inside of a dictionary. So we have arg1 could be 1, then we have arg2 is going to be test, and finally we have arg3 is going to be, let's say, a list with 1, 2, and 3. If I run this now, we get a dictionary with 3 key value pairs. We have arg1 with the value 1, arg2 with test, and arg3 with a list. And those are the 3 arguments we passed in here, or keyword arguments to be more specific. And we are getting this dictionary because of this double star here. Now, so far, we haven't really learned how to work with dictionaries. So we don't really know how to use this dictionary, but we're going to learn about that in the next major section. So for now, don't worry too much about this. But we are going to work with this quite a bit more later on, when we learn more about dictionaries. For now, all you have to understand is if we're using double star and arguments, then we get all of our keyword arguments as a dictionary returned in our function. And what you can also do, finally, is combine these arguments or the list unpacking arguments and the keyword unpacking arguments inside of one function. And for that, let's create a final function. Let's call this one print even more. And in here, I want to have my arguments and I want to have my keyword arguments. And these args and quarks is what you see quite often. It's just a shorthand for arguments and keyword arguments. And now inside of this function, we could basically pass in whatever we want. It would all be captured by these two parameters. Let me print the args and the quarks. And now I can comment out this function call and add print even more. And now in here, I can just add whatever I want. Let me add hello and true. And then besides that, I can also add, I don't know, test is going to be 1, test2 is going to be 5, whatever you want in here. And now if I execute the code, we get a tuple from the args parameter and the dictionary from the quarks parameter. And even if you didn't add anything in here, so if I didn't have any keyword arguments, it would still work. I would just get an empty dictionary. And that means if you have this kind of setup, as long as you add any kind of parameter that is valid Python code into the function, you are going to execute that function, or at least you're not going to get an error in this stage of the code. And well, with that, we have covered some really powerful stuff. And let's practice it actually. And what I want you guys to do, let me add an exercise down here. And what I want you guys to do, let me paste it in here. I want you guys to create a calculator function that prints the sum of an unlimited number of numbers, or well, unlimited amount of numbers. So pause the video now and try to figure this one out yourself. All right, let me paste this exercise here. So we have all of our function at the top of the code. And I want to create a new function that I'm going to call calculator. And in here, we want to have an unlimited number of numbers. So I want the tuple or the list unpacking operator, and let's call it args. And now essentially what I am going to get in here is a list. Let's actually print it. So I want to print my arguments. And now let me comment out this function here. And I want to have my calculator and add a random amount of numbers. If I run this now, we are getting a tuple with the numbers we are passing into it. That's a really good start. What we have to figure out now is to get the sum of all of these numbers. And this we can actually do quite easily. But let me do it over 2 lines so it's a bit easier to read. I first of all want to create a new variable. Let's call this one the result. And the result is going to be the sum of my arguments. Remember here, this argument or these args is going to be a tuple, and tuples can be used with the sum function. And the sum function is just going to return the sum of all the numbers inside of that list. This list here in our case. And once I have that, I want to print the result. So now if I run this, and we're getting 21. This seems accurate. If you wanted to be more efficient with your code, you wouldn't actually need this result here. So you could just print sum of the arguments and not the result at all. Let me comment it out. This one would also work just fine. Although the earlier one was a bit easier to read. So let's stick with this one. And with that, we have a function that uses list unpacking. Alrighty, welcome back. In this part, we are going to talk about functions and scope, which can be a really annoying but very important topic. Basically what it means is that variables created inside of a function are only available inside of that function. And this is called a local scope. And if we are creating variables outside of a function, we are creating a variable in the global scope. And the problem a lot of beginners have is to combine the local and the global scope. And I think all of this is going to sound a bit cryptic, so let's do this in a bit more of a practical way. Here we have a completely empty Python file. And I want to create a variable I called a and assign it a value 10. Doesn't really matter what it is. And after that, I want to create a function. Let's call it test_func. We don't need any parameters. And in here, I want to print a. And this is going to work. If I print test_func, I can run this, we get 10. all of this is working perfectly fine and there are no problems whatsoever. However, now we can do something weird. Let's say I want to get a and add some kind of value to it. Let's say 2. If I now run the code, we are getting an error. And the error we get is a local variable a was referenced before the assignment. Now, to understand that, we have to understand the local and the global scope. And this a here is a global variable. And we know it is a global variable because it was not created inside of a function. It is just there by itself. However, this test funct here has a local scope. And the reason why we got an error is because when we are creating a variable like this a inside of the function, we are creating a new variable inside of the scope of this function only here. And since we are now adding a value to it when we are creating it, Python gets confused because there's no original value, at least according to Python. What we could be doing is set this a just to 2 and now run this again, and this is going to work. And now this might be even more confusing because now we have an a inside of the function and an a outside of it. And to Python, those two are completely separate variables. There are no connections for Python. And the reason why there is no connection is again because this is a local scope of the test function. And all the variables we are creating inside of it only exist inside of this function. Meaning what I could also do now is create another function. Let's call it test func2. And in here, again, I can create variable a again. Let's give it another value, 200, and print a again. And now I can run test func2 and run all of this. And now the value for this a here is going to be 200, the one we are getting down here. And again, the reason why this works is that each of these functions have their own local scope. And on top of that, we have this global variable here. And understanding scope does take some time, but there's one really important thing I do want to cover. And that is that functions are supposed to be separate from the rest of the code. This scope isn't a necessity, it's by design. And the reason is that once the code becomes more complex, it is really easy to run out of variable names, which can be very annoying. For example, for the car we could have one function for the battery and one function for the tank. And both might have some kind of capacity variable. And because of the local scope, this is perfectly fine. We can reuse that word. If we didn't have functions, we would have to play around with that, like capacity battery, capacity tank. But then if we have more and more capacities, this gets really annoying. And this is one of the main reasons for scope inside of functions, that we want functions to be separate from each other so we can focus on one function at a time. So let me put it in red. Local scopes inside of a function help us keep things organized. Especially later on, when we are writing more complex code, this is becoming incredibly important and incredibly useful as well. But alright, still, when you get started with this, it's very, very annoying. So let's talk about the rules of scope. They are not that complicated. The first one is that every function has its own local scope, and every local scope is separate. And let's play around with that one. And this we have actually already seen in practice. We have test func here and test func2. And both of those have the variable a inside of them. And this variable a is completely separate for each function. And I guess just to keep with the example from earlier, this could be something like capacity, and I could print that capacity as well, and we will get different numbers. And I am probably repeating myself, but this capacity here, for example, only exists inside of this function here. And this also means I couldn't print capacity. Or well, I could, but Python would give me an error that name capacity is not defined. And the problem here is that this capacity we are trying to print in the global scope. But capacity does not exist in the global scope, so I can't do that. I can only print capacity inside of the local scope of the test function, because in there it does exist. And well, that is the first rule of scope inside of a function. For number 2, we have global variables, and those can be accessed in the local scope, but they cannot be changed or created, at least not by default. And let's have a look at this one in practice a bit more. This one is really important. And let me comment out all of this so we have an easier example. And this is actually what we have seen earlier. So let me run test func, let's call it test func3 to keep things a bit more organized. When we started this part, I just printed a, and this did work, meaning now if I run test func3, we get 10. And what happened here is we are creating a variable inside of the global scope. And then inside of the local scope of the test function, we are printing this. And if we are running all of this, we don't get an error and we are printing the global variable. This is working just fine. And the reason why it is working is because we can access global variables inside of a function. However, what we cannot do is update the value, meaning we couldn't do something like a plus equals 2, because then we are updating the value, which Python doesn't like. Now with that, we have the problem of scope. The question now is how can we solve it? And for that, we can use parameters, global, and return. And parameters we have already seen. It's just a normal function parameters, and those allow us to pass global variables inside of the local scope of a function. The more interesting ones are global and return. And I do want to emphasize straight away that global is a very easy solution to scope, but not a good one. You will see in a second why. But the one you want to use the most is return. This one is much better, and global you generally want to avoid. But let's actually have a look at how they work. The first way to overcome the local scope of a function is by declaring a variable to be global. And this you do by just typing global and then the name of the variable you want to declare as global. In my case, a. And now if I run this, this is working just fine. The reason why it is working just fine is because when Python now sees this a plus equal 2, we are telling it that this a is a global variable, which means Python is now looking in our global scope for the variable a, and then we're using that value. And if you really wanted to, you could declare global all of your local variables inside of every function you ever write and then never worry about scope ever again. Which I guess would be possible, but a really bad solution. You are supposed to be using a local scope and keep variables inside of that. Which is why global is not really used that often, and when it's used, it's not really looked that favorably upon. You generally want to avoid it. A better way would be using parameters and return. And parameters we have already seen. So for this test function, we can just create a parameter, let's call it a as well. And now when I'm calling this test function free, I want to pass in my 10. And if I run this now, we are getting 12 again. Meaning if you want to update a global variable inside of a function, you would want to use a parameter. That is generally how you get global variables inside of a function and then work with them. And to get values outside of a function, you usually want to use the return value. And in my case, for this function, I want to return the value a. And this return is the same return that basically anything in Python does. It's just a custom implementation of that principle. Meaning, if I have that, I can comment out my print a, and now when I run this function, it is going to return the value of this a. I could, for example, print it, and if I run this, I get 12 again, or 10 plus 2. And just to go over what's happening here. I first declare a 10 inside of the variable a inside of the global scope. Then this a I pass into the function, so we have a parameter inside of the function that is local to this function only. And to this value, we are adding the integer 2. And after we are doing this, we are returning this new value. And then this value is being printed with the print function, and we are getting 12. And all of this is working really well. And if you wanted to update this value here, you could even do something like a equals the test function with a, and now we could print a and get the same result. And this is then how you would actually want to work with functions, that you're using parameters and the return statement to keep everything inside of the function organized and separate from the rest of the code. And especially for beginners, this is generally something kind of confusing. So I guess when you are just getting started, using global can be okay sometimes, but you generally want to rather use return. It is a much cleaner way. But all right, let's do an exercise on all of this and let's see how well you understand it. And basically what I want you guys to do, let me copy all of it. I want you guys to create two global variables called multiplier and hasCalculated. Multiplier should have an integer and hasCalculated should be set to the Boolean false. What integer you set is entirely up to you. I really don't care. After you have done that, create a function called multiplyCalculator. And this one should take one argument and then calculates the multiplication. Let me put this on another line. It simply multiplies that number. That's just about it. All you really have to do is inside of the function, multiply the parameter with the global variable multiplier. And once the calculation is done, set hasCalculated to true. And that is this global variable hasCalculated. Then store the new number in a variable called result and return it from the function. And finally, print a return value of the function after it was called with the number. Okay, probably read through this a couple of times. It's a tiny bit longer, but pause the video now and try this one yourself. Alrighty, let's do it together now, and let me comment out all of this at the beginning so we don't get confused. First of all, I have to create two global variables. One is called multiplier, and this one I want to set to an integer, let's say 5. And after I have that, I want another variable called hasCalculated, and this one by default is going to be false. And with that, we have these two parts already covered. Next up, I want to create a function called multiplyCalculator. And this one takes one argument, so it needs one parameter. Let's call it number, meaning now we are basically here. So next up, I want to do this step here. I want to multiply my number with my multiplier. And this is perfectly fine for Python because remember, we can use global variables inside of the local scope. So this multiplier here is from the global scope. So we can use it, but we couldn't update it. But next up, we have to take care of the hasCalculated and set it to true, this part here. And for that, I want to set hasCalculated to true. But here now we have the problem. This is the local scope. So we cannot update this global variable here. And I guess for now, the easiest way of doing this would be to set global hasCalculated. And well, with that, we have this part covered here. Now, next up, we have to store the new number generated inside of a variable called result and return it. And all I really want to do in here is the result of, well, this operation here. And let me put this below hasCalculated, that feels a bit cleaner. And now what I want to do is to return that result. Meaning whenever we call this multiplication function, we are returning this value here. And this I want to use with print, and I want to multiplyCalculator. And in here, I can add any number I want. Let's say 10, and let's see what we get, 50, which is 10 times 5. So this is working just fine. And what I can also do now, I can print as calculated, and this is now true. So as soon as we're calling this function, this is being updated. Although there's one really important thing about the return statement that I forgot to mention earlier, and that is that return ends the execution of the function. For example, if has calculated is after return, and I run this again, has calculated is still false, because this has calculated is equal to true is not being executed. And that happens because return ends this function call. The function essentially ends here. This is something you do want to be careful about. But all right, with that, we have scope. And again, scope very early on can be kind of a tricky topic. So I hope all of that makes sense. But for now, don't worry too much about it. Just play around with different examples of code and come back to this video when you get to something more complex. It will become more important, and I hope eventually starts to make more sense. For this part, we are going to cover Lambda functions. And Lambda functions are fortunately fairly simple. All they really are single line, very simple functions. And the syntax for them looks like this. We have the Lambda keyword, then we get whatever parameters we want to use, and then we have a colon, and at the end we have an expression, and this is the actual code. That's really all it does. It's a single line function if you have some very simple functions you want to work with and you don't really want to write a whole function. This, for example, could look like this, where we have lambda, then we have an x parameter, and inside of the function, we are just adding x plus 1. And an important thing about lambdas is that the result of this expression, this one here, is returned automatically. Meaning when we are passing 10 in here, this lambda function returns 11 automatically. And I guess let's have a look at this in practice. This shouldn't be too hard. All right, once more, we have a completely empty Python file, and I want to create a lambda function. And let's use the example I've just mentioned. So I have a lambda function, and the one parameter I want to use is x. And what I want to return is x plus 1. And this is then the entire function. How you would use this is by assigning it to a variable. And this variable now contains a function, meaning we can call it by using brackets again and passing in any number we want. Let's say a 10. And if I run the code now, we don't get anything because we have to print this value. Let me print it, and we get 11. And that is the main idea of lambda functions. It's basically very, very simple functions that only consist of one line of code. I guess a slightly more useful one could be, let me copy this one here. Let's call this one simple calculator. And for this lambda, I want a and b. And all I really want to do is return a plus b. Meaning now I can call my simple calculator and pass in, let's say, 2 and 3. If I run this, we get 5. Obviously, right now, these examples are so simple that you wouldn't even create a function for it in the first place. I guess instead of this simple calculator, you just write 2 plus 3, and you would get the same result if you can type properly. So why would you ever use these kind of lambda functions? And there are two main reasons that we don't really are going to cover in too much detail. The first one is that some functions want other functions as argument. And this is something we are going to see later. For example, Python has a sort function, and this one sorts any kind of list. For example, a list like 1, 2, 3, 4, and 5. And we could sort this if it was unordered. Let me mess it up a bit to something like this. To order this function, Python is expecting another function to tell it how to order this list. And this function would usually be a lambda because we don't want anything too complicated. We are going to cover this later on. The other examples where you see lambdas fairly often is with graphical user interfaces. And essentially what happens in there is that every button gets one Lambda function because a button would only return a value like 5, for example. So you don't really want a full function, you just want some very simple line of code that executes some basic thing when a button is being pressed. So this could be really useful, but for this introduction to Python, we are not going to cover it. But all right, with that, let's do an exercise and then we should be done with it. And for the exercise, I want you guys to create a Lambda function that accepts one argument that should be an integer. And if the integer is greater than 5, return hello, and otherwise return bye. And then obviously, when you have created this, call this function and print the result. Let me comment out these Lambda functions here. And I want to create a new Lambda function that accepts one argument. Let's call this one x for the parameter name. And now I want to return hello if this x is greater than 5 and bye if it is below 5. And for that, I want hello if x is greater than 5, and if that is not the case, so else, I want to print bye. And this Lambda function I now want to assign to a variable. Let's call it x, but it doesn't really matter what it is. And now I can print my x and pass in a 3, we get bye, and if I pass in a 10, we get hello. And with that, we have covered lambdas. They honestly aren't that difficult, and you really aren't going to use them that often, so don't worry too much about them. Alright, next up, we have one final topic for functions that is actually really important, although it might not seem that much. For this part, we are going to talk about documenting functions. And this is incredibly important, although we are not adding more functionality. All we are doing in here is explaining what our function does. And this might not seem important, but it really is. Because functions can get really complicated, so you want to explain them. And this is something you are going to notice when you are starting to code, where you are writing a function and then don't look at it for a couple of weeks. You probably have absolutely no idea what you did. And when you look at other people's code, it might be even worse. And well, explaining what your function does is just good form and really helps you when you work with other people. And there are two things you can do to your functions to explain what they do. The most common one is you just add some explainer text, and this is called a doc string. And besides that, you can also add what is called type hinting. And all that really means is you indicate what you expect for the parameters and for the return value of the function. And if you have all of that, your function should make quite a bit more sense. So let's implement all of this. All right, here we have a very simple example of a function. If I run this, we are just printing 2 arguments. So obviously this isn't complicated, but I just want to keep it simple. And to explain what your function does, you can add what is called a doc string at the beginning of a function. And a doc string you create with quotation marks like any other string. And for a doc string, you always want 3 quotation marks on each side. It looks like this, and Sublime essentially turns this into a comment by default. And now for this doc string, you can write whatever you want, or well, whatever explains your function the best. Let's say I could call this one a simple function that prints 2 parameters. And if I run the function, we don't see any difference. However, now what you can do, you can print the name of the function, test in my case, then dot, underscore, underscore, doc, and underscore, underscore again. And if I run this, I get the doc string of the function, or a simple function that prints 2 parameters. Now, why we're using 2 underscores before and after this doc, you are going to understand later on. For now, just write it like this. It really isn't too important for you right now. Just remember how it looks like. I suppose another way you could be accessing this is by writing help and then test. And if I run this, we get some more information about the function. And in here, we also can see the docstring, a simple function that prints 2 parameters. And it is fairly common to use either of those to understand what a function does. Meaning, if you write code with a team, you really want to use this. But, well, that's basically it. It isn't that complicated. Now, besides that, what you can also do is to hint what you are expecting for these parameters and what the function should return. And right now, this function doesn't return anything, so let's add return a plus b. And now I want to indicate that for these parameters, I am expecting integers. All you have to do for that is to add a colon after the parameter and then add integer. If you wanted to, you could also set a default parameter for this. And this you do in a normal way by just adding an equal sign and let's say 10 for this value. And all this really means I am telling other programmers that for this a parameter, I am expecting an integer, and by default, this parameter is going to be 10. And for b, I also want an integer, but I don't have a default value. And with that, we have some default parameters where we are indicating that we are looking for integers. And let's say for b, I want a default value of 0. And with that, we are indicating to other programmers that we want 2 integer values that both have a default parameter. Meaning, if I run the code now, we can see, well, not much of a difference. Because this isn't supposed to influence what the function actually does. And besides that, we can also indicate what is being returned from this function. So this line here. And this you do by adding an arrow after the function, but before the colon. That's really important. And then here, you again add the name of the type. And here, again, use the name of the type you want to return. For an integer, this would be int. I guess other data types could be str for string, bool for a boolean, list for, well, a list, and dictionary for a dictionary. But in my case, I want to stick with an integer. And now I can run this again, and we again don't see any kind of difference. And a really important thing you have to understand about type hinting is that all of this is optional and it can be ignored. So for example, what I could be doing is add a string in here and also a string in here. I know, let's say test. If I run this now, the function is still going to work. Let me comment out those 2 lines here to make it a bit more readable. So now we have indicated for the function we are expecting an integer, but when we actually call the function, we are adding 2 strings. And Python doesn't really mind, it still works just fine. So you don't have to follow it, it's mostly an indication of what is being expected. But alright, with that, we have covered all you need to know about functions. In this section, we are going to cover more advanced data operators. And this is one of the parts where Python is incredibly powerful. There are lots of ways to manipulate data and get a certain kind of outcome. There is a reason why Python is really popular for data science and machine learning. It is because there are lots of different ways to work with data. So let's have a look what we can do. What we are going to cover in this section is more advanced ways to loop over data. We're going to sort data. We are going to learn list comprehension, a really important topic, even though the name here is probably a bit weird. And finally, data handling, if we want to import or export data. Let's get started by looking at more advanced ways to loop over data. So in this part, we are going to manipulate lists to get stronger for loops. And this is a super powerful topic because very often in Python, you want to merge a list and then loop over this merged list. And for this, for example, Python has a zip function that zips together 2 lists. And you could also get the index for each of the lists when you use a for loop. And I suppose all of this is going to sound a bit abstract, so let's do all of this a bit more practically. Here we have a nearly empty Python file, and I already have 2 lists. We have inventory names and inventory numbers. And the scenario we have here is you are running some kind of warehouse, And people gave you two lists, one with the things in your inventory and then how much of that thing you have. And for the order here, you are looking at the index, meaning the first item and the first number belong together. Then we have the second item and the second number, then the third one, and so on. We are sorting things here by their order. This could, for example, happen if somebody copies a column from Excel. It's very easy to get. The problem for you is if you want to write a for loop and you have two lists, you kind of have a problem if you want to access both of these lists at the same time. So the scenario here might be you have some kind of website, and on this website you want to display all of this information for customers. So you want to loop over both of these lists. But this you can't do right now. You can either do for name in inventory names, or you could do for, let's call it num, in inventory numbers. But both of these for loops are going to be independent of each other, so you have no way to connect the two. Python, in this case, has one specific function, and that is called zip. What zip does is it wants two lists. We want inventory names in our case and inventory numbers. If I print the result, we are getting a zip object some point in our memory. Not particularly useful. We're going to see how to use this in just a second. But for now, what you can do is to convert all of this into a list with the list function. If I run this now, we can see something much more useful. We have a list with tuples inside. And each tuple is right now the combination, in this case, of screws and of the number. And these are again sorted by the index, which is what I want in this case. That being said, this zip you hardly ever use in a list and inside of a print statement. Instead, you would usually use it inside of a for loop. And the for loop here could be, let's say, for thing in, and now I want to have the zip of inventory names and inventory numbers. And this I can now print as the thing. And let's see what we get. There we go. This is looking not too bad. We have a tuple with our screws and how many of these we have. But the issue still is we want to have each individual value to work with. We don't want to have an entire list. I guess what you could be doing here is use indexing to get one value from this tuple. 0 would give you the items and 1 would give you the inventory number. And you could access both like this, and you would get the name of the item and how many you have. This would work, but it's kind of hard to read. Thing here really isn't too specific. For that, Python has some really interesting functionality. Basically, what we have seen earlier when we assigned two values to two variable names. Instead of writing thing, we could write, for example, name and number. And now when Python goes through this list and it sees a tuple, let's say for the first example, we have screws and we have 43. So this screws here and this 43. This would be the first item we get inside of this zip operation here. It's kind of hard to read. If you have a tuple and you write more than one variable name here, Python is going to unpack this tuple into these separate variables. Meaning in this case, screws would be stored in name and the 43 would be stored in number. And that way we can access them much easier inside of the for loop. So name and number, if I run this now, this is still giving us the same result, except now this is much easier to read. And this is an operation you do surprisingly often. I guess what we can do here to make all of this a bit easier to read, we could use an f string, and then I want to write something like, let's say, name and current index with the number. If I run this now, we get screws current index 43. I guess index isn't ideal. Let's use inventory. That's better. So we have screws current inventory 43. And this information, if you give it to somebody designing a website, would be very easy to work with. Another thing that you could be using here is called the enumerate function. And this one is basically used to get the current index inside of the for loop. I guess an example here could be if you are cycling over this list, and when you get halfway into this list, somewhere here, you want to run some other code. The question then would be, how do you know when you're halfway into the list? And for that, you would have to know the current index. I guess let me demonstrate how this actually works. That should make much more sense. We need enumerate, and this is a function. What it wants is some kind of list or something you can iterate over. In my case, I want to go with my inventory names. And now, if I print what this is giving us, we are getting once again an enumerate object. Doesn't help us too much, but if I convert all of this into a list, I am getting the index and the item from the list. This 0 here is the index of this screws inside of the list. Wheels would be number 1, metal parts would be number 2, rubber bits number 3, and these are the numbers we are getting down here. And again, this enumerate you would basically always use inside of a for loop. Let's say again for thing in, and now I want to have the enumerate function, and inside of this, let me print the thing. If I run this now, we are getting again a tuple with the index and with the name of the item. And just like we have done up here, we can unpack this again. What you usually see is index and then the name of the item, or whatever you want to call it. This is entirely up to you, but index here is the common name for what enumerate returns. Once I have that, I could do something. Let me print an f string again, and here index with the name of the thing. And there we have the current index and the screws. And this I could, for example, use if the index is, let's say the example I had earlier, if we are halfway into this list, I want to run some other code. Maybe I want to notify my boss that my operation here is halfway done, something like that. I want to check if the length of my inventory names is equal to the index, and this will give me the whole list, but I only want half of that. And then here, you do want the flow operator, so you're getting an integer or a whole number, because the index is always going to be a whole number in and of itself. And if that is the case, I can print something like halfway done. Now if I run this, I am getting the first half and then the second half. Although you might have to tinker around with this to get exactly to the halfway point. The most important part here is that enumerate gives you the current index where you are inside of the list when you are using a for loop. And with that, we have two functions you see very often alongside for loops. The other one we have seen earlier was the range function, which also is almost always used alongside the for loop. We can do an exercise and then finish this part. And what I want you guys to do is to combine zip and enumerate to get some kind of string like screws, then in square brackets ID 0, and then inventory, and then the number of inventory items for each of these numbers from this list here. So pause the video now and try to figure this one out yourself. Let's go through it step by step. First of all, we need some kind of for loop. And let me start by just writing thing. We can refine this in a bit. And I want for thing in, let's start with inventory names. In here, I can already print something. We definitely need an f string, and I want to have my thing. This should be in curly brackets. Let me run this now. I forgot we get lots of stuff because I have to comment out all of this. If I run this now, we get the different items from this list. Not a bad start. We have the first word, but well, we're getting there. I suppose next up, I can put all of this inside of the zip function and then combine inventory names and the inventory numbers, I called it. If I run this now, we are getting a tuple. We essentially create a new list full of tuples, and each tuple will be captured by the variable thing. And this is what we are pasting inside of here. This we can unpack. I want to have my name, and I want to have the number. This is basically what we have done up here. I want to have a name, and then I can add my inventory with a colon. Now I need curly brackets and the number. Running this now gets me screws inventory 43. We are definitely making progress. Finally, we need to get the current ID of each of these objects. And for that, we need enumerate. What that means is I want to wrap the entire zip function inside of enumerate. I find this one very hard to write. You might struggle as well. And before we work more on this, I want to check out what we actually get returned from this thing here. It's quite a complex one. So let's see if I print thing. In here, we have one tuple, and inside of this tuple, we have two values. The first one is the index. The second one is another tuple that we got from this zip operation here. Unfortunately now, this thing is kind of annoying to unpack. We can't do this easily. What you might be very tempted to do here is something like index, name, and number. But if you run this, Python is not going to be happy because we have not enough values to unpack. What that means is that Python here returned two items inside of some kind of data structure. In our case, this is a tuple with the index, let's say 1, and then the other value is a tuple with the, let me call it the name, and let's say 43 for the number. And don't let me forget the closing brackets, that is important. Now Python looks at this tuple and it sees two items, this one and this one. But we are telling Python inside of the for loop down here that we want to unpack all of this into 3 parts. But Python doesn't know how to do this because it only sees 2 items. As a consequence, we are getting an error. What is most efficient here is to only use 2 unpacking variables. We have index, and then we have, let's call it the inventory tuple. Let me print the index here and the inventory tuple. Now we're getting all of this. Not ideal, but definitely something you can work with. Let me get rid of this one here and uncomment all of this. Now, what we want. The name is going to be part of the inventory tuple, and it is the one with the index 0. Because remember, this one is just a tuple, nothing else. After we have that, I want something like this. Square brackets with ID and then the current ID. Meaning I need square brackets, inside of that the word ID, a colon, and then curly brackets with my index. Finally, I want to have my inventory tuple, and now I need the first item inside of this tuple. And with that, let me run it. We get all of the different items properly formatted. I suppose the most important part here is to understand this and what different values are being returned. Definitely play around with this one and understand how these things interlock with each other. Zip, first of all, returns a new list with tuples inside that are zip values from names and numbers. And then enumerate creates a whole new tuple by adding an index and then adding the original tuple it got from the zip operation. For this part, we are going to cover one of the most powerful parts of Python, and that is called list comprehension. A very strange name, but it is for a super powerful concept. Basically, what a list comprehension is a way to create a list on one line of code. And this can get surprisingly powerful. You can either use it to create a list or to manipulate existing lists, like to filter out values, for example. But let's keep it simple for now. And let's say you want to create a list with the numbers from 0 to 99. For that, right now, you will probably write something like this. You start with an empty list, then you use a for loop, So for num in range from 0 to 100, because remember, we only go up to this number, we don't include it. And we want to end at 99. And then inside of this for loop, we are getting our list and we are appending the number we're getting from this for loop. Fairly simple operation. And since it is so simple, wasting 3 lines of code on it feels kind of pointless. As a consequence, we would use list comprehension. This one would look like this. It's kind of comparable to a ternary operator actually. We still keep most of the words here. So we have for, the same for we had here. Then we have num, we still have the num here. Then we have the in both of them, and also the range stays the same as well. We pretty much put the whole line here after the number. The major difference now is instead of writing mylist.append, we only need num inside of this. This one automatically gets appended to the list you are assigning it to. And that way you can write all of this much more efficiently. And this is only a very simple example. This can get significantly more powerful. But let's have a look at some easy examples. Here is the operation I have just shown you in the slides. And this, if I print my list, we are getting the values from 0 to 100 inside of a list. And again here, this is 3 lines of code for something that ultimately is kind of simple. So let's do all of this in one line. And let me call it my list comprehension or just comp. And in here, we always need square brackets. This always has to come in there. And then we again need this entire line here. As a matter of fact, let me actually copy it. So we have for num in range 100. The difference now is we don't add a colon and then the operation we want to do, like mylist.append. None of this is going to happen. Instead, the value we want to return to this list comes as the first word inside of it. And this will automatically be appended to this list. As a consequence, we would just need this. We need num for num in range 0 to 100. If I print this now, we are getting exactly the same outcome. All we really have done is condensed this entire line here into a single word, with the entire rest of the for loop staying identical. That being said now, you can make more changes to this part here. For example, you could multiply all of this by 2, run this again, and now you have every value multiplied. You could also put all of this inside of, let's say, a tuple, and then add num, num, and num. And now Python would automatically assign each value inside of the number. Basically what we are doing is this num looks at the range and gets the values from 0 to 99. And then it assigns each of these numbers to one of the values inside of the tuple. And this is then what we are getting here. So we'll get 0, 0, 0, 1, 1, 1, 2, 2, 2, and so on. And this is only the most basic kind of list comprehension you can do. And there's one way to make this significantly more powerful. You can combine list comprehension with the ternary operator, which is just a fancy way of saying you can add if to a list comprehension. There are actually 2 ways of doing it. The first one would be at the end. So num for num in range 0 to 100 if a certain condition is true. Although an important thing here is else does not work. I don't actually know why, but you just get an error if you add an else after this. However, the other way would look like this, where you first add the value you want to return and then the conditional statement. So if num is 10, else 0, and then the for loop we have seen up here. And choose whichever works better for you. Both are totally fine. Just keep in mind, the second one is a tiny bit more powerful. I honestly have no idea why the first one doesn't work with else statements. It might be something internal. And this is something really powerful because you could be using it to filter other lists. Let's have a look at this in practice actually. And let's do some basic examples first. I can add an if statement here at the end, and I only want to get these values here if the number is, let's say, below 20. If I run this now, my list comprehension stops at 19. Although, again, keep in mind, else 0, for example, would not work. I would get an error that says invalid syntax. So this is not good. But what I have to do to get around that, I would have to cut all of this out and paste it here. Now if I run this, this is working just fine. We get all of the tuples from 0 to 19, and then for any other value, we are getting 0. And that is basically it to add if statements in here. One example how you could be using this. Here are the two lists you have seen from the last part. And I want to clean them up. Let's say I want to create a list with all of the parts that have less than 25 items. So I want to select wheels because they only have 12 items, and I want to select the screwdrivers because they only have 23 items. And for that, list comprehension could be really, really powerful, along with the other stuff we have already seen. Let me call it the replenish, that's not how you spell that, replenish list. And now in here, we want to look through all of these items. And for that, first of all, we again need square brackets. And let's start with thing for thing in. And I want to again use my zip list because I want to access both of these lists. And in here, I need inventory, not numbers, but names. And now inventory numbers. If I print now my replenish list, I get the entire list inside of the square brackets. So far, this isn't helpful at all. But now what I can do, first of all, this thing here, instead of thing, I want to name, let's call it name and number. And to get the same outcome again, I would need my name and my number. So far, again, we are still going to get the same outcome. But now I only want to do all of this if a certain condition is true. And in my case, the condition is if the number is below 25. If I run this now, we are only getting 2 items with the name and the number attached to it, which is a very nice way to get data out of this list here. And this is a kind of operation you would actually do fairly often in Python. And list comprehension for that is what you would use very, very often. Now, what you can also do is to combine different list comprehensions. Let me add a comment here. Let's call it combine list comprehension. Although this one is going to get a little bit more complex, but let's go through it in a really simple example. Let me create a new variable, combined comprehension. And in here, first of all, I want to have something really simple. Let's say x for x in range 5. Then I'm going to comment out all the stuff we have done so far and print what we are getting from the combined comprehension. We are getting the numbers from 0 to 4. This should make sense. It is fairly simple. At least I hope it is. But now what we can do is put all of this inside of another list comprehension. So all of the stuff we have seen so far for y in range, let's say 10. If I now run this, we are getting something that possibly looks a bit weird. I think there's a better way of presenting this. Instead of printing the list by itself, I want for row in combined comp, print row. And now if I run this, we can see the entire output like this. Much easier to read. And let's go through what happened here that is probably kind of confusing right now. I think the best way to go over this is to separate these two lists. We have an inner list, this x for x in range 5, and then we have an outer range, the entire list comprehension. That's a terrible line. Let's do it like, that's still a terrible line. Let's do it like this. The yellow part is always this inner part here. And this we now got multiple times. We have one here, one here, one here, and so on. They are all x for x in range 5. The reason why we got this multiple times is because of this part here. We basically created this list 10 times. And that way you can create a list that contains other lists. Although still not particularly useful. But where this system becomes incredibly powerful is you can put this y here, for example, into the original list. Let me actually demonstrate. Instead of just having the x as the value for this list, I want to have instead a tuple with x and y. If I run this now, we are getting, let me use different colors for this. We have a tuple, this tuple here. And this tuple is inside of a list, this list here. That is the list we are getting from this inner list comprehension. Finally, then, we have a list of lists, and this is the entire list comprehension. And I suppose inside of the tuple, we have the x and we have the y value. X increases on every column, and y is increasing on every single row. Here is y0, y1, y2, and so on. With the system, you can create incredibly complex data structures. You could theoretically even add a third and a fourth list comprehension, but by that point things are a bit overkill, I think. I would not recommend overthinking this. It can get really complex, and it doesn't have to be as complex. If you really wanted to make something more complex, you probably want to use a for loop. But all right, with that, we can do an exercise, and then we are basically good to go. And what I want you guys to do is to create the fields for a chess board. And just in case you had actually fun hobbies at school, a chessboard has the fields A, B, C, D, E, F, G, and H, which is 8 letters in total. And then we also have the fields from 1, let's say 1, 2, 3, 4, 5, 6, 7, and 8. Which basically means the first field you are going to get is a 1, and then you keep on creating more fields, and at some point all the way at the bottom, you should have H8. And if you want an extra challenge, this is not actually a chessboard, because a real chessboard would have the A1 at the bottom and the H8 in the top right. I guess I can cover both. See how far you get, but pause the video now and try this one yourself. Let's get started by commenting out all of this. And then I want to start, let me call it chess board. And in here, I want to start with the square brackets for my list comprehension. And I guess we can start with the numbers. So num for num in, and now we want range. And let's start with 8 and let's see what we get. I want to print my chessboard and I get the numbers from 0 to 7, which is not a chessboard. We need the numbers from 1 to 8. For that, I'm going to specify a start value here, and now the end value is going to be 9. If I run this now, we get the numbers from 0 to 8. We have the inner list comprehension. Now for the outer. And now this might have been the one part where you struggled. That was how to get each individual letter here. And the solution is actually really simple. All you need is to type the string A, B, C, D, E, F, G, and H. If you have this, and I run this again, we get this entire list, except it's very hard to read. So let me do it again for row in chessboard, print the row. There we go. This is much easier to read. The problem now is that we want to have the letter and the number. This happens inside of this part here. I want to have the letter and then the number. If I run this now, we have A1 in the top left and H8 in the bottom right. That's a good start. Although I guess doing this as a tuple isn't ideal. But you don't have to. You could totally create an F string here, and in there I want to have the letter and I want to have the number. Now running this gets me something like this. I think that looks a bit more appropriate. The difference here really doesn't matter all that much. And now if you wanted to invert all of this, meaning that instead of the A1 here, you would want this top part to be H1. And then this part down here would be A1. In a chessboard, the bottom left field is always A1, and the top right one, this one here, would be H8. To achieve that, you could just type out this string here in reverse. But that would be kind of annoying and not exactly scalable if you wanted to make something larger. But here we can do something really clever. We can use slicing. Remember this from quite a few videos ago. We are specifying a start, an end, and a step size. Now the start and the end, if we leave them empty, is giving us the entire string. But now if we specify for the step size -1, then we are going to go backwards over this string. Now, to understand this part, you have to understand return statements. Basically, what happens here is originally we just returned this string. But now, because of this slicing operation, the for letter in is looking at the entire operation here, because this is what gets returned. This is really something you eventually understand when you play around more with Python. It does take some time. But now, if I run this, we are starting with H1 in the top left and A8 in the bottom right. And with that, we have a proper chess field. I hope that wasn't too bad. List comprehension, especially early on, can get very confusing. Besides a list comprehension, we have other types of comprehension as well. One for each type of container, at least kind of. And before I cover them, I really want to emphasize that list comprehension are by far the most common comprehension you are going to do. I am going to include these mostly for completion's sake, but you probably aren't going to use them very much. Comprehensions work quite easily with dictionaries and sets. This would look like this for a dictionary and like this for a set. Set is actually super easy. All we are doing here is we are replacing the square brackets with curly brackets, and then we are done. That is literally the only difference. For a dictionary, the one thing you really have to keep in mind is that we always need the key, then a colon, and then a value. In this case, both of them would be num, meaning we would create a dictionary that would have key value pairs like 1 and 1, then 2 and 2, 3 and 3, and so on. Not exactly useful, but it's something you can refine. And that brings us to the final type of comprehension, a tuple comprehension. This one works a bit differently. In here, you are still using num for num in range 10. The problem is, for Python, this kind of operation was already covered using the normal brackets. As a consequence, this operation gets a bit weird. To create a proper tuple out of it, you would need the tuple function. But after you have done that, you are back to a normal tuple with whatever operation you have in here. So not that much of a change. And that is basically it. Let's have a look at all of this in code. And let's get started with a set comprehension. This one we are creating with curly brackets. And now in here, we can just do the normal comprehension stuff. For example, num for num in range, let's say 100. And if I print the set comprehension, I am getting all the numbers from 0 to 99. This is basically all you have to know. And well, let's get to the next one. The much more interesting one, the dictionary comprehension. For this one, we again need curly brackets. But now the important thing is we need a key and we need a value. But once you have those two, you would still continue with for x in some kind of list. In my case, let's go with num in range 100. And now I have to define values for key and for value. I guess from the example, I could name both num and then print the entire dictionary comprehension. And now we are getting a dictionary, although I do want to fix the typo that is annoying me. There we go. Now, what we're getting in here is a dictionary with lots of key value pairs. This is one, this is another, this is a third, and so on. And in here, we have set the key and the value to the same number. As a consequence, they both have the same number, which really is not useful. To make this a bit more interesting, we could, for example, get the power of num and run this again. Now we can see a bit more of a difference. The key is 2 for this one, and the value is 4. 3 gets us 9, and so on. This way you can at least see different values. That is basically it for dictionary comprehensions. Finally, we have tuple comprehensions. And in here, you would use normal brackets. And now you would still write something like num for num in range 100. If I print this tuple comprehension, we are getting a generator object at some location in our memory, which, well, is really not useful. That being said, you could work with this tuple comprehension, for example, in a for loop. I could write for, let's say, value in tuple comprehension, and I want to print the value. If I run this now, we are getting all of the values inside of it, meaning this object is working as intended. We just can't really see the result. To actually see it, we would have to convert it to a tuple, and then we are done. If I print the tuple comprehension, run this again, now we can see the result we would expect. The reason for this is that these normal brackets are used quite often in Python. And in this case, they are in conflict with the tuple comprehension, but that's not something you have to worry about too much. I have never ever seen anybody use a tuple comprehension, to be honest. The one thing you see once in a while is a dictionary comprehension, but most of the time you see a list comprehension and nothing else. And I guess with that, we can do an exercise. What I want you guys to do is to create a dictionary with the keys A, B, C, D, and E. And each key should have a list as a value with the values 1, 2, 3, 4, and 5. That should be one list for each of these keys. Pause the video now and try to figure this one out yourself. Alright, let me start by creating an exercise comprehension, or whatever you want to name it. Since we are creating a dictionary, I want to have my curly brackets. Now in here, let's get started by creating the keys. We need the format key and value, then for x in some kind of iterable. And since these are the values that change, the iterable here should be a string with A, B, C, D, and E. For proper naming here, let me rename this x to a letter. And now my key should be this letter. And since the value doesn't change, it is always 1, 2, 3, 4, and 5, I can just type the value in here. And now all I have to do is to print the exercise comprehension, run all of this, and we can see we have the dictionary here. This one worked pretty well. Let me comment out the earlier part. There we go. This looks much cleaner. In this part, we are going to cover functions that take functions as argument, which is probably going to sound a bit weird, but let's talk about it. When you pass arguments into a function, it is perfectly fine to pass a function as an argument into another function. And let's do this by example to actually illustrate what I mean. And for that, I want to use the sorted function. This one sorts some kind of iterable in some kind of way. It looks like this. The name of the function is sorted, we have to pass in some kind of iterable. Most of the time it's going to be a list, but it doesn't have to be. And then we need some kind of function to tell Python how it needs to sort this list. For example, do you want to sort the list from the smallest to the largest number? Do you want the opposite of that? Or if you have, for example, a list that contains strings, how do you want to sort that? Do you want to go by the character in the alphabet? Do you want to go by the amount of characters inside of each string? It really depends here. Python doesn't know by itself. Meaning you have to write a function to tell how to sort this iterable. And this is the function we have to create ourselves, which, well, isn't that difficult, but you do have to understand the system. So let's have a look at this straight in code. In my code, I already have one list. And this list right now is kind of unsorted. It's a bit random. And to sort it, I need the sorted function. And in here, at the very least, I have to pass in one argument. And that is the list I want to sort. What I get in return from this, let me print it. I am getting the list sorted. And this you usually do with a list. As a matter of fact, a list even has a sort method that sorts the entire list. If I run this, and let me comment out this line here, list.sort, after I run this, I can print my list1, and now the list was sorted as well. This method and this function, they are basically doing the same thing. But this is not what we are here for. We want to look at sorted via the other arguments. And there are two you can pass in here. One is really easy, and one is the function I just talked about. But let's start with the easier one. The one argument you can use here, and let me use a keyword argument, we want to specify a reverse. And in here, Python expects a Boolean. If I set this to true, it reverses the entire list. Now we go from the highest to the lowest instead of the lowest to the highest. That's basically it. What is much more interesting is the key argument or parameter, because in here, Python is expecting some kind of function. And let me actually demonstrate a use case where you would need it. For that, I have another list that I want to store in, let's call it list2. In here, I have a list that contains tuples. In each tuple, we have, for example, A and 3, we have B and 10, C and 6, and so on. And this would be really difficult to sort. If I print sorted and list2, let me comment out the first part and run this again, we now get, well, no change in the list. Python just doesn't know what to do with this list. But in my case, I want to sort this list by the integer inside of each tuple. Meaning this one here should be first, then this second, then this third, and then this last. And for that behavior, I have to tell Python which value to access. And for that, we have to create a function. Let me do it straight below the list, although most of the time you would do it straight at the top of the code, but in my case, I want to keep this a bit more readable. I want to create, let me call it a sort function. And this is always going to need one argument. Let me call it item. And now how this is going to work. Inside of my sorted function, I have to specify a key. And for this key, I want to have my sort function. And really important now, you do not call this function. There should not be any brackets after the sort function except to close sorted and print. You are only passing in the function, you are not calling the function. Python, or well, sorted, does this one internally, so you don't have to do it. And basically what is happening is that sorted goes through each of these tuples in this example and passes each tuple inside of the sort function as an argument. And then this function has to return some kind of integer. Let me write int. And the size of this integer is going to determine how we are ordering this list. So in my case, all I want to do inside of the function, I want to return item and then 1. For example, if I'm getting this tuple here as an argument, all I really want to do is to pick this integer and return it. And then Python knows what to look for inside of this list for the sorting algorithm. And that is literally it. If I run this now, we can see the list is sorted now via the integer inside of the tuple. So we have 3, 5, 6, and 10. And of course, inside of this function, you can be really fancy and add a whole bunch of stuff. The thing is, most of the time, you are not going to do that. In almost all cases, you simply want to tell Python a bit more in detail what kind of value you are looking for. This is very rarely becoming complicated. As a consequence, you hardly ever write a dedicated function. Instead, you use lambdas. Let me actually copy this line. And now I want to have my list too. And for the key now, I don't want a function. Instead, I want a lambda function. And for this one, we again, as the first argument here, we have to specify what kind of parameter we want. That is this item here. This one would be equivalent to this item here. Inside of this, we have to tell Python what to do with this item. In this case, all I want to do is get the item and then pick the first index. And since this item here will be returned automatically, this is equivalent to all of this. And with that, we are done. I can run this now, and we get the same result. So this is working just fine. And that is essentially it. Now with that, we can do an exercise. And for the exercise, I want to stick with the same data we have used earlier. This one here. We have inventory names, inventory numbers, and I already used zip to zip these two together. Meaning now, let me comment out all of this. I want to print my combined list, run this one now, and we have a list with tuples inside, and inside of each tuple, we have the name of the item and the amount of how much we have of that item. And I want you guys to do two operations actually. Number one is sort this list by inventory numbers. For this list, the first item should be this 12 here with wheels. Next up should be 23 with screwdrivers and so on. And number two, sort this list by length of the inventory name. This means that the longer the word gets, the later it should be in the list. I guess wood should be first and screwdrivers should be last. We are looking at the length of each string here. And well, pause the video now and try this one yourself. Let's start. Let me call the first one sorted comp by numbers. In here, I want to have the sorted function, and inside of list, I have to first of all pass my combined list. Now I have to specify a key. And for this one, I want to have a lambda function. Let me use a num here as the parameter name. Since the argument we are expecting is some kind of tuple, let's call this one the inventory tuple. All we want to do with this one is to get the inventory tuple, and get the item with index number 1. We should be done. Let me print the sorted comp by num, and there we go. The first tuple is now with 12, then 23, 43, 43, 95, and 421. This is working just fine. So next one, we get the sorted comprehension by name. Once again, we are going to need sorted. I want the combined list. And now we have to specify a key. I guess here again, we are still going to get the inventory tuple. Inside of this, we still want to look at the inventory tuple, but now we want to have the index 0 because we want to look at the strings. And we don't want to return the strings, we want to return the length of the string. Meaning we want to have the length function, and then the result of that is going to get returned. I can now print the sorted comp name, and we get the first item is wood. There are 4 letters in here. Then we have screws. This is 6 characters. Wheels is also 6, and metal parts is definitely more than 6. Meaning this seems to be working just fine. And with that, we have the sorted function. But there are 2 more functions like it that I would like to cover. For this part, we are going to look at 2 more functions that take functions as arguments. Besides sorted, we also have map and filter, at least for basic Python. Now, that being said, you probably are very rarely going to actually use or see them. They have basically been replaced by list comprehension, which is a more elegant way to do all of this. But let's have a look at all of this in practice. Once again, I have an empty Python file, except now I have my list that contains a list with the numbers from 1 to 5. The 2 functions, let's start with map. All that this one really does is it changes values with a function inside of a iterable. Just like with sorted, we have to start by using the map function name. And in here, we need 2 arguments. We need some kind of key, and then we need an iterable. In my case, the iterable is going to be my list. For the key, I want to create some kind of function. And in my case, I want to create a power function. So basically what map does is it cycles through this list, which in our case is going to give us 1, 2, 3, 4, and 5. Every single one of these values will be passed into the power function as an argument. And then whatever the power function returns will be used to create a new list. Instead of sorting it, we are just changing every single value. Map, in a way, is simpler than sorted. I want to create a power function. And this one, again, is going to need some kind of parameter. In my case, I'm going to call it num. And now we have to return what we want this new value to be. In my case, I just want to take the power of this num. And that is all we needed. Now I can print all of this, and let's see what we get. We are getting a map object. Cool, completely useless. But we can convert this to a list, and then we can actually read it. If I run this now, you can see we have taken the power of every single value inside of this original list. 1 remained a 1, but the 2 became a 4, and the 3 became a 9, and so on. We went through this list and we applied this function to every single value. And that is literally all that happened here. Once again, since it's kind of annoying to write a whole function for something so simple, we are usually going to use a lambda function. We need the lambda keyword and now the name of the parameter. In my case, I want to go with num. All I want to return here is num and the power of that. If I run this now, we get the same outcome. If you compare this to list comprehension, it really should look kind of familiar. We're going to talk about this in a bit more detail, but first of all, I want to look at the filter function. And this one filters out values from a condition. For example, let's say in this list here, I only want to get the values that are smaller than 4, 1, 2, and 3. We would need the filter function. And in here, again, we are going to need some kind of key and then an iterable we want to change. The iterable, in my case, is going to be my list. And for the key, I guess we can create another function. Let me call it get below 4. That is not an underscore. And for this function, we are going to need another parameter once again. I'm going to stick with num. I want to check if this number is below 4. So if num is below 4, I want to return true. And if that is not the case, I want to return false. And this is the function I want to pass in here. And this, let me comment out all of the stuff we have seen earlier. Now I can print my filter, and you might already expect what we are going to see. We are getting a filter object, which is useless for us, but we can convert it to a list. And then we can see now we only have values smaller than 4. Essentially, what happened in here is that filter looks for every item inside of this list. We are again looking at 1, 2, 3, 4, and 5. Each of these numbers is going to be passed into this get below 4 as an argument. And depending on what Python gets returned here, this item either stays inside of a list or it gets filtered out. If Python is getting true from this function, the number is going to stay inside of the list. 1, 2, and 3 all have the function returning true. However, 4 and 5 had the function return false. As a consequence, they were filtered out of the list. That is literally all that filter does. I guess, once again, I can duplicate the entire line because we don't have to create a whole function. We can use lambdas for that, which is kind of how this was intended to be used. I want a lambda. In here, I want my number. And in here, I want to run num is smaller than 4. And this works because Python is going to convert all of this into a Boolean value. So if I run all of this now, we are getting the same outcome, except this line here is much easier and shorter than all of this. And with that, we have filter and map. Basically 2 functions you very rarely see nowadays. Why that is, we can actually see from the exercise. What I want you guys to do is to convert both of the power and the filter function, so this one and this one here. Let me uncomment all of this. I want you guys to convert this one and this one to a list comprehension and see how much you remember. Let me copy the 2 functions first, and now I can comment out all of this here so we are not getting confused. The first one is the map function. And for this one, let me do it straight inside of a print statement. In here, I need the square brackets for the list comprehension. And now I want num for num in my list. This is the list we have gotten all the way up here. All we want to do is to get the power of it. And with that, we are actually already done. If I run this now, we are getting the same result. Except, I think it's pretty obvious, this is much easier to read than all of this, which is why map is very rarely used nowadays. If you really wanted to, you could even use a function in here as well, and this would imitate map even more. So there's very rarely a reason nowadays to use map. The main reason why you are still learning it is because some older code examples might use it and you know what they mean. But chances are that you aren't going to use it yourself. All right, now, besides that, we can do the same thing for filter. And let me comment out those 2. For this one, again, I want to have my list comprehension, and I want num for num in my list, which, if I run this, is giving me the entire list. But now I only want this number if the number is smaller than 4. And running this is giving me the exact same result. And again, this is much easier to read than this one here, which again is why filter is very, very rarely used nowadays. In this part, we are going to cover file handling, meaning we are going to open a file and we are going to write into that file, which is surprisingly simple. Python is very capable of opening simple file formats. the one we are going to see in this video, is .txt, which is the simplest form of storing text on Windows computers. Also works on a Mac, they are kind of universal. Besides that, you could also open a picture, and there are a couple of other basic file formats you could be working with, but I'm going to stick to txt. Now, that being said, Python could, at least in theory, open basically any kind of file. Let's say a Blender file, an Excel file, a Word file, a PDF document. Python can open all of them, but most of the time you are going to need external modules to do that. What those are and how to use them, we're going to cover later in this series. I guess as a good example here, for some self-promotion, a while back I made a video on how to create a snake game in Excel using Python. Totally doable, kind of fun, although very strange. But anyway, let's have a look at all of this in code. Before we start coding, I want to look at my folder. This one is looking like this. Let me extend it a tiny bit. Inside of the code, I have the Python file itself, and I have a txt file called test. If I open this one, I am getting a simple txt file with a bit of text inside. Nothing complicated, but well, we don't want to overcomplicate things. This is the file I want to open, and this is also the file I want to write in. Keep in mind here, both the Python file and the text file are in the same folder. That is important. To open it, you have two ways. You could either open and close it manually. This means I want to create a new variable, let me call it file, and the function you're looking for here is called open. And this open wants a file path and the name of the file. In my case, this is going to be test.txt. Let me actually print what we get. So I want to print the file. We are, once again, get some random thing that we can't read, but this we could convert to a list. And now we have the document as a list with all of the text inside. Notice here at the end of each line, we have a line break, the one we have seen all the way at the beginning. This way the document knows where to end one line. The one thing you want to be aware of right now is that we only need the file name because both files are in the same folder. If that wasn't the case, you would have to specify in what folder you are. For example, if the text was inside of a folder, you would need folder, then a slash, and then the name of the file. And if you want to go up one folder, you would need 2 dots. And that's basically it. This way, you can create file paths and find specific documents you want to open. Besides that, there's one more thing that you do want to keep in mind. And that is, we have to close the file again. If we had a longer code example and kept it like this, we would keep this file in memory, which wouldn't be necessary. To do that, you would need file.close. If you run this again now, you are not going to see any difference. But this line removes the file out of the memory, which is more efficient. And with that, you can open and close a file. That being said, this approach isn't really used that often. Because the better way is, let me call it open and close it automatically. The way you would most of the time import a file is with the with statement. In here, we need with open and then the file name. This is still going to be test.txt. And now you have to write s and give this a name. In my case, I am going to go with file. What happened here is basically the same that we have done up here. We opened a file just like we have done here. And this file we are storing in a variable called file. The same thing we have done up here. The difference now is we have to write some indented code in here. And as soon as this indentation is over, then we are closing the file automatically. That way we are not going to need this line here. This is also more deliberate and possibly easier to read. It's basically up to you. Both approaches are fine, but this is the one you are going to see more often. In here, we could, for example, print, and let me use the same line, I want to print the list of my file. And we get exactly the same outcome. Let me comment out the earlier part because this is the one I want to work with the most. Now, Python has a few functions that you can use to read documents, especially TXT files. The one you're probably going to use the most is file.read. Don't forget the brackets. If you're calling this, you get a proper output from all of the stuff. Read basically converts this into something that you can work with more easily. Although, keep in mind, this read is going to return, if I use the type function, it is going to give me a string, which means if I convert all of this to a list, I would get a whole bunch of individual characters that don't help me that much. The way you want to use this read function is just to get an overview of what you have. It's kind of difficult to cycle through this. But for that, you could use something like for line, and then I want the list of the file, and now I can print the line. And I want to comment out this part here, and now I get basically the same thing. Since I'm not going to use this too much, I'm going to keep it short, but this is kind of all you need to know about it. If you had other kind of data, you could work more with this, but that's beyond this video. What is not beyond this video is write some file. Let me comment all of this out. And to write a file, we again need with open. And in here, I again want to open my document. But now I have to specify another argument. And this has to be a string. Most of the time, this could be R, it could be A, or it could be W. R stands for read, A stands for append, and W stands for write. The default one is R, meaning we are just going to read the document. But the one that we could also use is A for append. And now I want to keep this as a file. And in here now, I could use file.write. As an argument in here, I can now write some more text. And just to make it a bit more visible, let me add a whole bunch of X's so we know what we're doing. If I run the code now, we cannot see any kind of difference. That being said, if I now open the folder again, open the document, we can now see the end, the one we already had, and then write some more text with X's around it. The kind of annoying thing here is at the end, we don't have a line break. This one you would get by adding a line break character manually. And now if I run this again and open the folder with the document, we now have all of this on a whole new line. And you do want to be careful here because this A means append. If you write W, you're going to write a whole new file with this content here. Let me run it. If I open the folder again, test file is still there, but if I open it, we only have write some text with a line break on the first line. The reason here is that this W tells Python to create a whole new file. If there already is a file, Python is going to write over it. And this you could also use to create new files. For example, if I renamed this test to new file, that is terrible spelling. If I run this now with proper spelling and open the folder, we now have new file. Python has created a text document. And that is basically all you need to get started with reading and writing into text files. Let's do an exercise. I want you guys to create a new text file and draw a tree in it. Kind of like the tree we have seen all the way at the beginning of this entire series. So pause the video now and try to figure this one out yourself. I, first of all, want to comment out all the stuff I had earlier. And now I want with open, and let me call this tree.txt. For this one to work, I need W as an argument. And I want to call this one as, let me call it the tree file. Inside of here, let me save the tree inside of a string. And this I want to do with the triple quotation marks that are going to be assigned to the tree string. I have to work with white space and axis to create a tree. So 3 axis, I hope I can still get it just right. Something like this should be good. And I realized I have 1 quotation mark too much. Now that I have that, I want to have my tree file and I want to write in it. What I want to write is the tree string. Now I can run this. We don't have an error, that's a good start. And if I open my folder once again, we now have a tree file, and inside of that, we have a tree. Although I messed up here a tiny bit. I think if I put this X on the next line, run this again, and open my folder, run this now, and there we go. Now we have a tree or an arrow, but you get the idea. And all right, with that, we have file writing and file opening. For this part, we are going to look at deleting stuff, which is something you can do, but you rarely need to. Let's talk about it. The way you can delete something in Python is with the del keyword. This one here. All you have to do is specify what you want to delete and Python gets rid of it. This would even work with variables. If you delete them, they are going to be gone. Thing is, you basically never need it that way. It hardly ever happens that you absolutely have to get rid of a variable. Instead, most of the time, you only need to delete values from a list. And this is what I am going to focus on for this part. Let's have a look at it. I want to start by just creating a basic variable. Let me call it a and give it a value of 1. Inside of my Python file, I want to create one variable. Let me call it a. It really doesn't matter because we are going to delete a. If I print a now, Python is going to be unhappy because a is not defined, which is Python's way of saying a does not exist, which makes sense because we just deleted a. That's kind of all you need here. The thing is, this kind of operation you basically never do. There just isn't a need for it. Although, if you are going to learn other languages, they are much more aggressive about clearing memory after you used something. So you might see something there. But in Python, all you ever really are going to do is remove items from a list. I guess let me reuse a, and I want to assign it 1, 2, and 3. And I want to delete individual values from this one. Here, delete is where you are going to see it the most. It removes an item by index. So for example, I could write delete a and then the index 1. If I now print a, we are getting an error message because up here we still have the problem. If I comment this one out, run this again, we now can see 1 and 3. The reason we can't see 2 anymore is because we deleted the item with the index 1. Inside of a, we have index 0, index 1, and index 2. And we have told Python to delete the one with the index 1. That's all that happened here. What you could also do, let me comment this one out. You can remove an item by value, and this should be a comment. So let's say in this list, you want to get rid of any value that has a 3, but you don't know what index that 3 is on. For that, Python, or well, a list, has the remove method. All you need is a.remove and then specify what you want to get rid of. In my case, a 3. If I now print the list, we only get 1 and 2, the 3 has disappeared. Besides that, let me comment this one out. You can also use the pop method. What this one does is it removes an item again by index, although the default value here is -1. After I have run this, I can print my list again, and we again get rid of the 3 all the way at the end. The difference between pop and remove is that pop pops out the value we have deleted, meaning we could print this one as well. So if I run all of this, I get free, the value that was deleted, and then the list itself with this line here. And finally, you can just clear the entire list. And this I think we have actually already seen. All you need is a.clear, and if you then print the list, it is going to be empty. Most of the time, this is kind of overkill, but well, it is something you can do. And with that, you have a couple of operations to get values out of a list, or well, remove items from a list. In this tutorial, we talk about objects and classes. And well, more specifically, I will talk about what objects and classes are. I will cover how to create and use them. We will cover Dunder methods and also simple and complex inheritance. And finally, I will cover how to use classes in practice. And well, let's get started by talking about what objects are in the first place. And well, an object is just a container for variables and functions. For example, we could make a video game with lots of monsters. And I think video games are a really good way to explain objects. So I will stick with that for this entire video. But basically, for the monster we are going to create, we want to have variables and functions. And in this case, I want the monster to have some health, some energy, stamina, and damage. And you could add whatever else you want in here. It's really up to you. And then besides that, the monster should also be able to attack, to move, to animate. And again, you could add whatever else you want in here. And what you have to understand here is that these variables and functions only exist inside of this monster object. It's very similar compared to the local scope of a function. If we tried to get this health outside of the container, it wouldn't exist because this health exists only inside of monster object. Although in terms of naming, there's one minor complication, and that is special names. All that really means is that variables inside of an object are called attributes and functions in an object are called methods. And that is more or less the only difference. The only reason why this exists is so that we are a bit more specific with our language. For example, when you talk about health with somebody else for your game, you really want to emphasize that you don't talk about a global variable, you talk about the specific attribute of one object. And one more thing, methods should actually be familiar to you because you are using methods very, very often in Python anyway. For example, when you call the upper method on any kind of string, you are turning every letter inside of that string to an uppercase letter. And that is also a method. And that is the same kind of method we are seeing here. Essentially, a string in Python is just another object with functions inside of it, or methods to be more specific. This also applies to integers, floating point numbers, Booleans, all of that stuff is basically just other kinds of objects that Python creates. But that's something we don't have to worry about for now. Now, another thing that is really important to understand is that it is possible to have multiple objects. For example, I could create 3 different monsters. And each of these monsters could have customized attributes. These red pieces of text here. So my first monster has 90 health, 20 energy, the next monster has 60 and 40, and the final monster has 40 and 10. So when you create an object, you can give it custom attributes. However, this does not apply to methods. And as you can see here, monster 1, monster 2, and monster 3 all have the same methods. And these can be customized to an extent, but not nearly as much as the attributes. That's something you do want to keep in mind. But still, each object has its own attributes and methods. Meaning that this attack here and this attack are not the same function, or well, the same method. They always apply to their respective object. And what you can also do is have objects interact with each other. For example, if monster 3 attacks monster 2, we could run some code to reduce the health of monster 2 from 60 to, let's say, 20. And that actually brings us to a really important topic, and that is object-oriented programming, or OOP in short. And all that really means is that you are organizing your code via different objects. And then you make these objects interact with each other. And this approach is basically how almost all large projects are made in any programming language, or at the very least, any modern programming language. Meaning, if you don't understand classes, you will be very much lost and, well, you will have no idea what you see when you look at larger examples of code. Here we have a couple more objects. We still have monster1 and monster2, but now we also have a player, we have an obstacle, and we have a menu. And all of these have slightly different attributes and slightly different methods. And just to talk about how these different objects can interact with each other. The one we have already seen is that monster2 could, for example, attack monster1, and then monster1's health would be reduced from 90 to 60. And if monster2 is attacking, it might reduce its own energy from 40 to 20. So attacking isn't free for the monster. What we can also do is have an object without any methods, like the obstacle here. And all the obstacle is, well, an object with a position and a size. And this we could use, for example, with the move method of any of the other classes. So the player and the monsters all have a move method, and this could interact with the obstacle. And let me clean this up. Something even more interesting. If you look at the player, this one here, and the menu, those two do look very much connected, because the player has one method called menu. And what this one would do is to create, or at the very least open, a menu. And then when we create the menu, we are passing in the player itself. So this player here is going to be passed in as one attribute of the menu object. And this is totally fine to do. You can totally add a function or an object inside of another object as an attribute. And then this select could, for example, change the weapon of the player. And we could close the menu as well. And I hope this makes sense. The main thing you have to understand is that objects can interact with each other. And this is how you want to organize code. It makes it very easy to work with, and especially for larger bits of code, this approach is essentially mandatory. Or at the very least, it's the easiest way to organize it. And let's actually do a practical example. Here is a Zelda-like game that I made a while ago. And basically everything you see on the screen is an object. For example, right in the middle, we have the player, and that's one object. Then we also have this raccoon here and this spirit, and each of those are one object. And beyond that, each of these flames here is its own object. And these are only created when the player is attacking with some magic. And finally, in the top left, the bottom left, and the bottom right, you can see some UI elements, and they are all part of the same object. And this object is very much related to the player, so those two work together very closely. And besides that, each of these pillars and trees and rocks and statues, they are all objects that I created just for this game. So I hope that illustrates how useful objects are. They make it really easy to group together code chunks that should belong together. And for a bit more detail, the raccoon, for example, has 3 attributes: health, speed, and damage, and the methods attack and move. And all the other objects would have similar attributes and methods. And with that, we have objects. Now, the next question is, what are classes? And this is fairly easy to explain as well. The class is basically a blueprint for an object, meaning whenever we create an object, we first have to create a class. And a class can also accept arguments to customize the object we are creating. For example, this would be a class. We have a class, and this class has 2 attributes, health and energy. and right now the value for both of these is not being set. This we do when we actually use this class to create an object. But this class also has two methods, attack and move, and those do not change. And basically what we're doing is use this class to create the object, and in the process we are giving it the specific values for health and energy. So in this case the monster is going to have 90 health and 20 energy. And this process we could do as many times as we want. For example, earlier you have seen monster 1, we had monster 2, monster 3, and we could continue with monster 4, 5, up to an unlimited number of monsters. And that is essentially the main idea. All you really have to understand is that we always need a class to create an object. Now, what we can also do with classes is that one class can inherit from another class, and the resulting objects will have attributes and methods from both classes. For example, let's say we want to create a shark class, and this one right now only has speed for the attribute and bite for the method. And this class would be fairly limited because we, well, don't have any attribute for health or for energy, and we also don't have any kind of method for move or attack. But we don't need to, because what we can do is have this shark class inherit from the monster class. And this means this shark is going to get the health and the energy from the monster parent class, and it is also going to get the attack and the move from this class as well. Meaning when we actually use the shark class to create a shark object, we are going to get health, energy, and speed for the attributes and attack, move, and bite for the methods. And I think I should use better colors here. In the shark class, health and energy are coming from the monster class. Same with attack and move. Those two are coming from the monster class. And then speed and bite are from the shark class. And this would allow us to reuse code quite extensively. For example, we could have a lot of different monsters. We could have a shark, some flying enemies, some armored enemies, lots more, and they all inherit from this one monster class. And with this approach, we would save a ton of writing in terms of code. And on top of that, if we change the move method, for example, it would affect every single other class as well, which is very useful if you want to make some changes and make it affect every single other class. And especially with larger projects, this is just about the only way to manage them. And let's do an example again. Here is the screenshot from earlier. And we have a monster class, we have another monster class, and those two have the same attributes and methods, although with different values. And besides that, we also have the player. And what is really important to understand here is that all of these inherit from the entity parent class. And this, for example, contains the method for movement, because all of the monsters and the player move in the same way. So they could share this method quite easily. And just to emphasize it, I do want to go over the advantages of classes and objects. And the first point here is that classes and objects help you organize complex code. And the second point is related. Classes and objects also help you to create reusable code. And just from these 2 points, I hope it becomes obvious that if you want to create some really large project, let's say a really good looking game, you need objects and classes. Without them, it's still possible, but significantly more difficult. Besides that, classes are also used everywhere. Meaning, if you don't understand them, you will be very much lost. As a matter of fact, in Python, there are quite a few modules that require you to use classes. For example, Pygame, tkinter, and matplotlib, respectively the module you use for games, for GUIs, and for data analysis, they all work with classes primarily. So if you don't know how to use it, you pretty much cannot use these modules. or at least you could only use a very small part of them. And there's one more point that I haven't mentioned yet, and that is that classes make it much easier to work with scope. I will talk about this in more detail later, but if you struggled so far with getting information in and outside of functions, you will really like classes that make it very easy to work with different levels of scope. So these are the arguments why you would want to use classes and objects. However, you can write code without using objects at all, and this is very common, especially for beginners. And let me illustrate the problem here. The yellow line is the need for classes. And especially when you start writing code. Let's say you are somewhere here, and your average program is something like 50 lines of code. In this case, there really isn't any need for classes because, well, your code is very simple and there isn't any need to organize complexity. However, the longer and more complex your code is becoming, the more you will need classes. And this ramps up really, really fast. But as long as you are in this area here, it, well, is very tempting to never use a class and ignore them entirely. And this, especially as a beginner, you really want to avoid. So even though when you are here, I would really recommend you to use classes, even though it's not strictly necessary in your example, just to practice for more complex code. Because when you are an actual software developer, you are never going to write just 50 lines of code. Most of the programs you are going to work are somewhere here with a few thousand lines of code, let's say 2000. And if you are up here and you don't use classes, you are going to be in a lot of trouble. But all right, with that, we have the theory of objects and classes. And for the next part, we are actually going to create and use objects. So let's have a look at some code. Here I have a completely empty sheet of code. And the first thing I want to do is to create a class. And this you do with class and then the name of the class. In my case, I want to go with monster. And here already we have to cover something important. And that is the naming scheme. So far in Python, what you probably have written is something like monster. And generally, you always used the snake case styling for any kind of text. So why is this different here? And well, in Python, by convention, class names are always written in the camel case. So camel case looks like this, where you don't have any spaces between words, or well, any underscores, but any word starts with an uppercase letter. And this is different from normal Python, where variables are written in snake case, where everything is lowercase and a space is an underscore. And this isn't strictly necessary. You can call a class monster with a lowercase m just fine. This is purely convention. But all the other Python requirements for naming still apply. For example, a class couldn't start with a number. And we also couldn't have a space in between. So we don't have to learn any new naming scheme. Now, next up, what you have to do is a colon. And now in here, we can work on the attributes and methods of our class. And for now, I just want to create some basic attributes. Let's say I want to give this monster some health. And for now, I want to have specific numbers. Let's say 90. I want to have energy. And this one should be 40. So now we have a class. And what we have to do now is turn this class into an object. And this we do by typing the name of the class and then calling it by using brackets. Again, very similar compared to functions. And this is going to return the object. So we have to capture that in a variable. And this very often is written like this. And here I hope you can see why we have the different naming schemes. To Python, this name here and this name here are two completely different things, because one starts with a lowercase, the other with an uppercase. Although to us as the programmer, we can tell that those two are related because they basically have the same name. And for that reason, we are usually writing class names in camel case and variable names in snake case. it makes it very easy to connect these two and clearly indicate that they are connected. Although you don't have to do any of this. You could totally call this, I don't know, hamster, and this could be lowercase. It's totally fine. All of this is just convention. Although you should follow conventions, they are there for a reason. But I can run the code now, and I am not getting an error. That's a good sign. And now what I can do, I can use print and monster dot, let's say, health. And now if I run this, we are getting 90. And this 90 here is coming from this health. And the same would also work for energy in just the same way. So we get 90 and 40. Now, just to emphasize that both this health and this energy only exist inside of this class, let me print health by itself. That is horrible spelling, health. And if I run this, Python is going to give me an error. And we have name health is not defined. Meaning Python cannot find this health anywhere in the global scope. Which makes sense because there is no health in the global scope. We only have health in the scope of this monster class. And let me add some comments here to make this a bit more readable. We have attributes, and besides that, I also want to create methods. And those work kind of like functions. We again need the define keyword, or def. And now we need a name for our function. And for that, we have the exact same naming scheme for normal functions. For example, attack would be a perfectly fine name. And after that, you need a colon. And then, let's say for this attack method, I want to keep it simple and just print the monster has attacked. And now I can call monster.attack, and don't forget the brackets. And now if I run this, we are getting an error. And this error says that monster.attack takes 0 positional arguments, but 1 was given. And this is probably very confusing, because when we called this method here, we didn't pass anything inside of it. And the method itself doesn't have any parameters. So why is Python being so weird here? Now, the reason why this is happening is that whenever we call a method, so a function inside of a class, what is going to happen is that Python automatically passes a reference to the object created by the class as the first argument into the method. And this first argument we always have to capture with some kind of parameter. Meaning a method always needs at the very least one parameter. For example, I could just write monster in here. And if I run this now, we get the monster has attacked. And let me just print what we actually get. So I want to print the monster we get as an argument in here. And what we get is main monster object at somewhere in our memory. And well, in my case, I don't really care about this monster, so let me remove the print statement, but I do have to keep this first parameter. However, once we have the first parameter, I can add as many custom parameters as I want. For example, I could add the amount of damage here. And I could, let's say, print the amount with an F string. And I want to say the amount of damage was dealt. And now when I call this method down here, I can pass in any number I want. And I get the monster has attacked, 40 of damage was dealt. That does not make sense in terms of grammar. Let's try this again. 40 damage was dealt. That feels much better. What is really important to understand here is that this monster, or more specifically, the first parameter of any method, always references the object created by the class. So this class up here creates an object, and then this monster is a reference to that object. The monster is not a reference to the class itself. And this is really important because that way you can create multiple objects that always work with the first parameter here. For example, I could have monster1 that I'm creating from the same class and now call monster1.attack, let's say with 10 in here. And now the first argument passed in here and the first argument passed in here are different. Essentially, we are passing this monster in here and this monster1 in here. That way, this first parameter is really flexible. It can target any kind of object, or more specifically, any kind of object you are using it with. I don't want to do this one right now, but what you could also do, if I add another line here, you could, for example, print monster.energy. This, once again, would target this first parameter, and then this first parameter targets the object itself, which in this case is going to give me the energy here, the one I've just drawn over. But if I run this, we are getting 40. The 40 we have seen from here. And this right now is created in a class, but later on, when we use this class to create an object, every single object would have this energy attribute. And this is what we are referencing here. And what you could also do is increase this amount. So monster.energy minus equal 20. And if I print it now, we get 20. And I hope you can tell how useful this can be. Because if you imagine that this monster here is the global scope, and these attributes are global variables. If this attack was just a normal function, then this would not work. Because you would be creating a local variable that wouldn't work with the global ones. But because of this first argument that the method always gets, we can influence variables, or well, attributes outside of this function, which is incredibly useful. So I hope this kind of method here makes sense. As a matter of fact, let's practice this one. I want you guys to create another method for this monster, and this one should be called move. And it should accept one parameter besides the reference to itself. And that is the speed of the movement. And then inside of the method, you should just print that the monster has moved at a certain speed. Doesn't really matter what you put in here as long as it is working. So try to figure this one out yourself. All right, let's try it together now. I want to create a method called move. And in here, I want to have speed as a parameter. However, what we have learned from the attack method is that we always need a reference to the object as the first parameter. Meaning, the first parameter here should be something for the monster. And it really doesn't matter what you call it. So I could even write something in here, it would still work. And now in here, I can print the monster has moved. And let me add another line with an F string that says it has a speed of, and then the speed. And let me fix the typo. And now I can call monster.move and add, let's say, 10 in here. And let me comment out monster.attack. And let's see what we get. The monster has moved. It has a speed of 10. So all of this seems to be working very nicely. Now, obviously, calling this first parameter something is a bit confusing. And as a consequence, in Python, there is a convention that this first parameter is always called self. And this applies to all of the methods. Meaning this is what you are going to see most of the time and what I am going to use as well. You don't have to do it, but I think it makes the most sense. Although I do want to emphasize that this parameter here and this parameter here have no relation whatsoever. They are entirely separate. But it is totally fine to call self here and self here. The names are not in conflict with each other. And all right, with that, we have the very basics of using classes and objects. Although right now we do have a problem that our monster always has the same health and the same energy. So even if we created multiple monsters, so what I could be doing is monster 1, monster 2, monster 3, and let me get rid of this one here. All of these monsters would have the same amount of health and the same amount of energy. And they all have the same attack and move method, which is fine to an extent, but I do want them to have different amounts of health and different amounts of energy. And to implement that, we need another concept, and that is called Dunder methods. So let's talk about that one. And the Dunder here just stands for double underscore, meaning we are talking about a double underscore at the beginning and at the end of the method. But it's important here, we are still talking just about methods. So essentially, we are calling a specific kind of function. And let's talk about why it's special. A Dunder method is just another method. The thing that makes it special is that it is not called by the user. Instead, it is called by Python when something else is happening. For example, there is the Dunder init method, and this one is called when the object is being created. Another example is the len method, and this one is called when the object is passed into the len function. And besides that, we also have Dunder apps, and this one is called when we are passing the object into the apps function. And that is really the entire idea. It honestly isn't that complicated. The most important Dunder method you have to understand is Dunder init. This one you are going to be calling all the time. But let's actually do all of this in code. That should make the most sense. All right, here we have the class I created earlier. And what we have seen earlier as well, I can create monster1, and that is just going to be the monster. And I can also have monster2. And if I now print monster1.health and monster2.health, we get the same number because we always set health to 90. There's no way to customize it. And basically what I want to do is as soon as the class is being created, then I want to create these different attributes. And instead, what I want to do is when this class is being created, I want to create this health and this energy with custom values. And for that to work, we need to define a Dunder method. And the one we need is called Dunder init. And this is just going to be another method. Like attack and move, we are just calling a method, meaning the first parameter here has to be a reference to the class itself. And for now, let me just print the monster was created. And do pay attention, I am never calling the init method myself. But if I run this, we get the monster was created, and then 90 and 90. And what that means, if I minimize this a bit, every time we are creating a monster, so first here, and then here, then we are calling this Dunder method. And this Dunder method, we can also give some parameters. For example, we could specify in here the amount of health and the amount of energy we want. And, well, I hope you can see where this is going. Basically, what we can do now is we can set self.health to whatever health parameter we pass in, and we can do the same thing for energy. And the names here might be a bit confusing, so let me add a bit of white space and explain. This self.health here is referring to this self.health of the monster class, whereas this health here refers to this parameter. And the important point here is self, because this one specifies where health belongs to. I hope this makes sense. This is something you see fairly often. Let me remove the white space again. And now when I am calling the monster, I can either pass in arguments or named arguments. Let's say for the first monster, I want health 10 and energy 20. And for the second monster, I could specify health being 50 and energy being 100. Now, if I run all of this, we get monster1 health is 10 and monster2 health is 50. And this 10 here refers to this 10, and this 50 is referring to this 50 here. Meaning now we can have custom attributes. And what is even better, since this self is a reference to the class itself, we can just create the attribute in here, which means we don't need those lines at all. It would still work without them. If I run this now, this is still working just fine. And this is what you see most of the time, where the class by itself doesn't have any attributes. We only create attributes when we are creating the class with the init method or the Dunder init method. And then inside of the other methods, we are calling self all the time to refer to the class. And I just realized this should be self instead of monster. So we're capturing this self here. And what you are going to notice is that you are going to write self all the time. It is a little bit annoying, but well, it is manageable. And well, with that, we have the first init method. But there are quite a few more, although those you wouldn't use that often. And just to keep things simple, let me get rid of monster2, and I don't want to print anything at all. Another Dunder method I talked about in the introduction is len. And this one needs self and no other parameters. And in here, we just want to return something. Let me return the number 5. And what this one is going to do is if I call len and pass in monster1 in there. And this len, just as a quick recap, if I pass in any kind of string into len, let's say test, and if I print the result, I get 4 or the number of characters inside of the string. I guess I could also pass a list in here. That might make a bit more sense. So I have a list with 5 entries and the length of it is 5. But what I can do now, if my monster has a len method, I can pass monster1 in here and it would return 5 as well. And any number that is being returned here is going to be passed into the len function. And I guess for something slightly more relevant, instead of returning a number, I could return self.health. And now if I run this, I'm getting 10, or the amount of health my character has, which is 10 right now. And another example we have seen in the introduction that works in the same way is ABS, and we need Dunder on both sides, and in here self. And again, I have to return something. So return, and for this case, let's say self.energy. And if I copy this and pass it into absolute, I get 20. Now, usually absolute is if you have a negative number and you want to make sure it's always positive. That's what it does. But well, you could theoretically do whatever you want with it. Now, what you can also do is one specific function in Python, and that is called dir, short for directory, I think, or directory listing or something like that. Basically what it does, you pass in an object and then you want to print the result. And what you get from that is all of the Dunder methods and at the end, the attributes and the normal methods. And in here, you can see a lot of stuff actually. And what you have to understand here is every time we are creating an object, Python already gives it some Dunder methods. For example, here we can see the dir method. And this one is necessary for the dir function to work. It kind of works like the len method, the one we have created ourselves, or the ABS function. And I guess the one we have just created is the init method. This is the really important one. And most of those you really don't want to worry about because, well, they're just there to make the class work, but we don't really have to worry about them. Although some Dunder methods in here can be very useful. For example, Dunder dict is, well, it's kind of a dictionary, but not in the way you would expect. Basically, how you would use that one. Let me print it right after the monster. I want to print monster1 and then dot dunder dict. And in here, this is the one exception where this is not a method, this is just an attribute. So no brackets afterwards. And this one gives us all of the attributes of the method inside of one dictionary. Can be quite useful sometimes, although you wouldn't be using it too often. Now, another way to get to this dict here is to, let me duplicate the entire line. You can call the vars function and pass in monster1. And this one is giving us the very same thing. Although I have hardly ever used either of these, most of the time you just don't need them. And with that, you should understand Dunder methods reasonably well. Now, there are quite a few Dunder methods that get a bit more advanced. I only covered the really fundamental one. Some other examples of Dunder methods is, for example, Dunder call. And in here, we only need one parameter, self. And in here, we can return something else again. And this should be Dunder on both sides. Let's say the monster was called. And what this Dunder call does is it essentially turns our object into a function. Meaning I can call monster1 and then add brackets afterwards. And if I do that, we are not getting anything because I would have to print what I get. So I have to put brackets around it and call print. And now the monster was called. I guess a cleaner way of doing this is to return nothing and just print this string. So now if I call monster1, we get the monster was called and nothing is being returned. And when you create a function in Python, it basically behind the scenes creates an object with this Dunder method here. And this we can just create ourselves. It really isn't that complicated. And what we can also do is to add and subtract numbers. And this you would, for example, do with Dunder add. And in here, you need two parameters. First of all, self as always, and then you need some other number. And what you can do in here is return something. Let's say I want to self.health and then plus whatever other number I get. And now that I have that, I can print monster1 plus 10. And if I run it, I get 20, which is, if I find it, so the health of my monster is 10, and I add 10 towards it, so I get 20. And I guess to make this a bit more understandable, let's add 55 in here. And I get 65, which is 10 plus 55. And well, that is a couple more Dunder methods. They can be incredibly useful, although most of the time you are only going to use Dunder init. This is the one you absolutely have to understand. But I guess they don't really get that much more complicated, so it shouldn't be too hard. All right, now for the challenge for this part, I want you guys to do some research because there's another Dunder method that is called str. And I want you guys to look up online what it does and how to use it in code. All right, here we are in the official Python documentation. And there you can see Dunder string or Dunder str. And basically what it does, it's called by the str object, built in function format and print to compute the informal or nicely printable string presentation of the object. Basically what it means is that this object is going to return some text. So let's have a look at it. Here we are back in the code, and I only need one parameter, and that is self. And now I have to return some kind of string. And the string I want for this one, let's say a monster. And what I can do with that, let me get rid of this print statement, and instead I want to print str for monster1. And this is going to return a monster. And we don't even need this str because print is trying to find a string. So let me duplicate this line and remove the str and just have monster1. If I call this now, I still get a monster. And this can be a really nice way to look at your objects and see what they are doing. Because if we didn't have this Dunder method, let me comment it out and run this again, all we get is a monster object, which really isn't that useful. And obviously, this str can return a lot more than just a simple string. For example, we could have an f string with health that says self.health and energy that says self.energy. And now if I run this, we get quite a bit of information by just passing the monster or the object into the print statement. So this str can be really, really useful. And with that, we have covered quite a few Dunder methods. If you look online, you can find even more, but well, most of the time you're not going to need them. This is very often a fairly advanced topic. Except Dunder init, this is the one you are going to use a lot. But alright, with that, we have Dunder init methods covered. And if you understand all of this so far, you can actually understand Python itself quite a bit more. Let's talk about this one in the next part. And the one thing I think that confuses beginners quite a bit is that every single thing in Python is an object. Meaning every time you see a string or integers, you are going to see an object. Just like the objects that we have created, so our monster. And this even includes functions, which are just objects with the call Dunder method. And I'm going to show you some examples in just a second, but most of what I will cover here isn't really important. I just want you guys to understand how it works, so you don't get confused later on. And there's another thing that I believe is very often confusing, and that is the difference between a function and a method. And the reason why this is confusing is both just execute a block of code. So in terms of functionality, they basically do the same thing. However, the difference is that a method always belongs to an object. It doesn't matter if the object was created by us or by Python. And a good example here would be using a string. So if we have a function, this would be len, for example, and we can pass a string into it, this would return 4. And a method would be something with dot, and then upper, for example, for a string, returns uppercase letters for this string. And that really is the entire difference. That's the main thing you have to understand. And it doesn't matter if we create the method ourselves or the function ourselves or if it's created by Python. And the reason why these are different, for example, is that the len method could work for lots of other things as well. For example, you could pass in a list in here, you could pass in a dictionary or a tuple. It would still work with different data types. Whereas upper only works for strings. You couldn't add a list with upper, that one would not work. So it makes sense in this case that upper only exists as a method for strings, whereas len should be a function, so you can pass in different kinds of objects in here and they would all work. You could perfectly fine create some kind of len method for test and it would work just fine. Although then you would also have to create a len method for lists, for dictionaries, for tuples, for all of that stuff, and it would be quite labor intensive. So all we're doing here is to keep things more efficient. But alright, let's have a look at some code and let's have a small deep dive into Python. Here I have a completely empty sheet of code. And what I want to create for now is create a test variable. And this one should have a string, let's call it A, doesn't really matter what it is. And what I can do now, I can call my print dir and pass in my test in here. And if I run this now, I am getting a bunch of Dunder methods, and after they are over, starting from here, I get a couple of methods and attributes. Now the dir method doesn't separate between methods and attributes, so we just get one big list. But, well, basically what we get here is an object. And anything in here you could just call, like upper or title or strip. All of these are very simple methods. And along with that, we have the len Dunder method, and this is what's being called when we are passing this string into the len function. And besides that, what you can also do, let me get rid of this test and instead create define test, and in here let me just add pass. So this is a function with the name test, and I'm still printing dir test. So if I run this, I am getting another object. And this object is special because it has a call Dunder method. Meaning when we're adding brackets afterwards, it is being executed. And that's basically what a function is in Python. It's just an object with the Dunder call method. It really isn't much more than that. Although we do have a couple extra things that make this a bit more special, but that's the main idea. And if you really wanted to, you could even store this function inside of a variable. And this works because the function is an object. So this is just going to be an object. Meaning if I now print A, we are getting the same outcome. Although what we can even do now, let's call it another attribute. That is not how you spell that. And this could just be 10. And now if I run this, our function has another attribute. And again, this is working because functions are just objects. Although in practice, you wouldn't really do this, there's no reason for it. But what is much more common is that you are passing functions or methods into other objects. So what is much more common? Let's say, for example, a simple add function. And this one takes A and B and is going to return A plus B. Obviously, this still isn't particularly useful, but I just want to illustrate what it does. And now I can create a class, and let's call it test. And in here, for the Dunder init method, I want to have self, and I want to add an add function. And now inside of this Dunder init add function, I can set an attribute self.add function, and this should be the argument we get from the parameter add function. And now when I create this test, I have to pass in one function, and I want to have this add function here, so I'm going to add it in here. And let me use a named argument so it's a bit easier to see what's happening. And in here, it is really important that you don't add brackets, because we don't want to call this function, we want to get the function itself. So the object of the function, not what's being returned. And if I run this now, this is working just fine. And even better, what I can do, I can call test.add function, and I can pass in, let's say, 1 and 2. And this is not doing anything because we're not printing anything, we're just returning something. So if I put all of this into a print statement, now we are getting 3. And I hope all of this is making sense. This is a really important thing to understand. Right now, this here is creating an object of a function. And this object we can pass around. For example, we could pass it inside of a class, and this would work just fine. And then inside of the class, we can store it inside of an attribute and then call it from outside of the function. This is working just fine. There's no limitations on this. And this is something you really want to practice because passing around functions is a really important thing to understand. And I guess since this is really important, we should practice this with a slightly larger exercise. And let me add some comments that should help quite a bit. First of all, I want you guys to create a monster class with a parameter called func. And this func should be stored as a parameter. That's the first step. After that, I want you guys to create another class. And this one is called attacks. And this has 4 methods. We have, let me put it on another line. We have bite, strike, slash, and kick. And for each method, you just print some text, basically whatever you want. I would recommend to print kick, slash, strike, and bite, but it really doesn't matter. And let me add proper white space here. And then for the final step, I want you guys to create a monster object and give it one of the attack methods from the attack class. And remember here that methods are basically just functions. The only difference is that they are part of an object. So this should work kind of similar compared to what you have seen here. But, well, it's going to be slightly different. So experiment with this and see how far you get. All right, let's try together now. First of all, I want to create a monster class. And this I do with class monster. And in here, I want a Dunder init method that needs self and a func. And this func I want to turn into an attribute, so self.func, and I want to capture the parameter or the argument we get here in there. And this is covering all of this. Next up, we have to create another class. So class, and this one is called attacks. And in here, we don't need a Dunder init method. Instead, I want to define, let's start with bite. And we need self as always. And in here, I just want to print bite. And since we need 4 attack methods, let me copy this a few more times. And now besides bite, I also want strike. Then I want slash. And finally, I want kick. And I think you can already tell why this might be useful. It's a very neat way to organize all of your different functions. If you have a really large game with hundreds of different attack methods, this may actually be really nice to organize all of this. All right, now finally, I want to create an object of my monster. So monster in lowercase, and then here I want to have my monster. And now we have to define a function. Now this you could approach in a couple of different ways. Although there's one way that is definitely wrong, and it's very tempting to go this way. You could write something like attacks and then .byte. And if I run this code, we get a 3, and this 3 comes from up here. So let me comment out all of this. And if I run this again now, we can't see any difference. But if I run monster.func, we are getting that attack.byte is missing one required positional argument, and that is self. And this is a reasonably common error. The reason is that this here is not returning an actual object, it's returning a class. And this is confusing Python. Now, an easy way around this is to actually turn this class into an object by calling it, so adding brackets afterwards. And now if I run this, we are getting byte. And basically what is happening here, think of this in terms of return statements. When we are calling this attacks, it's returning an object. And then inside of this object, we are getting the byte method, which is this byte method here. And if you don't like how this looks, what you could also do is create a separate object. Let's call it attacks. And in here, I could add this attacks and then call attacks.byte, and we will get the same result. And this is something we are going to explore quite a bit more, that you pass different things around different classes. So that in this example, we are taking the byte method and passing it into another object. And this is getting incredibly powerful and really important to understand if you want to understand more complex code. Because a key part of object-oriented programming is that you work with different objects and make them interact with each other. And this example here, so this part down here, is one example to make classes interact with each other. and I would really recommend you to practice this in your own time. It's really going to be helpful. But all right, with that, we have covered a really basic deep dive into Python. Although I do want to practice this a bit more, and there's one important topic I do want to cover, and that is going to be scope in terms of objects and classes. Let's talk about that one in the next section. All right, so let's talk about classes and scope. And this is one of the really powerful parts of objects that make it really easy to work with this scope. But let's talk about it. Basically, every method, so every function inside of a class, has a reference to that class. And because of that, it's really easy to get and change class attributes. And because of that, methods are much easier to work with than normal functions, meaning they rely much less on parameters, the global keyword, and return statements. Although you can still use them if you really want to, and sometimes that does make sense. But you are going to do this much less often. And what is even better, objects can be influenced from outside of the object itself, and even from the local scope of a function. Basically, objects you can change wherever you want. There is no limitation on the scope for them, which makes it even easier to work with them. But I guess let's have a look at all of this in code that should illustrate this the best. Here I have a completely empty sheet of code. And first of all, I want to illustrate the problem. So let's talk about scope again. Let me add a comment, scope problem. And let's say I have a game, and I have some kind of health that right now is 10. And for this health, I want to have a function, let's call it update health, and this one takes an amount, and all it really does is it adds that amount to the health. A super simple function, just about the simplest function you could write. Now, what I want to do, let me say I want to print health, then I want to update my health with 20, and then I want to print my health again. And if I were to run this, what do you think is going to happen? Just think about it. And well, if I print it, we are getting an error. And what Python is unhappy about is that we have a local variable health referenced before assignment. And what is happening here is that this health to Python is a local variable. Let me remove the error messages. They are getting a bit annoying. That's easier to work with. Essentially, this health only exists in the scope of this function here. Or in other words, this health here and this health here to Python are two completely separate things. And then when we are trying to update this health with some amount, Python cannot find any starting amount for this health. As a consequence, we are getting an error. And there are a couple of ways to get around this. For example, we could use global health. That's probably the easiest one, and now this would work. Although you could also use return statements, but it really isn't the cleanest way to work with this. So this is not great. So let me comment it all out, and let's do the same thing with classes. So let me create a class monster again. And in here, I want to create a Dunder init method that needs self, health, and energy. And then, as always, I want to set self.health equal to health, and self.energy is going to be energy. And now let me create an object from this class, and let's give it a health of 100 and energy 50. Doesn't really matter what values you put in here. So now I can print monster.health. And we are getting 100. So this one works just as expected. And now what we can do, we can just get monster.health and add, let's say 20 to it. And if I now print monster.health again, we are getting 120, i.e. the sum of 100 and 20. And what is even more powerful, let me uncomment this function up here. And now instead of the health, I want to get my monster.health and update the amount. And this would still work if you are using an object. So let me get rid of these two lines here and instead call the function update health. And let's say I want to raise this by 20 again. And now if I print monster.health after calling this function, I get 120. Meaning even inside of the local scope of a function, you can still update anything inside of an object. For the simple reason that here Python is very clear about what kind of object you're talking about. This monster is not going to become a variable in the local scope. And this monster could be updated anywhere. It could be in the global scope, it could be in the local scope of a function, it could be in the scope of another method, it could even be inside of the object itself, so this monster. Python just doesn't care, which makes it really easy to work with. So I guess one thing you do see fairly often is inside of a class. You have something like, let's call this one update energy. And then here we need self, and let's add an amount in here as well. And all I really have to do to update this self.energy would be to first target the attribute itself, so self.energy, and then plus equal amount. And now I could just run monster.updateEnergy, pass in anything I want in here, and then print monster.energy, and we are getting 70. And again here, this is a very easy way to work with scope. You don't have to worry about return statements, you don't have to worry about global. All you do is target the attribute and then you set it to a new value or update whatever you want. That's it. It's super easy to work with. Although, if you wanted to, you could use a return statement as well. For example, if I wanted to set energy, and in here I want self and energy, and let's say for this one, I want to create a new local variable that I call new energy, and this is going to be energy times 2. And then I want to return this new energy. And now in my init method, instead of setting energy straight as the attribute, I want to call self.setEnergy and pass in the energy. And now let me comment out this line down here to update the energy and just get the energy. Now we're getting 100, which is this 50 here. This 50 we are passing inside of this energy here. From that energy, we are passing it inside of another method inside of the monster class. And this method is down here. We are getting one parameter, and this we are doubling and assigning it to a new local variable inside of this method. And after that, we are returning the new energy, and this new energy is going to become the attribute self.energy. Kind of a roundabout way of doing it, but it is possible to do. All I really want you to understand is that you can still use return and parameters just like with any other function, although most of the time you don't really need it. A better way for this one would be to remove this part entirely, just call setEnergy, and then self.energy is going to be new energy. This would work in exactly the same way, although it is much cleaner to read. So if I run this, we are still getting 100. And I hope you understand why self is really, really powerful. It essentially bypasses all of the scope issues very efficiently. But all right, let me get rid of all of this because I don't really care about it. And instead, I want to set self.energy back to energy. All right, now with that, let's do an exercise to practice this. And what I want you guys to do, first of all, create a hero class with 2 parameters. One is damage, and the second one is a monster, which is going to be this object here. So this object you want to pass into another class as an argument. Then second of all, the monster class should have a method that lowers the health. And I guess you can call it getDamage, and this one should take an amount. And then this amount you would reduce from the health of the monster. And finally, the hero class should have an attack method that calls the getDamage method from the monster. And let me put this on a second line. And the amount of damage is hero.damage, which is going to be the damage you specified up here, which should be an attribute. So I hope all of this makes sense. Try to implement this yourself and see how far you get. All right, let's try it together now. First of all, I want to create a new class, and this is going to be hero. And the hero needs a Dunder init method. In here we need self, and besides that I want damage and I want a monster. And let me add a bit more white space. There we go. Now I want self.damage to be damage, and I want self.monster to be monster. And let me spell this correctly. There we go. And this would then be step number 1. And for step number 2, let me move it up a bit so it's easier to see what's going on. The monster class should have a method that lowers the health, and this I want to call getDamage. So define get_damage, and then here I need self and I need the amount. And all I really want to do in here is self.health minus equal whatever amount we specify. And this getDamage I want to call from inside of the hero. And this brings us to step number 3. And this, right now, we are still inside of the hero class, which you can see by the indentation. I probably should have actually mentioned that for the class, we always define something by one level of indentation. In here, I want to now create, let's call it an attack method. And this one needs self and nothing else. And all I really want to do in here is get my self.monster. And this self.monster is the monster we specified up here. And on this monster, we want to call getDamage. And all we really have to do for that is call get_damage. And now we have to specify how much damage we want to cause to the monster. And for that, I want to get the damage of the hero. And all we need for that is specify self.damage. And we are done. And if you just read through this, I hope this really illustrates why this makes a ton of sense. It's basically a normal sentence. We want to get the monster, we want to cause the monster some damage, and the amount of damage we want is self.damage, so the damage of the hero. And now with that, all we have to do is to actually create the object of the hero. Meaning I want to create a hero object, and this is going to be hero. And then here we need damage. Let's say damage for the hero is 15. And then we need a monster. And the monster is going to be the monster object we created just a second ago, this one here. And this we're just passing in here. And now let me print monster.health. And if I run this, we are getting 100, which is this 100 here. But now, if I call hero.attack, and this one doesn't need any arguments, and afterwards I can print monster.health again. And now if I run this, we get 85, which is 100 minus 15. This is how this 85 comes about. And to get to this point, to lower the health of the monster, we just had to call one method, and that's it. All we are really doing in here is we are passing different objects around and make them interact with each other. And since we don't really have to worry about scope, this is very easy to implement. And again, this is something you really want to practice on your own and try to work on this more to make sure you understand it. But all right, with that, we have covered scope. And I guess for the next part, let's talk about inheritance. And inheritance really just means that one class gets the attributes and methods from another class or multiple classes. And I have already shown an example earlier. And that was, we had a monster that we have already seen multiple times with health and energy. And this right now is called a parent class. And the reason why it is called a parent class is because there's a child class, and this one was the shark. And this shark by itself only has a speed and a bite method. And what I want to happen is that the health and the energy of the monster parent class comes into the child class, and the same for the method. So attack and move should also be available inside of the shark class. So that when I actually use this to create an object, the shark object has health, energy, and speed for the attributes, and attack, move, and bite. Meaning we are combining the monster and the shark class to create the actual shark object. And the reason why we are doing this is this makes it very easy to reuse code. Let's say this monster here could be the parent class to every monster in our game. And if we have this, we never have to set the attributes health or energy for any other monster. They are always available for every single class because they all inherit from this monster. And obviously, this is still a very simple example. In an actual game, the monster class might have a few hundred, if not thousands of lines of code. And then it really makes sense to reuse code as much as we can, because then we don't have to create new classes all the time with all of these methods that we have to type over and over again. And then on top of that, if we wanted to make changes to how things move in the game, so this method here, if we didn't use inheritance and we wanted to make change how things move in the game, we would have to change possibly hundreds of different move methods for every single monster. But if we use inheritance, we don't have to. If we change one move method, we are changing how every monster in the game moves. So I hope that makes sense. And one important concept here is that the class can inherit from an unlimited number of other classes. This could look like this. In here, we could have a parent class 1, a parent class 2, and a parent class 3. And then the child class would have the attributes and methods of all of these parent classes. And you can also turn this around, where you have a parent class, and this parent class is being inherited from by an unlimited number of other classes. And this would look something like this. You have one parent class, and you have one child class, a second child class, and a third child class. And all three of those would have the methods and attributes of the parent class. And this here, for example, could be the monster class, and then this one here, maybe the shark class, and let's say this one here could be, I don't know, like a bird class or something. Now, there's one thing you do want to be aware of though, and that is that inheritance can get very, very complex, up to a point where it really doesn't become fun to work with them. And this is also the part where beginners really start to struggle because, well, I'm going to show you an example later on, but this can get very, very complex and really hard to work with. Fortunately, this is fairly rare. Most of the time, you just need simple inheritance, and this one is really easy to implement. And this one might be something like this, the example we have already seen. And this one should be very easy to follow. So for this section, I just want to focus on implementing this part here. And I guess let's actually implement this one in code, and let's see how this is going to look like. Alrighty, so here, once again, we can see our monster class. And from this monster class, I want to get a shark class, and this one should get the health, the energy, the attack method, and the move method of this monster class. We want to put all of this inside of the shark. Now, passing in the methods is very simple, but the health and the energy are going to be a bit more complicated. So for now, let me simplify things a tiny bit by commenting out the Dunder init method and instead setting health to something constant, let's say 50, and energy to 100. The reason being that init is a bit more complicated for inheritance, so I'm going to ignore this part for now just to keep things simple, but we will implement this in just a bit. All right, now for this shark, I want to create an init method by itself, and this one needs self, and in here I want to set the speed. And now what I want to do is self.speed is going to be speed. And this way we are getting our attribute, and besides that I also want one method. And that method I have called bite. And in here we just need self, and let me print the shark has bitten, or whatever you want to put in here. And this by itself would be a functioning class, but also a very limited class because it only has a single attribute and one method. It doesn't really do all that much. So how can I get all of the monster attributes and methods inside of the shark? And to get inheritance, what we have to do is add brackets after the shark, or the name of the shark class. And then here we have to pass in what class we want to inherit from. In my case, this is monster. And for a start, this is all you need. Meaning now I can create my shark by calling shark, and I have to pass in a speed for the shark. And let me just say, I don't know, 120. And now if I print my shark, all of this works just fine, and we are getting an object. But what I can do now is get my shark.health, and this is the 50 we have set all the way at the top here. I can also get my shark speed. This is the 120 we set for the shark in here. And besides that, I can also call shark.bite. We get the shark has bitten. And besides that, I can also set shark.attack. And this one needs an amount, so let's say 20. And this is the attack method we have gotten from here, so the parent class. And if I run this, we get the monster has attacked. And well, with that, we already have super simple inheritance. Just by adding this brackets monster, we are getting all of these attributes and these methods here. So that's a pretty good start. Now, what you can also do, let's say, let me remove some white space here. Let's say for the shark, this move method here doesn't really work because for the shark, I want something else. I want the shark to swim. And for the speed, I want to set, since I have a speed, I want to use self.speed, meaning I want to override this speed from the parent class. And to achieve that, all you have to do is define a method with the same name in the child class. So in here, I want self.move. And now I can add a print statement in here. The shark has moved. And let's say print again. The speed of the shark is, and then self.speed. And this should be an F string. And now if I call shark.move, and we don't need any arguments, if I call this, the shark has moved, the speed of the shark is 120. And what happens in here is we are first getting the inheritance from the monster, and then this move here is being overwritten by this move here, which means you can overwrite what you get from the parent class very easily. And this you could also do with attributes, although we actually have to talk about attributes. Let's do it right now. The problem we are facing right now is that the monster has an init method. Let me remove this health and energy and uncomment the init method. Essentially the problem we have right now, to give the monster the attributes, this self.health and self.energy, we have to first call the init method. And if we don't call the init method, we don't get these attributes. So what we have to figure out inside of the init method, how to call the parent init method. So this would have to happen in here. And for that, we have two ways. One that is a bit outdated, but still works, and one you actually want to use. And let's cover both, but you don't really need the first one anymore. But just in case you see it, let's cover it. Now, what you can do, you can call the parent class, so monster, and then call the Dunder init method. And now in here, you have to pass all of the arguments, so these ones here, that you want for the parent class. So we need self, health, and energy. And these we have to get from arguments. So when I initiate the shark, besides speed, I also want to get health for the shark and energy for the shark. Meaning when I actually create the object of the shark, besides speed, I want to set health to 100 and energy to 80. Now what I get, let's go over this actually. The first step happens down here. I am calling the shark class and I'm passing in 3 arguments. I have the speed, I have the health, and I have the energy. And these 3 arguments are being covered in speed, health, and energy. And inside of this init method, we are calling the parent init method. And into this init method, we have to pass in 3 arguments: self, health, and energy. And self, originally for the parent class, was the class itself. So this self here, which refers to this monster. However, now the self is going to refer to this self here, which is the shark. Meaning when we are setting self.health and self.energy, we don't talk about the monster, we are talking about the shark class. And this is why the self here is important. And then besides the self, we also need health and energy. And these are just going to be arguments we have to pass in here. So this health and this energy. And these two we get from these 2 parameters here, which is health and energy. And those are being passed in here. And we still have the move method. I don't care about this one. Instead, let me print shark dot, let's start with speed. Let's actually print all of them. So besides speed, I want health and I want energy. If I run this, we get 120, 100, and 80. The numbers we have specified here. And well, this can get a bit complicated, but look at the init method here and the init method here. And if you didn't understand what I talked about in the last part, practice this yourself and then go over this a couple of times. If you get used to this, it's eventually going to become fairly easy. Although I suppose in the beginning, this can be a bit overwhelming. The one really important thing you have to understand is that we are calling the init method and we are passing in the arguments that we want to set. In this case, speed, health, and energy. And then inside of this init method, we are right now calling the parent init method and then passing health and energy, so these 2, in there as arguments. So for example, we first set the health here when we are creating the object. This health goes into this health for the parameter, and then this parameter goes into the init method of the parent, and then the init method sets self.health for the actual class. And that way you can connect the init methods of different classes. Now this is how Python used to work, and this still works, but there are some downsides to using it this way. So this isn't really used anymore. Instead, what we use is called super, and this is a function. And this super, all it really does is it gets the parent class. So if we have that, we can just call the init method on it as well. And in here, we don't need self. All we have to do is pass in health and energy. And then we are done. If I run this now, we are getting the very same outcome. Meaning those 2 approaches here are functionally identical, at least up to this point. When we get to multiple inheritance, or let's say more complex inheritance, super is the much better method. And this is why we don't use this initial approach anymore. And I guess this one is also a bit easier to read. It kind of is up to you, but this is the one you do want to use. And super, you can actually use for a lot of other things as well. For example, I could call super and then call the move method of the parent. And in here I have to pass in a speed, let's say 10. So now when I run the code, I get the monster has moved at a speed of 10, meaning when we are calling the init method of the shark class, we are also calling the move method of the parent. And this way, even if you overwrite a method from the parent class, you can still call it with super if you really want to, which adds even more flexibility to all of this. And this is simple inheritance, which is something you definitely want to practice. This is the one kind of inheritance you are going to use fairly often and the one you have to understand. Let's practice this one. And let me add comments one more time. Let's do an exercise. I want you guys to create a scorpion class that inherits from the monster. And it should get health and energy from the parent. And then besides that, there should also be a poison damage attribute. And I want you guys to override the damage method to show poison damage. Kinda like what we have done for the move method for the shark. Pause the video now and try to implement this one yourself and see how far you get. I want to start by creating a class called Scorpion. That is not how you spell scorpion. There we go. And this one should inherit from monster. And now in here, I want to create a Dunder init method. And this one needs self. And besides that, I want poison damage. And now inside of the scorpion, I want to set self poison damage as poison damage. So we are getting an attribute. And then besides that, I want to define or, well, override the attack method. Let me minimize the shark class so we can see the code a bit easier. And I want to override this attack method here. And in my case, what I just want self because I already have the poison damage. And all I want to do in here is print the scorpion has attacked and print it has dealt. And then we want self.poison damage and poison damage. And this should be an F string. All right, so far this should have been fairly easy. What I can do now, let me delete all of this and let's delete the shark as well. We don't need him for now. And what I want to do is to create an instance or an object from my scorpion. I am really bad at typing scorpion. And here I want my scorpion. And right now we have a poison damage, I don't know, of 50. And now if I type scorpion.attack, this is working. The scorpion has attacked, it has dealt 50 poison damage. This shouldn't have an underscore. There we go. It has dealt 50 poison damage. This looks much better. Meaning what we have so far, we have a scorpion with poison damage and we have overwritten the attack method. And since we are inheriting from monster, we are also getting this move method here. Meaning my scorpion can also move at a certain speed, let's say 5. If I run this, and let's make this a bit larger, we have the attack method for the scorpion and we have the move method. But what we don't have, let me get rid of those two. We don't have scorpion.health, for example. This attribute doesn't exist right now because monster only gets these two attributes once we are running the init method. So what we have to do in the scorpion, call the init method of the parent class, which we get with super and then Dunder init in here. And if I scroll up, the monster class for the init method needs 2 arguments, health and energy. So let me comment those 2. And in the init method, I want to pass in health and energy. Now, these numbers have to come from somewhere. Although they don't necessarily have to. I could, for example, just set static numbers in here, let's say 50 and 10. If I run this now, we get 50 for health. Because all we are doing here is calling a function, that is Dunder init. And we are just giving it different arguments. Although this lacks a lot of flexibility, so I don't want to do it. But we could if we wanted to. Instead, I want to get this health and this energy from the init method of the Scorpion class. And in here, just to be specific about what we are doing, let me name this Scorpion health and Scorpion energy. And somehow my brain always wants to add a T to Scorpion. I have no idea why. And now, when I call the init method for the monster, my health should be my Scorpion health, and my energy should be my Scorpion energy. When I am creating the actual object, I want to have, let me use named arguments, that makes it a bit easier to read. My poison damage should be 50, my Scorpion health should be 20, and my Scorpion energy should be 10. And now, if I run this, we get 20 for the health of the Scorpion. Because remember, we are only calling Scorpion health the parameter. So this is Scorpion health here. We don't actually set this parameter as an attribute. Instead, what we do, we are using the health attribute of the parent class, and this gets the value of the Scorpion health. So our Scorpion doesn't have Scorpion health as an attribute, it just has health. And along those lines, we also have energy. If I run this, we get 10. And I hope this starts to make a bit more sense. This is definitely something you want to practice if you only partially followed along. This is a really important concept to understand. And definitely something you are going to see all the time. And this you can actually make quite a bit more complex with, well, more complex inheritance. So let's talk about that one. And basically what that means. So far, we always had one parent class and then a child class. So a pretty immediate connection. Something slightly more complex is you have a child class and 2 parent classes. This is something we are going to build in this section. But if you really wanted to, you could do something like this and it would still work. Now, maintaining something like this is going to be a ton of work. Although once you have it, this child class is incredibly powerful because it gets information from a lot of parent classes. So especially if you create something really large, this is something you do want to be able to understand. But for now, especially if you're a beginner and this is the first time you've really engaged with objects, I wouldn't recommend to worry about this too much because it gets overwhelming very fast. Instead, make sure to understand this scheme. If you understand that one, you should be able to follow along with this one as well. But for now, just practice objects in the first place, and once you have a better grasp of objects, engage in this one. So let's talk about how we could create something like this. And this, I think, is best done in actual code. So let's have a look how we can work with this. Now, here I have some code already. I have the monster class we have seen quite often by now. This one I hope is familiar at this point. Besides that, I also have a fish class now. And this one is a very simple class. All we have is an init method, and this one sets a speed and has scales. And besides that, we have a swim method, and this one just prints swimming at the speed of whatever the speed of the object is going to be. And what I want to do, I want to create my shark again. But this time, the shark is not just going to be inheriting from monster, it is also going to be inheriting from fish. So the first thing for multiple or complex inheritance is that all the objects you want to inherit from should be here in the brackets after the name of the class. And in here, you could add as many other classes you want. There could be class 3, class 4, class 5, as many as you want. There isn't really a limit. And now inside of this shark, I want to set a Dunder init method. And in here, we always need self. This one should make sense by now. And besides that, for the shark, let's say I want to set a byte strength. And then inside of this init method, I want to self.byteStrength is going to be byte strength. This one should still make sense. It's quite straightforward. But the more complex one is if I now want to call super and then Dunder init. Now we have a problem because I have no idea what to put in here. And the question here is, what arguments should go into this init method? Should I add the arguments for the monster class or for the fish class? Or both? How would this work? And there are a couple of things you have to understand to solve this problem. The first one is called the MRO, or the method resolution order. And what this really means is, let me add a comment here, MRO, or method resolution order. What this basically means is in what order the parent init methods are being called. And this you can get by just printing. And I want to get the shark class, not the object, the class itself, and call MRO on it. And this is still going to work. And if I call this, we are getting invalid syntax because the question mark here is not something Python likes. So let me comment it out for now. And now let's run this again. And now we can see the MRO, or the resolution order. And basically what it means is in what order Python is going to go through the classes. We start with the shark itself. This one should make sense. This is the class that we actually work in, so this is where we want to start. Next up, we are looking at the monster class. Then we look at the fish. And finally, we look at a generic object. And this generic object you don't have to worry about because this is something inbuilt into Python. It's the thing that makes all of the objects work. You don't have to worry about it. So what we have to worry about is the shark, the monster, and the fish. And how this order comes about is from the order of these arguments here. And basically how this works is that the leftmost item, monster in this case, is always going to be the first in line, with the class itself being the very first item. So shark is going to be 0, monster is 1, fish is 2, and then every subsequent item is going to be next. Meaning what I could be doing is turn these two around and call fish first and then monster. If I run this now, we are still starting on our shark, but now fish is the first item of inheritance, then we have monster, and we still have object finally. But in my case, I do want to keep monster as the first item. So the first thing you do have to understand is if we are calling the super Dunder init method, we are looking at the first item inside of these arguments here. So in this case, monster. Meaning for now, I can minimize the fish class and just look at the monster. And let me minimize these methods as well, so it's a bit easier to see. And basically what I can do now, let me comment out the MRO, and I actually want to create a shark object from my shark. And this is something you should be familiar with from simple inheritance. Right now, we only have the byte strength. So byte strength, and this we can set to whatever we want, let's say 50. But now for this super init method, I need the arguments for the init method of the parent class. In this case, health and energy. These two I want to pass in here. Now for these two, I am going to need some numbers. So for the init method of the shark class, I also want health and energy. Meaning when I create the object, I also want health and energy. And let's set those to, I don't know, 200 and energy could be 55. And with that, we are essentially back to simple inheritance. I first call the class itself, and the first thing we do after calling the class, we are calling the init method. And inside of the init method, Python knows that the first item of inheritance is the monster class. And then after that, Python knows we have one parameter for byte strength, and this we're just setting as a parameter, and then we are done with it. So this is as far as this one goes. Besides that, we also have health and energy. And these two we want to pass into the init method of the first parent class, so the monster. And those we are getting up here. But now we have another problem. And that problem is what happens to the fish. Let me run the code and let's see what happens. We are not getting an error. That's a pretty good sign. Now, if I run shark, and the methods we have here could, for example, be attack. And for attack, we need an amount, let's say 10. The monster is attacked, 10 damage was dealt, so this attack method works just fine. Besides that, I can also print shark.health, and let me print this. This one is working, 200. We also get shark.energy with 55, and we are also getting the byte strength. So far, we have the shark itself and the monster. What we don't have is the fish. Let me minimize the monster class and open the fish. In here, we have speed and has scales. And this, our class doesn't have right now. So if I type shark and speed and run the code, we are getting that the shark object has no attribute speed, which means that the inheritance from the fish is not working right now. And let me reopen the monster and hide the monster methods so we can see all of the classes quite easily. Basically, what is happening? The MRO is important here again, this one here. Essentially, how you have to think about it. We first of all call the shark, and then we call the init method of the shark. And then Python knows the first item of inheritance is the monster. And since we are calling super.init, we are calling this init method up here and passing the arguments in there. The consequence is that we have health and energy for the monster, and the normal inheritance still works, so we also have attack and move. But now the problem is that the init method of the fish is never called. And as a consequence, speed and has scales doesn't exist inside of the shark. And what we have to figure out is how to call this init method. And since we still have to worry about the MRO, we have to figure out how to call this init method with the arguments from inside of the init method of the monster. And for that purpose, we are still going to need the super and then the Dunder init method. And this function is very smart because it follows the inheritance that we have set by the shark to begin with. Meaning, if we call the monster from the shark, it knows it has to look at the fish next in line. However, if we call the monster by itself, this init method wouldn't really do anything. So this is a very intelligent function. In the simplest terms, basically what this init method has to do is to set the speed and has scales of the other class, which is the fish again. Let me set some static numbers. For the speed, let's go with 75. And for scales, this should be false. And now, if I run all of this again, I get for speed, let's try this again now. For speed, I get 75. And for has scales, I get false. The arguments we have set in here. And this is, especially if you are starting with objects, probably going to be really confusing. But the one thing that makes all of this work is the order of the init methods. We are first calling this one here. This is number 1. Then we are looking at the monster, which is this one here. This init method is number 2 then. And then finally, we are looking at the second item in the inheritance, which is the fish, this fish here. So this init method is called third. And we always need the super init method to go to the next item. And what we would want to add in here as well is a super and then Dunder init method for the fish as well. So if there's going to be another item in the list of inheritance or in the MRO, we would also call that one. And for that reason, you very often see super init in most classes because it enables inheritance to work across multiple classes. And well, I hope you can still follow along. This is getting quite complicated and it is just going to get worse because right now we do have one problem, and that is that this speed here and the Haskell's are constant right now. But I want to be able to set them dynamically when I am creating the shark. Meaning what I want to do when I create the shark, I want to set this speed. Let's set it to 120, and I want to set Haskell's to false. And this would then be all the stuff I have for the shark, and I think it makes sense to put all of this on separate lines to make it a bit easier to read. Alright, but now if I run this, we are getting an error that shark init got unexpected keyword argument speed. Basically, what Python is complaining about, that this speed and this Haskell's don't exist in the parameters for the init method of the shark class. We can fix that by adding a speed and Haskell's in here. If I run this now, this is going to work, but we're not doing anything with either the speed or the Haskell's. We are still up here setting the speed and Haskell's as constant numbers. And now we kind of have a problem, because if I try to, in this super init method, add this speed and Haskell's, then let me fix the typo first. If I run this now, we are getting the other problem, that monster.init. Down here is the error we're getting right now. Monster.init takes 3 positional arguments, but 3 were given. Meaning, Python in the monster class wants 3 arguments, self, health, and energy. And those we do get. Let me minimize the fish for now so we can see what's going on. We are getting health and energy, and this is what this init method wants. But besides that now, we are also adding speed and Haskell's. And for this, the init method doesn't have any parameters. So Python is very unhappy because it gets too many arguments and it doesn't know what to do with them. But this is a problem for us because we need those 2 arguments to pass into the init method for the fish. But the init method of the monster doesn't have as many parameters, so we have a problem here. And to overcome this, we need one special concept, and that in Python is called keyword unpacking. And basically what it means is, in my monster class, after I have added all of the parameters I definitely know I need, I want to add star star and then keyword arguments. And that way, any argument I get after the parameters, I'm going to store those in a separate dictionary. Let me actually print what we get. So I want to print my keyword arguments without the stars for now. And for these double stars, Python is expecting keyword arguments. So all of the arguments for the init method here need to be keyword arguments, meaning health.health, energy is energy, speed is speed, and has_scales is Haskell's. And now if I run this, we are getting a dictionary with speed and Haskell's. And this false here we are getting from printing shark Haskell's. Let me remove that and try this again now. So now we can focus on just the dictionary. And that is something really useful because this we could use in here now. And essentially what you have to do is call the unpacking operator again and passing in the keyword arguments. And now if I run this again, we are still getting the same dictionary. So we are getting speed and we're getting Haskell's. But what happens now if we are calling this star again, it turns each key value pair inside of this dictionary into a named argument, meaning this speed under 20 is going to become a named argument. And then this we are passing into the init method of the next class in the method resolution order. And with that, if I now print shark.speed and actually display what we get, I now get 120, the one we have specified in here. And this is how you would work with this. Now, for an actual example, you would add a lot more quarks to all of these classes. For example, the fish would also have double star and keyword arguments, and then you would pass this into the init method as well. So in here, quarks as well. Now, in this case, the keyword arguments is going to be empty. If I print it, keyword arguments, and run this, we're getting an empty dictionary, because we don't have any additional named arguments that we have to worry about. So this dictionary here is going to be empty. Well, this dictionary actually. But if we had more named arguments, they would all go in there. And this is then how you would deal with multiple inheritance. And if, again, you are just starting with inheritance, this really isn't something you want to worry about too much. Probably if you're watching this for the first time and you're still struggling with objects in general, this is going to be way too much. I would recommend just practice objects and simple inheritance for now, and once you are more comfortable with them, come back to this. This sort of inheritance is only really something you are going to see once you get much more advanced. Especially for making games or for making GUIs, you probably don't need any of this whatsoever. All of the games I have made so far have never used multiple inheritance. They all use simple inheritance and they worked just fine. But, well, at this point, we have covered all the main parts of classes. I guess at this point there is some more smaller things I do want to cover, but they're all going to be fairly simple. So let's talk about them in the next section. Alright, for this part, I want to talk about some extra parts for classes. And those are things I couldn't really fit in any of the other sections, but they're all fairly simple, but they can be quite useful. And, well, let's do all of this straight in code. I think that's going to be the easiest. Alright, once more, we have the monster class, and this is just something I want to use to illustrate what we are going to do. And let me create an instance of this monster with monster, and for the health I want 20, for the energy I want 10. It really doesn't matter what number we go with here. And now there are three things I want to cover. The first one is private attributes. The second one is has utter and set utter. And the third one is going to be the doc string. And once we have those, we are basically done with classes. And the first one is going to be private attributes, which is just going to be an attribute inside of a class that cannot be influenced from outside of the class, which may be something like an ID number that you really want to make sure of cannot be changed from outside of the class to be sure that it doesn't mess with some other code. And this actually isn't possible in Python. We are always able to change the attribute of a class. So Python developers came up with something else. And this, let me copy this comment here. And in the init method of the monster class, I want to create a private attribute. And how you would do this is first add an underscore and then the name of the attribute. Let's say in this case, I want to have an ID. And the number I want here could be 5, but it could be anything. It really doesn't matter. And now this ID by convention is not supposed to be changed, but this is just a convention. Basically what you do with this format is you tell other developers that this attribute should not be worked on, but you totally could work on it. For example, what I can do, I can print monster, and then underscore ID, and I get 5. Meaning you can work with it, but there's a very clear indicator that you shouldn't. So if you ever work with somebody else and they added something like this, you probably should not change it. And well, that is all you need to know about private attributes. You could do the same thing for methods. You are essentially following a naming scheme, so this works with both attributes and methods. Alright, next up, we have hasUtter and setUtter. And what those two are doing is they allow us to check if a class has an attribute, and we can also use it to set an attribute. And the first one is going to be hasUtter. And that is just going to be a normal Python function. And this one wants 2 arguments. It first of all wants to have an object, and besides that, it wants a string with an attribute name. And let's try this one. I want to look at my monster. And for my monster, I want to check if the monster has health. And this is then going to return a Boolean that either says true or false. Meaning I can print all of this and I get true. So this monster has the attribute health. If I check for something that doesn't exist, let's say a weapon, I get false because the monster doesn't have a weapon. And this you could then use in an if statement. For example, if hasUtter monster health, and if it has health, I want to print the monster has, and I guess then we can use an f string monster.health, and that is terrible spelling. And let's turn this into an f string and add health at the end. And now if I run this, the monster has 20 health, and that is what we have set here. And this is hasUtter. It's a really useful way to check if a certain class has an attribute. You are going to use this fairly often actually. It's a really useful function. And besides that, setUtter works in kind of the same way. So let me call it setUtter. And in here, we need 3 arguments. First of all, we need an object. Then we need a string of an attribute name. Let's call it attribute again. And then we have to set a new value. And this could be a string, it could be a number. It's really up to you. I guess, let's say again, I want to look at my monster. The attribute I want to set is a weapon. And for the value, let's give the monster a sword. And now I can print monster.weapon, and I get sword. And this setUtter is basically the same thing as calling monster.weapon and setting this to sword. These two things essentially do the same thing. And now you might be wondering, why do we have this kind of redundancy? That this is kind of pointless, at least seemingly, that we have this entire function that does something very obvious. But the reason for it, that this allows us to very efficiently create new attributes. For example, what we could be doing, let me comment those two out, and I could run a for loop. And let me add, let's call it new attributes. And this is going to be a tuple with lists. I want to have, for example, a weapon, and there I can have an X. Besides that, I want to have another list with, let's say, armor, and the armor could be a shield. And finally, I want to have one more list, and this could be potion. I could set something like mana or whatever you want to go for. And now I can use that as a for loop. So for attribute and value in new attributes, I can call setUtter. I can pass in my monster in here, and then I want my attribute and my value. And if I run this, we are not getting an error, which is a good sign. And now I can print my vars for the monster. And I get the new weapon, the new armor, and the new potion. And this way, you can set a lot of new attributes and values for a class by using this. If you just used monster.weapon, this one here, this would not be possible. And this is why setUtter exists. Although you probably would want to create all of these attributes when you actually create the object itself. So this isn't something you want to do too often, although in some situations it can be really useful. But all right, with that, we have setUtter and hasUtter. And finally, we have doc. And doc is just there to explain what your object does. That's really just about it. You are getting doc, or the doc string to be more specific, by calling monster and then dunder doc. And in this case, if I run this, we get none. For the simple reason that we have to create a doc string for our object. And this you do first thing in the object, and all you do in here is you set a triple quotation mark like this. And then in there, you are setting what you want for the monster. For example, I could write in here, a monster that has some attributes. And I am really bad at spelling monster for some reason. And now if I run this print again, and now I get a monster that has some attributes. And this you could make significantly longer, depending on what kind of class you have, but this is usually what you want to set to explain your code to other people. And especially if you work in a team with much larger projects, it's really helpful to set something like this, because, well, somebody else might have no idea what you're talking about. What you can also do is let me comment out this print statement here and instead call help. And I want to look at my monster. If I run this, I am getting a long list of different things. And in here, I can see lots of useful things. For example, I can see monster and its parameters. I can see the doc string. And I can see all of the methods inside of it. And if you just find a new object you don't really know much about, the help function is really useful. As a matter of fact, you can also pass normal Python code in here. For example, what I could pass in here is just str for string. And now Python gives me the help function for strings. And if I go all the way to the top, there you can see basically that we have another object, and the object takes one argument, which is going to be a string. Then we have the doc string, and this one explains what this object does. And afterwards, we have all of the methods, and there are quite a few because strings are very complex objects. And with that, we have covered objects and classes. I hope that wasn't too difficult, but this is definitely something you do want to practice. So I hope that was helpful, and I will see you around. In this part, we are going to be talking about modules. This is the part where Python really becomes powerful. So let's talk about it. Essentially, modules are just extra parts that we can attach to our programs. For example, if we wanted random numbers, we would add the random module. That's basically what it is. There are quite a few modules that we can use that come with Python by default, and random is the one you are probably going to use the most, but I will cover a few more in just a bit. Besides that, we can also create our own modules to make our code more organized. And each module would be in a separate file, which makes it really easy to organize larger programs, which is something we're also going to cover in just a bit. But the much more important part is to use modules for extra functionality. And let's start with that one. And in here, we have two different options. We can either import from the Python standard library. All this really means is that these modules come with Python when we install Python. So we can just import them and then work with them. It's super easy. Besides that, we can also import additional modules made by other people. But those we have to install on our computer first. These modules here can become incredibly important. For example, if we want to make games or work with machine learning or do data analysis or run databases, we would basically install additional modules to make all of this work. But let's not get ahead of ourselves, and let's start with the Python standard library, and by just talking about basic modules. Here we once again have a completely empty Python file, and what I want to create is a random number. The problem we have is that there's no way so far to create random numbers, but we can do it by importing a module. And this we do with the import command and then the name of the module. And the module we want here is called random. And this one is giving us random numbers. I think the name makes sense here. And random has lots of different submodules that we could be using. And the way you would access them is first the name of the module and then the methods inside of it. And one here is called randint, which is standing for random integer. And this is just a method, we can call it. Although this one is expecting two arguments, a minimum and a maximum number. But once I have those two, I can print the random number. And now if I run this, I get different random numbers every time I'm executing this code. And now you might be wondering, how do you know what else is inside of the random module? And that's a really good question. Usually what you do is you just Google the module and then you find lots of information. For example, for random, we have a whole documentation that is actually incredibly extensive. So all of the stuff in here would be part of the random module. The one we have seen already is random.randint. And all it does is it creates a random integer between two numbers. And this is a function you are using all the time. It is really popular. Another one that you are seeing fairly often is choice. And this one picks a random item from some kind of sequence. This could be a list, it could be a dictionary, something like that. And let's actually implement this one. Here I'm back in the code and I want to create a test list. And for this test list, I just want to have a couple of numbers. It really doesn't matter. I guess let me put the print on top. And now I want to select one item from this list. And for that, I would get my random again, and I would add choice. And now this choice is expecting one argument, and that is the list. So test list in here. And now all I have to do is print the result. And let me comment out this stuff up here so we're not getting confused. And if I run this, we get different items from this list. I guess to make it a bit more visually appealing, let's add a few different data types in here. This one is looking better. So now if I run this, we get all of the different values. And that is, in the most basic sense, how you would be using modules. And there are a lot of different modules that come with Python already. If you look this up online, you are going to find this list calling the Python standard library. And those are all of the modules that come with Python. And in here, we have a lot of different options that we could be working with. For example, the one I'm seeing right now is called tkinter, and this is the most common way to create GUIs or graphical user interface in Python. It basically gives you buttons. Besides that, we also have a ton of modules that work with the internet. And if I go up a bit more, we can see, I hope I find it, there should be random in here somewhere. There we go, there is random. And there are quite a few more modules that we could use with numbers. Chances are you are only ever going to see a very small part of all of these modules. Even I have only ever used a very small part of them. For example, I have no idea what RL completer is. I have never used it even once. But some modules in here are incredibly useful, and you do want to have a basic awareness of them. And you basically learn all of them by just using Python and then discovering more and more of them. Now, if you want to import multiple modules, you can do it in two ways. you could either on another line import something again. Let's say what I could also import is the string module. And what this one does, let me comment this one out. I could, for example, print string, and in here I could print the S key underscore lowercase. And be aware, this is not a method, this is just an attribute. And if I run this, I get all the lowercase letters of the alphabet. That's really it. String is a very simple module. If you are importing two modules just like that, to save a bit of space, you can put all of this on the same line, like this. And then I can get rid of the second line, run all of this again, and we get the same output. The random module would still work just fine. I guess one more module that we could be looking at that you do see fairly often is called math. And this one is giving us a few more advanced math functions. For example, what we could do in here is print math.sineCurve and add like a 1 in here. And if you have no idea what this means, don't worry too much about it. It's just a sine curve, not something you use too often unless you are doing some fairly specific tasks. I suppose a more common operation for math would be floor. And this one gives us the floor of an integer, meaning if I have 4.9, this one is giving me 4. We are basically just rounding down. That's all that's happening in here. And with that, we have a couple more modules. Now, there are a few more things you can do with the import statement. And those are mostly to be more specific in terms of what you import. For example, for my math, I only want to import math.floor and nothing else. And if that is the case, you can just type from math import floor. And this way, we are only importing floor, and we don't have to worry about the math part in front of it. Meaning now, when I'm calling it down here, I can remove it and call floor like any other function. Oh, and let me get rid of the comma all the way up here. That shouldn't be there. Now, if I run this, we get the same outcome, and this floor now works like any other Python function. If you really wanted to, you could also rename this floor function. And this you would do by adding s and then the name. And you could name this any valid Python name. I could, for example, call it get floor, and then this one here would be get underscore floor, and there we go, same outcome. I guess what you would mostly do in here is to shorten method names if they get too long. For example, I could shorten this to f, and this would then save me quite a bit of writing. And some modules do get very long, so this isn't actually as rare as you would think it is. And finally, there's one more thing that we can do. Let's say for this random here, I want to use all of the methods, but I don't really want to write this random at the beginning every single time. And to achieve that, we would use from random again. But now, when we import individual modules, we are typing a star. And this tells Python we want to import every single method and function from the random module and then use it in our code. And this allows us to use all of them without writing random first. Meaning now I can run this and I still get the same outcome. Although this you really don't want to overdo, because if you import all of it, you are, well, importing all of it. And this could add a ton of functions and methods and variables that you don't want to use and that could clutter up your program. But all right, with that, we have covered the basics of modules, and let's do an exercise. And this is going to involve a bit of research on your part. What I want you guys to do is to get the current time from the datetime module. So do some Google research and try to figure out how to get this. It should be doable in a single line of code. I guess 2 lines of code if you include the importing part as well. But pause the video now and try this one yourself. I suppose the best way to start this is by doing the research ourselves. Here, again, we have the website with the Python standard library. And what I'm looking for, it's already in here, I am looking for datetime, the module. And this I get here. If I click on it, I get a lot more information. And in here, if you scroll down, you can find a ton of different things. It's actually quite an extensive module, but I'm just looking for one specific thing. I hope I can find it. For example, here we would have today. That is kind of useful, but I want to find the current time. And the current time I can find in here. Class method datetime now. This is what I was looking for. And this gives me the current time. Now, you obviously didn't know that this one even existed. So this probably took you a bit more Googling, but most of the time, this is how you discover new modules. You just Google a problem, then you in some forum find a new module, and this solves most of your issues. That's basically how everybody learns Python or any programming language in general. Let's implement it. Here I'm back in the code. I want to import datetime. Although datetime is a bit weird, because what we have to do is from datetime import datetime. And what that means is inside of the datetime module, we have one object called datetime. They just happen to have the same name, which can be kind of confusing, but well, it is what it is. And I guess just to be a bit fancy here, let's abbreviate it as DT. And now to get the current time, I need my datetime.now. And this I can just print. And if I run the code now, I get lots of stuff. Let me comment out all of this. And now I get my current date and my current time down to some nanoseconds. With that, we have covered all the basics of modules. Meaning if you got so far, you already have a pretty good understanding. Although you can do quite a bit more. And that is going to be the next part. In this part, we are going to cover external modules. And external modules are just modules that are made by other programmers. And this is giving us a ton of extra functionality. For example, any kind of game development, any kind of data analysis, machine learning, graphical user interface, and a lot more is essentially just a module made by somebody else, and we are using these functionalities. And this is one of the really strong parts of Python. There's a very active community that makes a lot of extra modules that you can use for your own projects. Almost all of them are free. There are some very select ones that are being paid. Those are usually more business-oriented ones that you don't have to worry about. And these modules are imported like the standard modules. The only difference is that these modules have to be installed on your computer first. And this can be done in a couple of ways. The most common one is in the PowerShell or the terminal. Now, what does that mean? The PowerShell is for Windows and the terminal is for macOS. And both are command line interfaces. And what a command line interface is simply a way to interact with your computer simply by typing text. If you ever watched any kind of old movies, those always used command line interfaces, where people just write commands into a computer. There are no buttons, no windows, you just write text into your computer. And this is what we are doing here as well. And this is the way Python is intended to be used. It's honestly the easiest way and sounds way more complicated than it actually is. But let's actually have a look at this. And let's start with Windows. Both versions are identical, bar a very minor difference. Now for Windows, you just have to open the Start menu and type PowerShell. And if you press enter, you can see something like this. Let me full screen it. And this is a command line interface for Windows. And in here, I can type a ton of commands to make Windows do something. In my case, I only want to do some very specific things. And what I want to do is to type pip and install, and then the module I want to go for. And pip is the Python package manager, meaning this is what we are using to install any kind of external module. And the module I want to install now is called PyAutoGUI. And now all you have to do is press enter, and Python is installing a bunch of different things. There really isn't that much we have to do ourselves. But at the end, you can see successfully installed PyAutoGUI and then the version name. And that is basically all you have to do. Although I guess there are a few more things I do want to cover in here. One command that I found really useful is called clear. And this one clears the entire interface, so things are a bit cleaner. And one more thing that can be useful is called pip list. And this one gives you all the modules that are being installed. And your list should be a good bit shorter than mine, but you can install a ton of different things here. And finally, if you want to uninstall a module, you would just run pip uninstall. And in my case, I want to uninstall pyauto-GUI. Then Python would ask us if we want to proceed. I want to with yes, and now it's uninstalled. Now I can clear all of this again. And since I do want to use pyauto-GUI, I want to install it again. And this could be a good exercise for you. So install pyauto-GUI yourself again and see how far you get. All we need is pip install pyauto-GUI. If I type this, we get all of this again, and we have installed pyauto-GUI. And that is pretty much all we needed. And now that we have that, let's do the same thing for macOS. You open all of your programs, and in there, you type terminal. Once you do that, you're getting a new window, and let me maximize it. In here, if you hold the Apple key and plus, you can increase the font size, which I really want to do. You might not need it. And in here, we can work with macOS using commands. Just like in Windows, I could type commands here to control Mac OS. Obviously not like that, but you get the idea. For example, clear works just in the same way. Most commands do, actually. The one minor difference here is we do not type pip install and the module. Instead, we would be writing pip free install and then the module. The only difference here is the free, the rest stays identical. The free here is needed because on macOS, Python comes pre-installed. The problem is the Python version is really old, and when we installed Python on the Mac, we installed a separate version of Python. And this free is to tell Python that we want to use the latest one, which is Python 3. We do not want to use the original Python. But that is the only difference. So in my case, I want to install pyauto-GUI. I press enter. Now Python is doing a thing, and at the end, we get successfully installed pyauto-GUI. And if you notice here, this is the same version we have on Windows. And with that, we are good to go. Inside of our code editor, there's not going to be a single difference. So let's have a look at that. All right, here we are back in my Python file, and I'm using Windows, but this is going to work both with Mac and with Windows. The installing part was the only difference between the operating systems. But now I have pyauto-GUI, so I want to import it. So import pyauto-GUI. And what this module is doing is it automates Windows to a certain extent. For example, what you could be doing is to move the mouse around or to write some text from your computer with Python. And I guess let's get started with that. Now that we have pyauto-GUI, I just want to call the entire module and then write. And now in here, I can tell it to write some text. For example, this is written by a computer. And now if I would run this code, we would have this typed out. Although right now this would be kind of awkward because I have no time to switch to another program like a text editor. Meaning I want to import another module from the Python standard library or another part of a module. And this is called from time import sleep. And all that sleep does is it pauses our code for a certain time interval. Let's say I want to call sleep and 1 second. And now let me bring in a text editor and let me run the code, switch back. And now we have this is written by a computer. The text you have just seen was just written by Python, not by me. I suppose to make the effect a bit more noticeable is for this method here, we can add another argument or a named argument to be more specific. And this is called interval. And in my case, let's go with 0.5. probably a bit long, let's say 0.25. And this is the interval duration between each letter that is being typed out. I guess let me write again and switch back to the text editor. And now you can see this is written by a computer, just very, very slowly. I guess what you also could do is run the code itself. And now Python is writing this code by itself in Sublime. This is also working just fine. PyAutoGUI doesn't care where it's writing, it just starts typing these letters. Let me get rid of them. And with that, we have one module. The only difference to standard modules is we are first installing it via pip, and then we're using it like any other module. And the main task for you is to understand what each module is doing. And for that, you usually find documentations online. Let's actually have a look at the one for PyAutoGUI. It is looking like this. And if you scroll around here, you can find a ton of different things you could do. For example, you could move your mouse, you could add a click, you could add a double click, you could write, you could press a button. There are a ton of things you can do with PyAutoGUI. It's a really fun module. And well, this is then bringing us to the exercise bit. And what I want you guys to do is to do a bit more research. And what that means is create a graph from any of the examples below. I should type these things out more. But essentially, here you have a link to a website. If I copy this and open the website, you can see a tutorial for pyplot in the matplotlib module. And this is the standard module you would use for data analysis. It basically makes nice looking graphs. And I want you guys to look at any of these examples and try to understand what is happening. Or, well, you first have to install matplotlib, and then you can follow any of these examples. So try to do that. Install the matplotlib module and try to copy or understand any of these examples. It's entirely up to you which one. Maybe go for something slightly more complex. This could be a really good challenge for you. I want to work on the simplest example here because I want to keep the video short. And the first thing we have to do is to install matplotlib. So once again, for Windows, I want the PowerShell. Let me maximize it. I guess let me clear this one first, so it's a bit easier to read. And now what I have to do is pip install matplotlib. And if I run this, we have to install quite a few different things. This is going to take a second, and we have successfully installed matplotlib 3.5.2. And if you are working on a Mac, this would be pip3 install matplotlib. Now that we have that, let's return to the code. And in here, let's comment out all of this. And we have to figure out how to import matplotlib. And let me bring in the reference from the side. Let's put it here. This is good for reference. On the first line, we have to import matplotlib.pyplot as PLT. When we're importing matplotlib, we are not importing all of it. We're just getting one subpart of it, pyplot, and we're renaming this to PLT because typing is hard. So I want import matplotlib.pyplot as PLT. And now after the exercise, I have to create a plt.plot. And this one wants a list with a couple of numbers. In the example, it's 1, 2, 3, and 4. And once you have that, you can already run this program, and you're running this with plt.show. Meaning if I run this now, we are getting a graph, the one you can see on the right, besides the Y labels. And in here, you can change the numbers quite easily. For example, I could add 10, 0, 100, and if I run this again, we get a very different looking graph. All that the plot method really wants is a list of numbers, and then it puts them into a line chart. And what we also see in the example is plt.y label. And all this one really does is it adds a label on the y-axis. So some numbers in this case on the example. And I guess let's copy it one-to-one. We have some numbers for the y-axis to be a bit more specific. Now if I run this, we have some numbers for the y-axis. We can also do the same thing for the x-axis if you really want to, and this you get with plt.xLabel. And then we have some number for the x-axis. If I run this, we can see at the bottom now we have some numbers for the x-axis. And that would be matplotlib, or at the very least a really basic introduction to matplotlib. Matplotlib is a really complex module that can visualize data in a ton of different ways. So if you want to learn it, it is going to take you quite some time. All right, with that, we have external modules. So the last part for modules is to create our own. For this part, we are going to create our own custom modules. And the one question you might be having is, why would you want to do that? And the answer primarily is organization. That you are creating modules and each module is in a separate file. And that way, you just never have too much stuff in one file, which really helps organizing your code. So far, we just never really needed it, but later on, when we have thousands of lines of code, this becomes incredibly useful to not get lost in your own program. That being said, you don't have to do it, but it's a really good idea to do that. I guess let's implement all of this, and that should explain it the best. All right, here, once again, we have a completely empty Python file. Now, since we are working with multiple files, I want to be able to switch between them. And the best way for that is using tabs. So in Sublime, I'm pressing Alt, and then I can see all of the menu options. You could get the same result by pressing F11, and then you get this menu item here, and you can select different things. And in my case, I want to, in View, show tabs. And then I can see the different tabs I've opened, right now only one. And let me return to full screen so it looks a bit cleaner. And now this module is only going to import the stuff from another module, meaning I have to create another Python file with Ctrl-N, and this one I want to save. So if I click on save, I can save this to whatever I want. Let's call this one my module, and this is still going to be a Python file. And now I save this, and now I have two files open that I can switch between, although right now both are completely empty. And let's start in my module.py. In here, for the simplest possible example, I just want to create a test variable, and this could have any value. Let's say test. And now this module, I want to import in my custom modules Python file. And this happens in the normal way. I first have to import my underscore module, and this should not be capitalized. And if you run this and you don't get an error, this is looking pretty good. And now that you have that, you can use this module like any other module. For example, in our case, I can run my module, and then in my module, I have a test var. Let me copy it. I can print this, and I get test. This is also going to work with functions and with classes. For example, I could create a test underscore function, and then here we could even add some parameters. And let's say I just want to print this is an imported function with the parameter and then parameter. And now this function I can also use inside of my main module, meaning I want my module.test underscore function, and the argument I want to pass in here, let's say, is 123. And if I run this now, we are getting an error. The name parameter is not defined. And the reason is that the parameter and this parameter here have different names. This one should be content. And now if we execute the code, we get this is an imported function with the parameter 1, 2, and 3. So this one is working just fine. Finally, what you can also do, let me do it below the function. I can create a class called my class. And then here you can run init with self and give it a self.name. Let's call it my app, and we can call self.value, I don't know, 12. And this can also have a method. It's literally like any other class. Let's call it do something. It needs self and nothing else. And then here, I just want to print hello. So once again, super simple class that we now are able to import in the main file. Actually, what I can do, if I hold Control and click on my module, I can see both files side by side, which is quite handy. And while looking at this, I realized that this has the wrong naming scheme. This should be my class. In fact, now looking at this, this feels like a really bad name. Let's rename it to test. And now I can call test and my module dot test, and don't forget the brackets. Now I can run test dot do something. And if I run this, we get hello, meaning this module test here refers to this class test, and this do something refers to this do something here. And later on, you are really going to appreciate having more files with less code in each individual file. It makes it much easier to work with. But I guess let's do an exercise. And what I want you guys to do is to create a sum calculator function that takes unlimited arguments and returns the sum. And create it here and run it in the main file. So pause the video now and create this one function, import it to the main file, and then run it there. All we have to do is create another function, and let's call this one sum calculator. And in here, I want to have one parameter that I called nums, but I want to be ready for unlimited arguments, so this I want to unpack. And now inside of the function, all I want to do is to return the sum of these nums. And that is literally it. Now that I have that, I guess we can be a bit more fancy here. Let's say from my module, I want to import the sum calculator. And again, this is working exactly the same way compared to what we have seen before with the external or the Python standard modules. And now that I have that, sum calculator, and I can add 1, 2, 3, 4, and 5, run this, and we don't get anything because we are just returning something, we are not printing it. So let's print it, and there we go, we get 15. And with that, we are pretty much good to go for modules. Although there is one more topic we do have to cover that is going to be quite short though. When you are creating your own Python modules, there's one really important concept you have to understand, and that is called Dunder main. All this one really means is when a Python file is called, it creates a couple of internal variables, and Dunder main is one of them. It is in fact the most used one. Essentially what it does is it gives a name to the current Python file, and the one that we are executing is always called Dunder main. But any imported file is called Dunder and then the file name. And this is really useful to control what code is being executed, and more importantly, to avoid executing code by accident. Here is the example from the last video. And in my main file, I want to print Dunder name, both in my main file and in the one I am importing. And if I run the code now, I get Dunder main all the way at the end, and all the way at the top, I get my module. I guess let me comment out all of the other print statements that is going to make it easier to read. Now if I run this, we get two print statements. We have my module and main. And what happens internally is Python first runs all of this imported code here, and what it gets at the end is print name, So it prints my module. And this my module is the same as the name my module up here. This is the name of the file. And after that, we are printing in the main file Dunder name, and then we are getting Dunder main. And the reason why this is called main instead of the file name we get up here is that this is the file we are currently executing. If I just looked at my module, so this one here, and run this again, and we are getting main here because right now we are executing my module, which turns this one into the main file. And this is being used usually with an if statement. And you're looking for if Dunder name is equal to Dunder main. Only if that is the case, let's say I want to print the main file. This makes sure you are only running this code if this is actually the file you are executing. And most of the time when you have multiple files, like in this case, all of the actual code is inside of this if statement. If you have other kinds of code, let's say for this one here, for my module.py, I would add the same if statement. This one here. And then the print statement would be inside of it. If I executed my custom module, I would only get the main file, this one here. And inside of my module, this one here would not be executed. And this way, if you have this if statement for every single file, you have a lot of control about what is getting executed when you are importing the file, which can be incredibly handy. In this entire section, we are going to cover some extra topics. Now, I do want to be clear here. Basically, all of these parts are very useful, but not that common, especially for beginners. The longest video in here are decorators and error handling. As a beginner, you are not going to encounter them or use them basically at all. Meaning, at least for now, it's perfectly fine to skip this entire section and return later. It is probably a good idea for you to practice basic Python and then explore these areas. Especially decorators can get really complicated. And if you're just getting started, you are not going to use them anyway, so you might as well skip them at the very least for the beginning. That being said, I do want to cover them because I want to cover all of Python. And first of all, I want to cover two very simple topics that I would recommend you to check out. And those are called pass and input. All that pass really does is it tells Python to not do anything. This does seem kind of pointless. And basically, you would only use it if you have a function but no content yet. So maybe you have a function with a good name, but you don't yet have good content for the function. So you have to fill it with something, and you would use a pass for that. Besides that, we have input. This is another function that can get user input. Although you are hardly ever going to use it. I'll talk about it in just a second, but it really isn't as useful as it sounds. So inside of a Python file, let's say I have a function that is really important function name with whatever parameters you have. And for this function, you don't have content yet. You don't really know what to do with it, or at least you're prototyping it, but you do want to keep the function by itself. But if you're doing this without any content and run the code, you are going to get an error, because Python expected an indented block after function defined on line 1. So Python needs to have something in here. And for that, you could just add pass, and now everything works just fine. So pass is basically telling Python to not do anything. And well, not doing anything is something you usually don't have to define. So this pass you hardly ever see in anything productive. It's pretty much only there to cover some kind of content where you don't have content yet. It's a filler, essentially. Now, besides that, we have input. Let's say I want to get some kind of user input. And for that, we would need input. And now in here, we can use this kind of like print. For example, I could print to the user, press a button. And whatever the user is going to press is going to be stored inside of this user input. However, there is going to be a problem, because if I'm running all of this, we can see press a button. However, if I keep on pressing a button, I keep on typing in Sublime. The issue here is Sublime does not support input. For that, we would have to run this Python script inside of the PowerShell or the terminal. And how this is going to work, let me print the user input at the end so we can tell what's going on. And really importantly, do save the file. What I want to do now is to run this script inside of the PowerShell or the terminal. And let me put this on a separate screen. So here we have the PowerShell, and here I have the folder with my Python file that I have just created. And if you want to run this, what you have to do is you first have to type Python to run a Python command, and then you need the file path towards this folder here. Let me show my mouse actually. Inside of the terminal, you can add a ton of commands to navigate the folder structure. The thing is, that's kind of complicated and you don't need it. All you really have to do is to drag the file in there, and then you get the rest automatically. So this is all you really have to do. Just drag and drop the file. Don't forget the Python in the beginning, but other than that, all you have to do is press enter. And now you get press a button. Exactly what we have specified inside of the Python file. And now I can press, this is my input. And if I now press enter, I get, this is my input. And after that, the code finishes and we can add another kind of input. For example, we could add clear in here and we are done. And that's really how you run files inside of the PowerShell or in Windows in general. And welcome back. In this part, we are going to cover error handling. And well, for this part, we are going to handle some errors, which means obviously your code should not contain any errors because that would crash your program and that would be bad. The issue is sometimes you can't really avoid having some errors. For example, you might try to find a file and it just doesn't exist and you don't notice in advance. And as a consequence, you want to have the ability to anticipate and deal with errors. And fortunately, Python can deal with that quite easily. There are quite a few different ways to do it actually. And let's jump straight into the code and let's have a look at all of this. Alrighty, here we have an empty Python file and let's just create an error just to get started. I want to print 1 divided by 0. And if I run this, we are going to get an error. We have a 0 division error that we are dividing by 0, and this is not allowed because math doesn't like it. So what could we do to overcome this? Or rather, how can we make Python try some code snippet and then do something else if we get an error? And well, the command is literally called try. And this works kind of like an if statement, except without any arguments. We're just telling Python, try this line of code here. If it works, cool. If not, we want to do something else. And the else here is called except. And inside of that, I can print something else. Let's literally write something else. And now if I run this, we get something else. What happened here is that Python first went with try, and the code in there was this print statement. And this print statement included the operation 1 divided by 0, which is not possible. As a consequence, this here gave us an error. And because of that, we are going to accept, and inside of that, we are printing something else. And this is what we got in the end as well. If I had valid code inside of the try statement, let's say 1 divided by 1, we would get the result of this line of code here, and except would not be run. And that is the easiest way to deal with errors in Python. However, we can both be more specific and we can add more things towards this. And let's be more specific first. And that is, for this except statement, we can specify specific errors that we are looking for. For example, what we are looking for right now is a 0 division error. And if I run this, we are getting the same outcome. However, now, if I add another print statement and I print a variable that doesn't exist yet, which, if I run this, is giving us another kind of error, specifically a name error. And we are right now only dealing with 0 division errors. So when Python sees a name error, it doesn't know what to do with it. But, well, we can account for it by adding another except statement. And now we want to look for a name error. And if that is the case, I want to print, let's say, does not exist. And now if I run this, we get does not exist. And be aware what happens here. Python starts all the way at the top with try. And then it goes through these lines of code here, and we are starting with print A. And this one doesn't exist. And as a consequence, none of the stuff below is executed, and we jump immediately to this name error. And in there, we are printing does not exist, which is what we are getting down here. Now, one important thing you may have noticed is that, let me actually get rid of it, this print here, which should have given us this except statement, is not being printed down here in the console, meaning that this here wasn't even executed. It's really important to understand, as soon as try finds any error, any code after that is not being executed. Which is why we only ever get one except statement, or the result of one except statement to be more specific. And if you happen to be interested in all the possible errors that could happen in Python, there is a whole documentation online. And in here, you can find, for example, arithmetic error, buffer error, lookup error, assertion error, lots of different things that could be raised. So if you are looking for some specific errors that could come up, this list here would be really useful. What you want to look for is built-in exceptions. There are two more things that we can do. One is else, and the other is finally. And let's start with else. That one is, well, it's basically an else statement that you should know from the if statement. Let's say in here, I can just print, let's say, the else statement. And if I run this right now, this else statement is not run because we do have an error, this name error here specifically. But if I run some code in here that does exist, let's say print try. If I run this now, we get the code inside of the try statement, and we are getting the else statement as well. But the else statement is only run if the try statement doesn't have an error. The way you have to think about it is that this else is an else to these except statements. And finally, we have, well, finally. And finally runs whenever all of this stuff finished, and it runs either way. Doesn't matter if we have an exception or not. Let me print finally. And if I run this now, we get finally again. And this is going to happen. Let me run the zero division error again. This finally even comes when we have this division error here. I guess I should rename these things a bit more properly. You cannot divide by 0. And now let's run this again. This looks better. What is happening in the code right now? We first, number one, start with the try part up here. And inside of that, on this line here, we are getting an error, and this leads us to the exception error for zero division error. And in there, we are printing you cannot divide by 0, which is this part here, number 2. And finally, we are ending on finally, which is number 3. And this finally runs no matter what happens. And with that, we have covered how to handle exceptions. Although there's one really interesting topic, and that is you can raise your own error. Let me actually add comments here to make this example a bit clearer. This part here, what we covered so far, is anticipating errors, or to be more specific, exceptions. What we can also do is raising exceptions ourselves. And what I want to do in here for the example is I want to create a variable that must be a string. And for now, let's give it a string. Let's call it test string. It really doesn't matter what the string here is. And now what I want to do is to run an if statement. that if this variable contains a string, I want to continue as normal. If that is not the case, I want to raise an exception, or well, call an error, same thing. And for that, we first of all need an if statement. And to check the type of a variable, we need isInstance. And in here, I want to check my var must be string, and the second argument is the string type, or the type we want to look for, which in my case is string. And if that is the case, the variable is all good, and let's say I want to print must be string. And let me comment out the earlier part and run this code. And this is working indeed, because var must be string is a string indeed, or it contains a string. However, now, if that is not the case, I want to raise an error. And this you do with raise, and then the type of error you want to raise. In my case, I want a type error. And in here, I can add a message as well as the argument. And in my case, I want to write must be a string. If I run the code now, nothing happens. However, if I change this string to something else, let's say an empty list, now I get a type error must be a string. And that way, with raise, you can create your own errors to your heart's content. And along those lines, there's another thing you can do to raise an exception. And that is called assert. And assert basically means that you want to make sure that your code only runs if a certain condition is true. Think of assert as a stronger if statement, that if this condition is false, your entire code stops with an error. For example, what you could do in here, let's do a simpler variable, a is 5. And a always has to be 5. If a is not 5, I want to end all of the code immediately. And this I do with assert. And in here, I can just look for any kind of Boolean statement, meaning a is equal to 5. And if I, let me comment this part out, if I run this now, we get nothing. However, if I change the value of a to 6, we are getting an assertion error. And that is caused by this line here. And sometimes in your code, you really want to make sure that a certain condition is true. Especially if you work with something more security concerned, this is something you really want to be using extensively. But, well, with that, let me uncomment all of this here as well. If you understand these three parts, you basically know all you ever need to know about error handling. It doesn't get that much more complicated. And that means we can do an exercise and then call it a day. And what I want you guys to do is to create a list and then try to raise an index error. And obviously account for this error as well and type some kind of message with the print statement. Also try to use else and finally and see how far you get. You might have to do some research online to find what an index error is. Although I think it makes sense what it might be. Just try to guess. Let me start by creating my list. And in here, I want a list with 1, 2, 3, 4, and 5. The content really doesn't matter. And an index error basically means that you are trying to get an index that doesn't exist. For example, I could get my list and then get the index 99, which does not exist. I am getting a type error, and the type error comes from here. Let me comment out all of the earlier stuff so we can focus on one thing. Now let's try this again. And now we're getting an index error. And that is what I want to account for. Let me cut this one out. And instead, I want to go with try. And in here, I want to get my list 99, which I know does not exist right now. So I want to run an except, and I want to look for my index error. And if that is the case, I want to print that index does not exist. And if I run this now, we get that index does not exist and no error message anymore. I guess with that, we have covered the first two parts of the assignment. Besides that, I also want an else and finally. let's start with else. And in here, I just want to print that index exists. Let's try it. If I run it by itself, we are getting that index does not exist, meaning this line here. And we don't see else because else is only run if there's no index error. So let's try to get the first index and let me print this one as well. Now we get 2 and that index exists, which is this print statement here and this else statement. And well, finally, we need finally. And in here, I just want to print finished. And this one is the easiest. It always runs. We get finished either way if this is working or if it is not working. And with that, we have covered error messages. It really is a fairly simple topic and quite easy to cover in Python. The main thing I suppose you have to learn is all the different types of exceptions that you can have. But if you play around with this a bit, it's getting quite natural. So we are done with this one. Hello there! In this tutorial, we are going to cover decorators, which are a somewhat more advanced topic in Python. So let's go over some theory first. In the most basic sense, decorators are functions that decorate other functions, which does sound a bit cryptic, but essentially what we do is we are wrapping one function around another function. And let's do this a bit more visually to illustrate what's happening. This is a normal function, and usually what you do is you just call it somewhere and then you have something happening. What decorators do is we still have the normal function, but now we are putting another function around it. And then when we are calling all of this, we are calling the decorator function, and inside of that decorator function, we are calling the original function. And this is allowing us to execute code before and after the function. So when I'm calling this function here, I could run code here and I could run code here without making any changes to the original function. This function here would stay exactly the same. All the actual logic happens inside of the decorator. We are literally putting one function inside of another function, and this other function executes extra code. That's the entire idea of a decorator. Now, why would you want to do this? Basically, this way we can give extra functionality to a function without changing it. A simple example here is we could write a decorator for a function and it makes the function execute twice when called. Not the most useful function, but we are going to talk some more useful examples later on. I just want to illustrate what is happening. Now, in practice, you are seeing decorators in 3 different circumstances. Let's go over them. The most common one is you want to test your code without changing it. Let's say you work in a team, you have some really complicated code, and you want to test your code without making too many changes. A decorator would be excellent for that. The other example would be you are working in a team and you want to avoid making unnecessary changes. Now, those 2 points are pretty similar. You basically want to do something with your code without making too many changes. And both of these are also fairly advanced. If you are just learning Python, you are quite far away from either of these, which is why you may be struggling with decorators because you don't really need them. However, there is a third case that you probably are going to use, and that is using a decorator inside of a class, because this allows you to run code when an attribute is accessed or changed. So for example, let's say you have a monster with health, and every time that health is changed, you want to run some other function inside of the monster. With a decorator, doing this is fairly easy. Although, that being said, decorators can be quite hard, especially for beginners, because we are going to use some more advanced functionalities in Python that may be slightly confusing. Although, I would really recommend you to try to follow along, because this is going to be really good practice to understand functions and how to pass them around. In fact, before we start with decorators, we need to recap functions itself. So let's have a look at that. Here we have a completely empty sheet of code. And let's just get started with a really basic function. I want to define Let's call it func. There are no arguments. And inside of this function, I just want to print function. Just about the easiest function you can write. If I call this function, I get function. So this really doesn't do all that much. Now there's a really important concept you have to understand, that right now we are calling the function here. And if we didn't do that, so if I remove those brackets, I could run this and nothing would happen. But what I could do is print the function itself. And now I get a function object, meaning this function here as the whole function, not what's being returned, just the function itself. And this is just going to be an object. If that doesn't tell you anything, check out my videos on object-oriented programming. They should be quite helpful. But basically, what this func is giving us is a simple object that we can call. And if we don't call it, we are just getting a function object. Still not particularly useful. But what we can do with this function object is pass it around like any other object, like an integer, like a string, like basically any other object. We can pass it around. For example, what we can do, I can create another function, and this, let's call it a wrapper. Because this one is supposed to take the argument of the function, and then I want to execute the function itself. Meaning what I can do now, I can call my wrapper function and run this, and I get function again. And what is happening in here? I am calling this wrapper and I'm passing in this function here. What happens as a consequence is this function is being passed as a parameter into the wrapper function, and inside of that function, we are calling this function. And when we are calling it, we are printing the word function. And now that we have that, we could also do something like print hello and print goodbye. And if I run this now, we are running the function inside of another function, and before and after we are calling it, we are running some other code. And this is basically the main idea of a decorator, although it does get a bit more complicated. But we'll come to that in just a bit. Now, there's one more thing that you can do inside of a function, and that is you can create a whole new function. So, for example, let me create another function. And let's call this one a function generator. And then here we have no arguments to keep it simple. And now inside of this function generator, I want to create a new function. And let's call this one new function, I guess is a good word. And in here, I just want to print new function. And since this new function is just going to be an object, we can return the new function. And what I can do with that, I can create a variable, let's call it new function, and I want to get my function generator, and if I run this, we can't see anything. But now this new function is going to have this new function in here. Meaning what I can do, I can call my new function, execute it, and we get new function. So just to go over this, because it may be a bit confusing, this new function executes this one here. And what we are getting from this function generator is we are defining a new function, this one here. And at the end of the function, we are returning this new function. And this we are capturing inside of this new function variable. And this new function variable now is just a function, meaning we can call it here. And when we are calling it, we are getting this print statement. That's really all that's happening here. The main thing you have to understand is we are basically passing around functions with the return statement. With that, we have some function basics, so now we can actually start working on the decorator. And for that, let me open up a new file. And in here, I want to create an actual decorator. Now, first of all, for a decorator, we are going to need a basic function we want to decorate. So from my function basics, I want to copy this basic function here, which is just printing function by itself. So if I run this, we get function. Literally the easiest function you can write, more or less. And now for this function, I want to create a decorator. And this is going to be another function that you can give whatever name you want. Let's say I want to call this one decorator to keep things simple. And this decorator is going to accept one parameter, which is going to be a function. So in just a bit, we're going to pass this function inside of this decorator. What we are going to do with that, inside of this function, we are going to create another function. And let's call this one the wrapper. And this one right now doesn't have any arguments. But now inside of this function, I want to run the original function. And besides that, I can do quite a few other things. For example, I could just print the decoration begins, and let me write this properly. And I can also write the decoration ends. And now after I have done that, I can return this wrapper. And now what I can do, I can create my new function. And this is going to be my decorator. And inside of this decorator, I want to pass in my function. And once I have that, I can just call my new function, and I get the decorator begins, the function, and the decorator ends. What is happening here? Let me go over this. This is probably a bit confusing. We are starting with our basic function. And this function we are passing in here into the decorator function. And this is the one we have up here. And inside of this decorator function, we are creating a whole new function, this bit here. And inside of this function, we are calling the original function, meaning this one here. And then around this function, we are doing some other stuff, like we are printing these two statements here. And then at the end of all of this, we are returning this new function, and this new function we are storing in the new function variable. And then we can just call it like any other function, and now we have extra functionality around our original function. Now, where this becomes really interesting is, let's say, somewhere later in the course, I am running function by itself, which would just give me the word function. Let me comment out these two lines here. If I just run func, I get function and nothing else. And what I can do with decorators, if I uncomment those two lines and get rid of this new func, when I create the variable name for this, I can just call it the same way like I have called the original function. So I can call both func. If I do that and run the code again, I now have a new functionality for this function, because we are essentially overwriting the original function name, and that way our function, even with the same name, has new functionality. And this is the basic idea of a decorator. If we have this kind of system, we can have really complex code and still check our function without making any changes to the code. And since this is a reasonable common operation, Python has a shorthand for it. And let me comment out this statement here. And the shorthand looks like this. I first write an add and then the decorator function. So in this case, decorator. And now if I run all of this again, we are seeing the same outcome. For the simple reason, let me uncomment it, that this statement here and this line here, they are doing essentially the same thing. We are wrapping this function here inside of a decorator, this one here. And let's go over this a bit more slowly. I think that's going to be useful. Here we have the function you have just seen. And you can wrap this in the traditional way by writing the function, and then we are putting the function inside of the decorator, and then we are calling the function. I hope this is making sense. If you're confused about this, I would recommend to pause the video now and just go over all of these different statements and see how they connect. I guess I can go over it as well. Again, we have this decorator here, and inside of this decorator, we are passing in the function. And then we get this function here as a parameter. Now, inside of this function, we are creating a whole new function. And this one is called wrapper. And only inside of this function, we are calling the original function, this one here. And then around this function, we can do whatever we want, like calling these two print statements here. We could also do lots of other things. I'm going to cover that in just a second. And finally, at the end, what we are doing is we are returning this wrapper function. And this wrapper function, we are storing right now in func, and then we can call it like any other function. And that way, we're using the name of the function and overwrite it with this new function that is being wrapped inside of the function. Which means if I took out this line here, the function would come back to its original functionality and just print function. Now the problem with that approach is that we are writing func 3 times, 1, 2, and 3, and if we want to call it a 4th time, which is kind of annoying. So what Python developers have done is to create a shorthand for this, and this is called a decorator. And this one is looking like this. And basically this line here, where we have the name of the function, a decorator, and then the function as an argument, is the same as this add decorator. Those two lines are doing the exact same thing. Meaning when you are calling this function, you have the same result. Now obviously just printing 2 more statements isn't particularly useful. So let's actually do something more relevant to see why decorators can be useful. Here we are back in the code, and I want to create another decorator. And this one I want to call the duration decorator. And then here, again, as a parameter, we need the function. And inside of that, I want to create a wrapper. Doesn't need any arguments. And in here, first of all, I want to execute my function and then return the wrapper. And this is essentially a decorator that doesn't do anything right now. And what I want to do with it is to measure how long it takes to execute this function here. And for that to work, we need the time module, meaning I want to import time. And now what I want to do inside of this decorator, I want to get my start time, and this I would get with time.time. And this has to run before I call the function. And after I have called the function, I want to get my duration, and my duration is my time.time, which is my current time. And from that, I want to subtract my start time. And once I have that, I can print, let's call it duration, and this should be an f string with the duration. And now, just to get some reasonable numbers in here, when I am calling the original function, I want to call time.sleep and make it sleep for 1 second. And now, with this duration decorator, let me actually call it, so duration decorator. I can now comment out this line here, and now if I run the code, we get function, and we get the actual duration. And from this line, we know it took 1 point, a tiny amount of time to execute all of this. And this now we could get without making any changes anywhere else in the code. We're just calling the function here, we have the wrapper up here, and then we're adding this 1 line of code to add some debugging functionality. So this is something you could be doing if your code is running very slow and you want to identify what is slowing it down. Now, another thing that I haven't covered yet is that you can combine different decorators. And this happens by just adding them with the different add statements on top of each other. And we already have another decorator. So let me call this original decorator, and let's run all of this again. And now let me go through them. I have decorator begins and decorator ends. That is what we are getting up here from this original decorator. Besides that, we have the duration of the decorator. And this is what we are getting from this print statement here. And the actual function, so this print here, is this line. Meaning now, even though we have a very simple function, by using decorators, we can give it a ton more extra functionality without making any changes to it. Which is, well, the entire idea of a decorator. If you understand this, it can be really useful in very specific circumstances. Although, if you are a beginner, you probably just are going to add more stuff to this function. Although, well, if you know decorators, you don't have to. And this makes it much cleaner to work with your functions. But alright, let's do another exercise on this. I want you guys to create another decorator that calls a function twice. And this decorator should be called with this decorator and this decorator as well, so that this function has 3 decorators in total. And let's see how far you get. Again, I have to create another function, and let's call it the double decorator. And in here, once more, we need a function, and inside of this function, I want to create a wrapper. Doesn't need any arguments again. And now in here, I want to call my function twice, which I just do by calling my function twice. It's very simple once it comes down to it. And once I have that, I want to return the wrapper once more. Oh, and by the way, I'm just calling this wrapper because I think it makes sense. You could call this whatever you want, there's no naming restriction. And alright, now what I can do, I can add another decorator with the double decorator. And now if I run all of this, we have to wait a second. And if I expand this, we have the code being executed once and then twice. And well, this is working really nicely. And here again, our actual function is really simple. And we are just adding more and more stuff to it. And that way it gets more and more complex. With that, we have some very basic decorators. Now, there are some more things we can do with them. And what I want to cover for this part is that you can have functions with parameters being decorated. That part is actually really simple. And besides that, decorators themselves can also have parameters. Although implementing this gets even more complicated because we are wrapping a function inside of a function inside of another function. So this we will have to explore in quite some more detail. But let's have a look at all of this. Here I am back in a completely empty sheet of code, and I want to create a new function. So define function, and now I want to have a function parameter. Doesn't really matter what it is, and in my case, I am just going to print that function parameter. And now once we have that, I can call this function with whatever I want. Let's say hello, and if I run this, I get hello. A super simple function. And to decorate this, we kind of need the same thing we have done here. It's not really that much more complicated. As a matter of fact, let me actually copy this decorator here and paste it in here. And now I want to decorate this function with the decorator. And just as a reminder, this would be the same thing as calling function is the decorator with the function. However, now if I call this, I am getting the decorator takes 0 positional arguments, but 1 was given. And this happens in this one as well as in this one. So we're getting the same error message. That's usually a good sign at the very least. The problem Python has is that this function needs this parameter. So when we are calling the function up here, we again need the parameter. But on top of that, when we call this function here, we are calling this wrapper. And right now, when we are calling hello, we are passing it essentially into this parameter here, which doesn't exist yet, which is why Python is so unhappy. And to get around this, we just have to create the parameters, meaning this wrapper here and this function need the same parameters. Or well, for this wrapper, it's a parameter. For this function, it's an argument. And let me name them properly here. I want to have a wrapper parameter. And now if I run all of this again, we should see a different error message. And that is that func is missing one required positional argument, func parameter, meaning this one here. And well, I get this argument from the wrapper parameter. So now if I run this, we get hello. And if I change this argument to something, this is still working. And we could also do this the other way, the more traditional way, and we will get the same outcome. And let me just go over what is happening here by using the traditional style to make it a bit easier to explain. We are again calling this decorator function here and passing in the function itself. Now, inside of this decorator, we are creating all of this here. And right now, the wrapper has one parameter, the wrapper parameter. And then inside of this wrapper function, we are calling whatever code we want. And we also have the original function here. And then we are passing the wrapper parameter as an argument inside of this function. And once we have all of that, at the end of the code, we can just call the function with something, and then this something would be passed into the parameter for the wrapper, and then this would be passed into the original function. Now, what you see very often, for the wrapper, you don't have one specific argument. Instead, people very often just add args with a star and then double quarks. And then this you pass into whatever original function you have. So if I run this, we get the same outcome. And these are very simple unpacking operators. This one is for a list, and this one is for a dictionary or keywords. And the reason why these are used is because they allow for this decorator to accept basically any kind of function with any kind of parameter. Right now, we only have one parameter, but we could also have more named parameters and an unlimited amount of arguments. It doesn't really matter. If you have this setup, you can accept any number of arguments or named arguments, which means that this decorator works with literally any function without limitation. And all right, with that, we have basic parameters. What we can also do, let me uncomment the decorator. Let's try if this is working. It does. What we can also do is create a decorator that is accepting other arguments, like a 10, for example. But for that to work, we need something even more complex. So let's do this in a separate file. All right, and here once more, we have an incredibly simple function. If I call this function, we can see function. And now what I want to do. I want to create another decorator, and let's call this one a repetition decorator. And this one should accept one argument by how many times I want to repeat this function here. For example, if I add a 5 in here, I want to repeat this code 5 times when it's being called. Or rather, I want to call it 5 times when it is being called. Now, for that to work, we need some pretty extensive setup. And let me go through how this would look like. I am first going to create the actual decorator, so a repetition decorator. But this one is not going to accept a function. Instead, it is going to accept this argument here. So in my case, I want to call this the repetitions. And now inside of this, I am creating another function, and this is the actual decorator. And this decorator is going to accept a function. And now inside of this decorator, I want to create the actual wrapper. And this one, in my case, has no arguments. And what I want to do is for, let's call it R in range repetitions, I want to run my function. And now what I have to do, I have to, inside of the decorator, I want to return the wrapper. And then inside of the scope of this repetition decorator, I want to return the actual decorator. And now if I run this, it is going to work 5 times. and I can change this to a 20, and we will call this function 20 times. Now the question is, why does this work? So let's go over it, and let's do this in a traditional way, which I guess I haven't done yet. But if we didn't use decorators and still wanted to use this, it would look like this. I'm still using my func variable name, and now I want to call the repetition decorator. And now for this repetition decorator, I have to specify how many repetitions I want. Let's say 4 in this case. And after I have that, I am calling whatever I get from this and passing in my function. And if I run this, we get function 4 times. Now, if you look at this, this is probably really confusing. But to understand this, you basically have to understand the return statement. And let's go through it one by one. First of all, we are calling the repetition decorator and passing in 4. That is this line of code here. And this one by itself doesn't actually do all that much. All we are doing is creating a new function and returning it. So all we are getting from this repetition decorator with a 4 is this decorator here, a new function. Meaning this decorator here is going to replace the entire decorator we have seen so far. And on this new decorator, we are calling the new function, this one here. Meaning now we are passing this function inside of here, and this function is being captured inside of this parameter. And once we have that, we are basically back to a normal decorator. So inside of this decorator, we have a wrapper, and this one just loops over the range of repetitions that we get from up here. And then inside of that, we are calling the function, and then we are returning the wrapper. And then this wrapper is being stored inside of the function, and we can call this function, and then we are repeating it by whatever we specified in here. And well, if I comment this out again and return to my decorator, let's add a 4 in here, and we still get 4 repetitions. And I would really recommend you to practice this in your own time. Although if you're just starting, don't worry too much about it. Just get used to functions and classes by themselves, and once you are a bit more comfortable, start working on decorators. They are definitely one of the more advanced topics in Python. Although there is going to be another section, and this is where you are probably going to use decorators the most as a beginner. And that is to use decorators inside of classes. So let's talk about decorators inside of classes. And there's one really important one. It is called property. And what this allows us to do is it allows us to turn methods into attributes. And this is something we get from the property function that we can use inside of Python. It actually comes with Python. And I'm pretty sure all of this is going to sound really cryptic if I just explain it theoretically. So let's do all of this in code. That should be better. All right, here I have a completely empty Python file. And what I want to do is to create a new class. Let's call it generic. And in here, I want to create a Dunder init method. And this one needs self and nothing else. And what I want to do in here is create one attribute, let's call it x, and let's set a value for 10. It really doesn't matter what it is. And now I want to create an object from this class. Let's call it generic, and I just want my generic class. And now I can print generic.x, and I should get 10, and indeed I do. And now what I want to do is I want to observe this x here. Meaning whenever I look at it, so I retrieve the value, or when I change the value, I want to run some other code. And this by itself in Python isn't really that easy to do. I guess what you could be doing is run some kind of function that, let's call it getX, in here self, and in here I could return self.x, and then besides that I could print some other code, let's say getX. And now inside of this print statement, instead of x, I want to get x. And don't forget to call it. If I run this, I get x and the value. So when I get x, I can run some other code. And this is fine by itself, but it's not very elegant. And again, like we have seen with the other decorators, what happens if I already have a lot of code? Let's say I have this generic x 10 times in my code, and I don't want to change all of these instances here. I just want to change my class itself to account for that. That whenever we get x, I want to run some other code. And this we can do, but we need some special function in Python. And this function is called property. And into this property function, we can pass in a getter, a setter, and a deleter. And then we can assign all of this to one attribute inside of our class. Let's say x right now. And then this x is what we are actually going to work with. So now when we are calling generic x, this line here, this x refers to this x here. And then when we are just looking at this x, we are calling the getter method. When we are changing this x, we are calling setter. And when we are deleting this x, we are calling deleter. Meaning now what you usually see with this, the original attribute we have, this x here, we are turning into a private method with an underscore before it. And now to Python, this x here and this x are two separate variables. But I, as a programmer, still know that they're the same because of the naming convention here. And now basically what I'm going to do, for this getter, I am going to return underscore x. And with that, we have a getter. So this method here is going to be this getter. Meaning whenever we are calling this generic x, we are calling this getter method, which is then returning this underscore x. And essentially what we are doing here, outside of the class, we are working with x. And this is what we are accessing. But inside of the class, we are using underscore x. And this is what actually keeps track of the value. And now, basically what we have to do besides the getter, we also need a setter. So let me change it. And for the setter, we need self and a new value. And when we are calling this, let me run set x, and then self underscore x should be the value. And this we do not want to return. And finally, besides that, let me copy it one more time. I want to have a deleter. This one doesn't need a value. And what I want to do in here is delete x. And all we have to do for this one is to run del and self dot underscore x. And now I can run this. And let me make this a bit smaller. Now, when I print generic x, we get x and the value of x, meaning we have run this method here. What I can also do before I'm printing x, I can run generic x is equal to 4. And now if I run this, I am setting x and I'm getting x, and then I get the actual value of x. And finally, what I can do, I can also run delete and generic.x. And now if I run this, I have set x, get x, the value of x, and delete x. Meaning now, whenever I, for example, get the value of x, I can run whatever other code I want. And for example, what I could do with that, I could import from datetime, that's not how you spell that, from datetime import datetime. And I want to know whenever I get x, which I get by just printing the datetime.now. And now if I run this, I am getting the current time when I'm accessing x. And since we're just returning this underscore x, you could even make changes to whatever x you get, depending on the time of day, some other variables, basically anything you want to look at. Which is why all of this is really powerful. And I would recommend to go over this in your own time. It's really useful. But just to go over it really quickly again, I think that's going to be useful. When we are initiating this class, we have underscore x, this one here. And this is the variable we actually storing values in. Right now, that is 10, but it really doesn't matter what it is. Once we have that, we are running this line here, and this one turns x into a property. And this property has a getter, a setter, and a deleter. And those are referring to this getter here, this setter here, and this deleter. And now from outside of the class, whenever we are accessing this x here, we are running either of these methods. And these methods then influence self.x, which is where we actually store the value. So this one here. And that way, when we are accessing, changing, or deleting a value, we can run whatever other code we want in there. And I hope this is making sense. This is, again, something slightly more advanced that you probably want to practice on your own time. But what Python developers also realized is that this isn't exactly an elegant way of writing all of this. Which is why this property works really well as a decorator. And let me copy the entire class to implement this as a decorator. And let me comment out all of this. And basically, how you would implement all of this as a decorator. For the getter, you would simply add the add property decorator. Although then the getter, you would rename to the name of the property, which in my case is this one here. So I just want this to be x. Now for the setter, I want to get another decorator, and this one you would call with the name of the property, in my case again x, and now you would add .setter. And then the actual method would also be called x, or the name of the property. And finally, the same works for deleter, so we need x.deleter. And now the name of the method should also be the name of the property. So x in my case. And now once we have that, I can get rid of this property here. And now this code does the same as this code up here. Meaning if I run all of this, we get the exact same result, except now it's a bit easier to read, I suppose. And this is something you are going to see reasonably often, even as a beginner, because running some code when you're just changing a value, or even when you're just looking at the value, can be really powerful. So understanding this here, or at least being able to replicate it by yourself, is going to be something you do want to practice. But again, this is all very advanced, so if you're just learning Python and all of this is too much, don't worry about it. You are not going to use it for quite some time, and it would be much more valuable for you to understand classes and functions by themselves. So don't stress yourself if this is too much. But anyway, this is all you need to know to get started with decorators, and I hope that was helpful. In this video, we are going to cover eval and exec, which are two fairly special functions in Python. Let's talk about them. Both eval and exec are simply functions inside of Python. The thing that makes them special is that both of them translate strings into Python code. In practice, this would look something like this. If I'm running eval 1 + 1, this would return the operation 1 + 1, which would give me a 2. And notice here, this 1 + 1 originally was just a string, nothing else. And with eval, we are turning this string into an actual Python operation, which can be incredibly powerful. As a matter of fact, you could even create new variables from a string, which I guess very occasionally can be incredibly useful. And well, it overall gives you a ton of flexibility. However, there's something really important. And that is, you have to be extremely careful when using exec or eval, for the simple reason that if you handle these functions badly, it allows users to run their own code inside of your code. Which, if you, for example, run a database, might end up with them stealing all of your data. For example, you might have some kind of input field, and this field was originally designed to handle names from users. And then you use the eval or exec function to update this kind of name to make sure there are no typos or something like that. A user, instead of writing a name, could just add a ton of code and thereby accessing your database. And if that happens, you probably are going to be in a lot of trouble. So be really careful when you're using these functions. They can end up horribly wrong. But alright, before we jump into code, let's talk about the difference between the two. Eval is the simpler of the two functions. It only evaluates code, which means you can run functions or simple operations, but you cannot create new variables or run if statements or stuff like that. For that, you would need exec. This is the more powerful one, and it basically is capable of running any kind of code. And let's have a look at both. And let me start with eval. I need to type eval, and now in here, I can write any kind of simple statement. For example, 5 plus 10. And if I execute this, we don't get anything, because this only returns a value, it doesn't print it. Meaning, I have to put all of this inside of a print statement. If I run this now, we are getting 15. And we could even run some kind of code. For example, what I could be doing is create another string inside of the string with the different quotation marks, and let's call this one test. And on this test, I can call the upper method and run this now, and we are getting test. Essentially what happens is that Python just removes these quotation marks and then runs all of this as normal Python code. However, there are limitations, especially for eval. For example, what I couldn't do is print eval if true, then print, let's say, test. And if I run this, we are getting an error that we have invalid syntax. And the invalid syntax we are getting because if true, or an if statement in general, cannot be run inside of eval. For that, you would need exec. If I run this now, this is working just fine. And this is a more general theme, that in eval, we are quite limited in terms of what we can do. Another example would be, I couldn't assign a new value to a variable. So in eval, I couldn't do something like a equals 10. I would be getting a syntax error. However, if I use exec, this would work just fine. And after running this code, we have a variable a, meaning I can print a, and we get 10. The value of this 10 here. And that is the entire idea behind exec and eval. Now, most of the time, especially as a beginner, you are not going to use them whatsoever because there are certainly more advanced things. However, there's one good example that I think can be quite valuable. Let me copy in 4 lines of code. And I guess I can comment out the earlier stuff. What you're looking right now is I have my string, and this is just a string. And on this string, I'm running upper, title, lower, and casefold. Meaning if I run the code now, I get all of these results. The issue here now is we have 4 lines of code for something that is actually really, really simple. And using eval here could shorten all of this quite substantially. And this, I think, could actually be a really good exercise. Try to express these 4 lines here using an eval statement. And if you want a tip, this should happen inside of a for loop. Try to figure this one out yourself. I first of all have to convert upper, title, lower, and casefold into some kind of string. And in my case, let me just copy it. It is looking like this. And I want to cycle over this with a for loop, meaning I want to do for operation inside of this list. And now inside of this, I want to run my eval function. And in here, I need a string of my string. And on this, I want to run each of these operations. And this I would do with an f string. And inside of that, I want curly brackets and my operation. And importantly, we do want to call these functions, which means I want brackets. So for example, we are starting with upper, and this is going to be inserted in here for the operation, which means we are ending up with my string dot upper, and then we're adding brackets to actually call this method. And eval then basically removes the quotation marks and turns all of this into valid Python code. And the last thing we have to do is to actually print this so we can see the result. Let me add the print statement and comment out this earlier stuff. And if I execute this now, we get the very same result. And this may be a bit arguable, but I think this is much easier to read than these 4 lines here. But both approaches would be perfectly fine. And well, with that, we have eval and exec.